variety of DevOps tools that are commonly used to automate and streamline different aspects of the software development and deployment process in order to improve the speed and quality of the software releases. Hello everyone and welcome to this session. You are currently watching an Edureka DevOps Tools Full Course. By the end of this video, you will have an idea of the multiple DevOps tools that are currently in demand. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about DevOps after watching this session and wish to obtain Edureka's DevOps certification course, then please see the link in the description below. Now let's begin with our agenda, where we'll have a brief overview of what we will cover in this DevOps Tools Full Course video. We will start with the introduction to DevOps, where we will learn what DevOps is and why should we learn it. After which, we will see the DevOps lifecycle. Now it's time to get our hands dirty with some popular DevOps tools. We will start with Git, followed by Jenkins and Docker. After this, we will learn about Kubernetes, Puppet, and Ansible. Once this is done, we will then move ahead with Terraform, Prometheus, and Grafana. We will also see Selenium and Nagios. Now, after all this, we will head over to Azure DevOps and AWS DevOps. We will then compare Azure DevOps to AWS DevOps. We hope that this session assists you in getting jobs in the industry. In order to accomplish this, we will look at how a career in DevOps works with some essential DevOps interview questions with answers. So stick till the end. Now let's get started with our first topic, that is, what is DevOps?
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise.
Let's understand one major concept of DevOps, that is the DevOps lifecycle. So if you're into DevOps from quite some time now, you must have heard at least one of these DevOps phases, that is continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. So all of these phases that I just mentioned make up the DevOps lifecycle. The first phase is the continuous development phase. So this is the phase that involves planning and coding of the software. So the vision of the project is decided during the planning phase, and the developers begin developing the code for the application. There are no DevOps tools that are required for planning, but there are a number of tools for maintaining the code. The code can be written in any language, but it is mainly maintained by using version control tools. So here, maintaining the code is referred to as source code management. So some of the most popular version control tools are Git, SVN, Mercurial, CVS, etc. Also, tools like Ant, Maven, Gradle can be used in this phase for building or packaging the code into an executable file that can eventually be forwarded to any of the next phases. The next phase in the DevOps lifecycle is continuous testing. So this is the stage where the developed software is continuously tested for bugs. For continuous testing, automation testing tools like Selenium, TestNG, JUnit, etc. are used. So basically, the tools that I just mentioned right now allow quality assurances to test multiple code bases thoroughly in parallel to ensure there are no flaws in the functionality. So what automation testing does is it saves a lot of time, effort, and labor for executing the test instead of doing this manually, right? Also in this phase, Docker containers can be used for simulating the test environment. Selenium here does the automation testing and the reports are generated by TestNG. So this entire testing phase can be automated with the help of a continuous integration tool called Jenkins. We'll talk about Jenkins later on in the session. So now let me explain you this with an example. Suppose you've written a Selenium code in Java to test your application. Now what you can do is you can build this code using Ant or Maven, and once the code is built, it is tested for user acceptance testing. So this entire process can be automated using Jenkins. Besides that, the report generation is a very big plus point. The task of evaluating the test cases that failed in a test suite gets simpler. We can also schedule the execution of test cases at predefined times. Once the entire testing is done, the code is continuously integrated with the existing code. The third phase of this life cycle is continuous integration. So now this stage is the heart of the entire DevOps lifecycle. It is a software development practice in which the developers require to commit changes to the source code more frequently. This may be on a daily or a weekly basis. So every commit is then built, and this allows early detection of problems if they are present. Building code does not involve compilation, but it also includes code review, unit testing, integration testing, and packaging. The code that is supporting new functionality is continuously integrated with the existing code. Since there is continuous development of software, the updated code needs to be integrated continuously as well as smoothly with the systems to reflect changes to the end users. As I've already said in the previous slide, Jenkins is a very popular tool used in this phase. So whenever there is a change in the Git repository, Jenkins simply fetches the updated code and it prepares a build of that code, which is in an executable file. So once this entire build is performed, it is then forwarded to the test server or the production server. Now let's move on to the fourth phase of the cycle, that is the continuous deployment phase. So this is the stage where the code is deployed to the production servers. It is very important to ensure that the code is correctly deployed on all the servers. Now before moving on, let us understand a few things about configuration management and containerization tools. Now these set of tools help in achieving continuous deployment. Firstly, I will talk about configuration management. It is basically the act of establishing and maintaining consistency in an application's functional requirements and performance. So let me put this in simple words. It is the act of releasing deployments to servers, scheduling updates, and most importantly, keeping the configurations consistent across all the servers. Since the new code is deployed on a continuous basis, configuration management tools play an extremely important role in executing tasks quickly and frequently. Now, some popular tools that are used here are Puppet, Chef, SaltStack, and Ansible. Containerization tools also play an equally important role in the deployment stage. Docker is one of the most popular tools used for this purpose. Basically, these tools help produce consistency across development, test, staging, and production environments. Besides this, they also help in scaling up and scaling down of instances very swiftly. Basically, containerization tools help in maintaining consistency across the environments where the application is deployed, developed, and tested. Using these tools, there is no scope of errors or failures in the production environment as they package and replicate the same dependencies and packages used in the development or testing or staging environment. Basically, it makes your application easy to run on different computers. The next stage is the continuous monitoring stage. This is the last stage in the DevOps lifecycle. This is a very crucial stage where you continuously monitor the performance of your application. So here, vital information about the use of the software is recorded. This information is processed to recognize the proper functionality of the application. The system errors such as low memory, server not reachable, etc. are resolved in this phase. The root cause of any issue is determined in this phase. It also maintains security and availability of the services. Also, if there are any network issues, they are resolved in this phase. That is, it helps us automatically fix the problem as soon as they're detected. So now this practice involves the participation of the operations team who will monitor the user activity for bugs or any improper behavior of the system. The most popular tools used for this phase is Splunk, ELK Stack, Nagios, New Relic, and Sensui. So what these tools do is they help you monitor the application's performance and the servers very closely, and they also eventually enable you to check the health of the system proactively. Now, using these tools, they can also improve productivity and increase the reliability of the systems, which in turn reduces IT support costs. Any major issues, if found, are reported to the development team so that it can be fixed in the continuous development phase. This also leads to a faster resolution of the problems. The stages are carried out on loop continuously till you achieve the desired product quality. Therefore, almost all of the major IT companies have shifted to DevOps for building their products. Moving on, if you want to become a DevOps engineer or be a part of this ideology, it is extremely important for you to be familiar with some DevOps related tools. Today, I will be talking about 7 important DevOps tools. Now, before we understand the tools DevOps engineers use, it is important to understand containers. So, what are containers? Containers allow you to package your application and its dependencies together into one manifest that can be version controlled, allowing for easy replication of your application across developers on your team and machines in your cluster. This is exactly why container-based microservices architectures have profoundly changed the way development and operation teams test and deploy software. Containers really help companies modernize by making it easier to scale and deploy applications. But they have also introduced new challenges and complexity by creating an entirely new infrastructure ecosystem. IT companies are now deploying thousands of container instances daily, and that's a complexity of scale they have to manage. How do they do it? Here is where Kubernetes comes to the rescue. Kubernetes is a container management technology developed in Google to manage containerized applications in different kinds of environments, like physical, virtual, cloud infrastructure, etc. So it really is just an open source system which helps in creating and managing containerization of applications. Its container management responsibilities include container deployment, scaling and descaling of containers, and container load balancing. It is extremely important to remember that Kubernetes is not a containerization platform, it is a multi-container management solution. Now let's move on and discuss some of the features of Kubernetes. The first one is automated scheduling. So Kubernetes provides an advanced scheduler to launch containers on cluster nodes based on their resource requirements and other constraints, while not sacrificing availability. The second feature is self-healing capabilities. So Kubernetes allows you to replace and reschedule containers when nodes die. It also kills containers that do not respond to user-defined health checks and does not advertise them to clients until they are ready to serve. The third feature is automated rollouts and rollback. So what Kubernetes does is it rolls out changes to the application or its configuration while monitoring your application health to ensure it does not kill all your instances at the same time. So if something goes wrong with Kubernetes, you can simply roll back the change. The fourth feature is horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command, using a user interface or automatically based on CPU usage. Now let us understand the architecture. The Kubernetes architecture has two main components. The first one is the master node, the second one is the worker node. So the master node is responsible for the management of Kubernetes cluster. It is mainly the entry point for all administrative tasks. There can always be more than one master node in the cluster to check for fault tolerance. So there are a few components in the master node that I'd like to discuss. The first one is the API server. So here the API server is the entry point for all the REST commands used to control the cluster. The second one is the controller manager. It is a daemon that regulates the Kubernetes cluster and manages different non-terminating control loops. The third one is the scheduler. So the scheduler schedules the tasks to worker nodes. So what it really does is it stores the resource usage information for each worker node. The fourth one is the etcd. So the etcd is simple distributed consistent key value store. So what it mainly is used for is to share configuration and service discovery. Now that we know how the master nodes work, let's move on to the worker nodes. So these worker nodes contain all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. So the first component that I'll be talking about in this worker node is the Docker container. So Docker runs on each of the worker nodes and runs the configured pods. The second one is the kubelet. The kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. The third one is kube proxy. So kube proxy acts as a network proxy and a load balancer for a service on a single worker node. The fourth one is pods. So a pod is one or more containers that logically run together on nodes. With this, we come to the end of the first tool in DevOps tool. Let's move on to the second tool, that is Docker. So what is a Docker? Docker is simply a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. So each application here will run on a separate container and will have its own set of libraries and dependencies. It must be really convenient to move around these containers, right? So containers also ensures that there is a process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. Now, the quality assurance team need not install all the dependent software and applications to test the code, and this helps them save lots and lots of time and energy. This also ensures that the working environment is consistent across all the individuals involved in the process, starting from development to deployment. So here the number of systems can be scaled up easily and the code can be deployed on them effortlessly. There are some basic concepts of Docker you must be aware of. That is Docker file, Docker image, and Docker container. So a Docker image is created by the sequence of commands written in a file called Docker file. When this Docker file is executed using a Docker command, it results into a Docker image with a name. So finally, when this image is executed by Docker run command, it will by itself start whatever application or service it must start on its execution. So I hope Docker file, Docker images, and Docker containers are clear. We'll understand what is Docker Hub now. So Docker Hub is basically a cloud registry where you can find Docker images uploaded by different communities. Also, you can develop your own image and upload on Docker Hub, but first you need to create an account at Docker Hub. So let's move on and understand what a Docker engine is. So the Docker engine is the heart of the system. It is simply the application that is installed on your host machine. Basically, it works like a client-server application. It uses a server, which is a type of a long-running program called a daemon process. It also uses a command line interface client. And finally, it uses an REST API, which is used for communication between the CLI client and Docker daemon. As per the image, in a Linux operating system, there is a client which can be accessed from the terminal and a host which runs the daemon. We build our images and run containers by passing commands from the CLI client to the daemon. However, in the case of Windows or Mac, there is an additional toolbox component inside the Docker host. So this Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or your MacBook. So this toolbox installs Docker client, machine, Compose, which is only present in Mac, and VirtualBox. With this, we come to the end of Docker. We'll move on to the third tool of DevOps tools, that is Git. So Git is an extremely important tool for software developers. It is a free, open source, distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was created by Linus Torvalds in 2005 to develop Linux kernel. Git has the functionality, performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control DevOps tool. So Git is primarily used to manage a project comprising a set of code or text files that may change over time. Now, before we go further, let us take a step back to learn about version control systems and how Git came into existence. So version control is the management of changes to documents, computer programs, large websites, and other collection of information. There are basically two types of version control systems. The first one being centralized version control system. The second one is distributed version control system. So Git is a distributed version control system where every contributor, that is the user, has a local copy or clone of the main repository. What is a repository? A repository is simply a storage space for your project files. Here, everyone maintains a local repository of their own which contains all the files and metadata present in the main repository. So the local repository is usually on the local machine of the user. So every programmer maintains a local repository, which is actually the copy or clone of the central repository on their hard drive. The central repository may be present on a web hosting platform like GitHub. They can commit and update the local repository without any interference. They can also update their local repositories with new data from the central server by an operation called pull and affect changes to the main repository by an operation called push from the local repository. So I hope everyone understood how Git works. Now moving on, let us understand the role of Git in DevOps. So Git plays a very vital role when it comes to managing the code that the collaborators contribute to the shared repository. So this code is then extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to the production. Tools like Git enable communication between the development and the operations team. When you're developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators while making changes within the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. To succeed in DevOps, you need to have all of the communication in version control. Hence, Git plays a very vital role in succeeding at DevOps. Now let's move on to the next tool, that is Selenium. Selenium is one of the most widely used open source web user interface automation testing suite. It was originally developed by Jason Huggins in 2004 as an internal tool at ThoughtWorks. So Selenium supports automation across different browsers, platforms, and programming languages. So this tool can be easily deployed on platforms such as Windows, Linux, Solaris, and Macintosh. Moreover, it supports operating systems for mobile applications like Windows and Android. Selenium supports a wide variety of programming languages through the use of drivers specific to each language. Languages supported by Selenium include C#, Java, Perl, PHP, Python, and Ruby. Currently, Selenium WebDriver is the most popular with Java and C#. Selenium test scripts can be coded in any of the supported programming languages and can be run directly in most modern web browsers. Browsers supported by Selenium include Internet Explorer, Mozilla Firefox, Google Chrome, and Safari. So basically, it can be used to automate functional tests and can be integrated with automation test tools such as Maven, Jenkins, and Docker to achieve continuous testing. It can be also integrated with tools such as TestNG and JUnit for managing test cases and generating reports. So now moving on, what are the advantages of Selenium? Why should we choose Selenium? Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. There are many other reasons behind Selenium's ever-growing popularity. The first one is that test scripts can be written in any of the programming languages, that is Java, Python, C#, PHP, Ruby, Perl, .NET, etc. Tests can also be carried out in any of the operating systems, that is Windows, Mac, or Linux. Tests can also be carried out using any browser, that is Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. We've all discussed this in the previous slide. And the last use is that it can be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So in short, Selenium can be used for automated testing. Also, because it has cross-browsers compatibility, it is more preferred. And it also increases test coverage and reduces test execution time. Now moving on, let us understand an important concept in Selenium, that is the Selenium Grid. Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA. It was used in a combination with remote control to run tests on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on multiple machines. parallel execution is achieved with the help of hub node architecture. One machine will assume the role of hub and the others will be the nodes. Hub controls the test scripts running on various browsers inside various operating systems. Test scripts being executed on different nodes can be written in different programming languages. Grid is still in use and works with both WebDriver and remote control. So we'll be learning about the WebDriver in the next slide. However, maintaining a grid with all required browsers and operating systems is a very huge challenge. For this, there are multiple online platforms that provide an online Selenium grid that lets you access to run your Selenium automation scripts. For example, you can use Lambda Test. It has more than 2000 browser environments over which you can run your tests and truly automate cross-browser testing. Now let's understand what is Selenium WebDriver. Selenium WebDriver is a web-based automation testing framework that can test web pages initiated on various web browsers and various operating systems. In fact, you also have the freedom to write test scripts in different programming languages like Java, Perl, Python, etc. It is important to remember that Mozilla Firefox is Selenium WebDriver's default browser. Now, some benefits of Selenium WebDriver are that they support 7 programming languages, they test on various browsers, and they work on different operating systems. Also, it overcomes limitations of Selenium version 1, like file upload, download, pop-ups, and dialogues barrier. Now, let's move on to the next most important tool, that is Jenkins. Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most popular continuous integration tool. It is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is basically used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. So basically with Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. So this tool also achieves continuous integration with the help of plugins. Plugins are extremely important. It allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install that particular plugin for that tool. For example, Git, Maven to Project, Amazon EC2, HTML Publisher, etc. There are many advantages of Jenkins, and I'd want to discuss each one of them in detail. So the first one is it is an open source tool with a great community support. The second one is it is extremely easy to install. The next one is it has more than 1000 plugins to ease your work. Now, if a plugin does not exist, you can simply code it and share it with the community. The fourth advantage is it is free of cost. The last one is it is built with Java. Now, if you have been coding for some time now, you must be knowing that Java is portable to all the major platforms. So this gives an added advantage to Jenkins. So what makes Jenkins different from the other continuous integration tools? There are two reasons. The first one is adoption, the second one is plugins. So Jenkins is widespread with more than 147,000 active installations and over 1 million users around the world. The adoption of Jenkins is extremely high. The second one is that Jenkins is interconnected with well over 1,000 plugins that allow it to integrate with most of the development, testing, and deployment tools. So these two features, that is adoption and plugins, make it one of the best continuous integration tools currently available in the market. Now let's move on to the next tool of DevOps tools, that is Puppet. Today, the most mature tool for configuration management is Puppet. But I know you must be wondering why Puppet is so popular and what makes it unique when compared to other configuration management tools. Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So now let's understand the functions of Puppet. So the first one is it helps in defining distinct configurations for each and every host. And it also continuously checks and confirms whether the required configuration is in place and is not altered on the host. The second function is dynamic scaling up and scaling down of machines. The last one is it provides control over all your configured machines. So a centralized change gets propagated to all automatically. Puppet basically uses a master-slave architecture in which the master and slave communicate through a secure encrypted channel with the help of SSL. Now let's see this architecture in detail. So as you can see the diagram on the screen, the Puppet agent sends the facts to the Puppet master. Facts are basically key value data pair that represents some aspect of the slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine. Puppet Master uses the facts to compile a catalog that defines how the slave should be configured. Catalog is a document that describes the desired state for each resource that Puppet Master manages on a slave. Puppet slave reports back to the master indicating that the configuration is finally complete, which is visible in the Puppet dashboard. Now with this we come to the last tool of DevOps, Nagios. Nagios monitors your entire IT infrastructure to ensure systems, applications, servers, and business processes are functioning properly. It is an integral to the DevOps lifecycle. So it is basically used for continuously monitoring of systems, applications, servers, and business processes in a DevOps culture. So in the event of a failure, Nagios can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you don't really have to explain why an unseen infrastructure outage affects your organization's bottom line. Nagios runs on a server, usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The Nagios daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these result changes. Nagios also use plugins. So these are compiled executables or scripts that can be run from a command line to check the status or a host or a service. Nagios also uses the results from the plugins to determine the current status of the hosts and services on your network. Nagios is built on a server or agents architecture. Usually on a network, a Nagios server is running on a host, and plugins interact with local and all the remote hosts that need to be monitored. So these plugins will send information to the scheduler, which displays that in a graphical user interface. With this, we come to the end of DevOps tools. Let's move on to the next part of the session, that is DevOps automation. Automation is the crucial need for DevOps practices, and automating everything is the fundamental principle of DevOps. We discussed this initially in the session. Automation kickstarts from the code generation on the developer's machine until the code is pushed to the code, and after that to monitor the application and system in the production. Automating infrastructure setup and configurations, software deployment is the key highlight of DevOps practice. DevOps practice is dependent on automation to make deliveries over a few hours and make frequent deliveries across platforms. Automation in DevOps boosts speed, consistency, higher accuracy, reliability, and increases the number of deliveries. Automation in DevOps encapsulates everything right from the building, deploying, and monitoring. In large DevOps teams that maintain extensive, massive IT infrastructure, the tools can be classified into 6 categories. That is infrastructure automation, configuration management, deployment automation, performance management, log management, and monitoring. So for infrastructure automation, a great example is the Amazon Web Services. Being a cloud service, you don't really need to be physically present in the data center. They're easy to scale on demand, and there are no upfront hardware costs. It can also be configured to provide more servers based on traffic automatically. For the second one, Chef is a great example. Chef is a handy DevOps tool for achieving speed, scale, and consistency. It can be used to ease out complex tasks and perform configuration management. With the help of this tool, the DevOps team can avoid making changes across 10,000 servers. Rather, they need to make changes in one place, which is automatically reflected in other servers. For deployment automation, Jenkins is a great example. As we've already discussed before, It helps facilitate continuous integration and testing. It integrates project changes more efficiently by quickly finding issues as soon as builds are deployed. For the fourth one, that is performance management, Application Dynamic is a great example. It offers real-time performance monitoring. The data that is collected by this tool helps developers to debug whenever an issue occurs. The fifth one, that is for log management, Splunk is a great example. This DevOps tool solves issues such as storing, aggregating, and analyzing all logs in one place. So for the last one, that is monitoring, Nagios is a great example. It notifies people when infrastructure and related services go down. It is a tool for this purpose which helps the DevOps team to find and correct problems immediately.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later And it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license. So you don't need to purchase Git. It is absolutely free. And since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very, very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? Alright. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of Git operations. First of all, you have your git init command, which basically creates a new empty Git repository. Now this can be used to convert an existing unversioned project to a Git repository or initiate an absolute fresh Git repository. Now most other Git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing Git repository, which I already have here. Now what this does is it reinitialized my existing Git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty Git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It will rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels like your username and your user ID correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your Git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first, you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you. and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of a, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You're ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1 to 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only 1 file changed, only 1 insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now, if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now, if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now, what is git push? This is something we will cover later in this session. Now, understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, here you can see at the bottom, your original main, there is your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah. So that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local Git repository, you can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository, and it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username, and password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account, and with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now, the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created. When we create a new branch, it originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see 2 different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch. As you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch, Edureka images, into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There is also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log. But that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command SSH-keygen. and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system. That is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the number one contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, Let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it. Whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the 3 important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this Your Profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the Edit Profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka, and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the readme text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it, and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch, and you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name, of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my README text file. That's the only file currently in our repository. So we'll make the change in the README text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my README text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my README text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my README text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that we'll be adding to my README text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are 2 radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my README text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button and you can see that I made my first commit 23 minutes ago and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits, after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch, and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left-hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request, and I'm going to confirm my merge, update my readme text file. I'm happy with that. So I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch 1 branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch 1 branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now if I switch to my branch 1 branch, it has the exact piece of information. So the information that was present in my branch 1 branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
Let's focus on various Git commands. So we'll start with git init command. Now git init is basically to turn a directory into an empty Git repository. Now the first thing that you need a local repository to work with. For those of you who don't know what exactly local repository is, it is basically a private copy of the whole repository, of the whole shared repository that you have. And users can perform many operations with this repository, such as add file, remove file, rename file, move file. You can commit changes, and you can do a lot of things with your local repository. So the first command that we are going to discuss is basically the git init command, which will turn a directory into an empty Git repository. So for that, I'll open my virtual machine to show you practically. So guys, this is my virtual machine where I've installed Git. If you want to see the version of Git that you have installed, just type in here git -- version, and it is 2.7.2 in my case. Now let's go ahead and create the directory first. So I'm going to name my directory as Edureka -repository. Now I'm going to move into this directory. So I'll just type in here cd Edureka repo. So now I have a directory. I want to convert it into a local Git repository, which is very easy. All I have to do is type in git init, and here we go. So initialized empty Git repository in home Edureka repo.git. So let's go back to our slides again, and we'll see which command we are going to discuss next. Let's talk about git add now. So git add basically adds all the files to the staging area for Git. Now Git doesn't track each and every modified file. So whenever you do the commit operation, Git looks for the files present in the staging area. Only those files present in the staging area are considered for commit, and not all the modified files. So the first thing you need to do is put all the modified files, all the changes that you have done into the staging area. And then from staging area, you can go ahead and make a commit, right? So the first thing is to add your files to the staging area, which is pretty easy. All I have to do is type in git add and the file name. So let me just quickly open my virtual machine and I'll show you that. This is my virtual machine again, guys. And first, let me just create a file here. Let the name of my file be edureka.py. Yeah, let me just go ahead and type something in this .py file. So I'll just type in here a equal to 10, a small code, b equal to 20, and I'm going to print a plus b, pretty basic. Save it and go ahead and close it, right? Now what I need to do is add the changes that I've done into the staging area, right? So all I need to do is type in here git add and the name of the file, that is edureka.py. So I've successfully done that. If I want to add all the files to the staging area, then I can go ahead and type git add and a period, right? So this will add all the files that are there in my local repository to the staging area. So this was all about git add. Let me just quickly open my slides and we'll see which is the next command we are going to discuss. Now we are going to see the git commit command. So git commit basically records the changes made to the files in a local repository. So you have all the modified files in the staging area. So when you make a commit, it'll basically record the changes that you have made to the files in that local repository. And for easy reference, each commit has a unique ID. And it is a good practice to always give a commit message, right? So that helps you in understanding what change was done in this particular commit, right? So I'll just quickly open my virtual machine and I'll show you how you can commit changes to the local repository. This is my virtual machine again, guys. So I'm just going to type in here git commit -m and the commit message. So I'll just type in here first commit, right? So I've done that successfully. 2 files changed, 5 insertions, create mode 100644 edureka.py, right? So this is the log for it. Let me just clear the terminal and go back to my slides again. Let's talk about git status now. So git status returns the current state of the repository. Git status will return the current working branch. If a file is in staging area but not committed, it shows with git status. Or if there are no changes, it will return nothing to commit, working directory is clean, right? So let me just open my virtual machine again and I'll show you practically how this works. All right, so if I go ahead and type here git status, so it says on branch master, nothing to commit, working directory clean. So it gives me the name of my branch and what is there anything that we need to commit or something that is already there in the staging area, but I have not committed that. And the working directory is clean right now. So whatever changes that I've made in my file are there in the staging area, and from the staging area, I've made a commit as well, right? So let me just do one thing, make some changes in the file, add it to the staging area, but I won't commit it, right? So let's see what will be the status then. So for that, I'll create one more file. Let that be welcome.py. I'll edit this using gedit. You can use whatever editor you want. I'll just type in here print welcome to Edureka, close the parentheses, save it, and close it. Now I'm going to add this file to the staging area. So I'm just going to type in here git add. I can go ahead and type a period as well that will add all the files, or I can give the name of the file, that is welcome.py. Now if I type git status, let us see what will come. So it says new file welcome.py, changes to be committed, right? So these changes are present in the staging area, but I have not committed these changes. And it gives me the name of my branch as well. So I hope you have understood what exactly git status is. So I'll just quickly open my slides again and see which command we are going to discuss next. Let's talk about git config now. Now with git, there are many configurations and settings possible. So git config is basically how to assign these settings. Now, two important settings are username and user email address. These values set what email address and name commits will be from on a local computer. And it's very easy to do that. Let me just quickly open my VM and I'll show you there. Now there are two things. Either I can run the git config command globally, or I can run the git config command on the current repository settings. So let me show you how you can do it globally. So I'll just type in here git config -- global user dot name and the name of the user. So let it be Shubham. And now I can go ahead and add the email address as well. So I just need to type in here user.email, and I'll type the email address in the parentheses in the double quotes, right? So this is done. And this was done globally. Now, if I want to execute this on the current repository, what I'll type in git config. I won't use -- global. I will directly go ahead and type user.name. So let it be my name, SAURABH. And I'm going to add my email address as well, which is saurabh@edureka.co. Done, guys. It's that easy. Now let me quickly open my slides again and we'll see which command we are going to execute next. So we've seen how git config works. Let's discuss about git branching now. So the first question is, why do we need branch, right? So branches are used to create another line of development. And by default, Git has a master branch. So usually a branch is created to work on a new feature. So if you're working on a web application, you might want to work on the card service, right? So for that, you'll create a new feature branch or any name that you want to give to your branch. And once the feature is completed, it is merged back with the master branch and we delete the feature branch. And every branch is referenced by head, which points to the latest commit in the branch. Whenever you make a commit, head is updated with the latest commit. Let me just quickly open my virtual machine. And over there, we're going to see how to create a branch, how to delete a branch, how to rename, how to merge, and how to check out into a different branch. This is my virtual machine again, guys. And let me just tell you how you can see all the branches. So just type in here git branch and it will list all the branches that are already there. So there's only one master branch present right now. So let me just quickly go ahead and create a branch. See, there are two ways to create a branch. One way is to create a branch and then you can check into that branch. Another is you just want to create it, but you still want to be in your master branch or your current working branch. So for that, if you don't want to check in that branch, just type in here git branch and give a name to your branch. So let that be feature, right? And if I go ahead and type git branch now, I can see that there are two branches, master and feature, right? Now I can go ahead and delete this branch as well, but let me just quickly move into this branch first. So I'll just type in here git checkout and the name of my branch, that is feature. And this will point towards my feature branch. Now I'm in my feature branch, right? So let me just make some changes in the files that are there in my Edureka repo. So you can see that I have a couple of files, edureka.py and welcome.py. So let me just make some change in, let it be edureka.py, right? So I'll just quickly type in here gedit. Again, you can use whatever editor that you want. Edureka.py, and I'll just add one more variable here. Let that be 30, and I'll print one more value. that is C plus A plus B. Pretty basic. Save it and then go back. So in my feature branch, I have made changes to my edureka.py file, right? So what will be my next step is to add these changes, add the modified file in the staging area. So I'll just type in here git add and a period because I want all the changes that I made to my files should be there in the staging area. So git add and period will add all the files. Now I want to commit these changes. So I'll just type in here git commit -m and a message feature commit, right? So it is done now. I've done all the changes and I've added those changes to the staging area, and then finally I've made a commit as well. So it says 4 files changed, 10 insertions, create mode welcome.py, welcome.py. Let me just clear my terminal now. So if I want to merge my feature branch with the master branch now, first I need to check into my master branch. For that, I'll type in here git checkout master. Now it says switching to branch master from feature. Now I'm in my master branch. So now I'm going to type in here git merge feature, and here we go. So you can see that I've merged my feature branch with that of the master branch. It's that easy, guys. Let me clear my terminal now. So what I'll do, I'll quickly create one more branch and I'll show you again how these things are happening because there might be some confusion still. So I'll just show you again how to create a branch, how to check into that branch, how to make some changes in your local repository, add that to the staging area, make a commit, and then merge it with the master branch. So now what I'm going to do is I'm going to delete my feature branch because I've told you earlier as well, once I've merged all my changes to my master branch, there's no point in keeping my feature branch as of now. I delete that branch, and there are a couple of options to do that. The safest one is what I'm going to tell you, right? So I'll just quickly type in here git branch -d and the name of your branch, which in my case is feature. So it has deleted the branch feature. Now there's one more way to delete a branch. Instead of -d, you can just type in here git branch -d and then the name of the branch. But this is not the preferred option and it's not safe as well, because if you have some unmerged changes, then also it will delete the branch. Whereas if you type in here a lowercase d, it will show you an error that will say that you have some unmerged changes, right? So always prefer -d and then feature -d and then the name of the branch that you want to delete, right? So now I'm going to show you one more way to create a branch, which is called git checkout -b, and you can give the name to your branch, right? So probably I want to name my branch again as a new. Let the name of my branch be new. So git checkout -b new. So this will not only create a branch called new, but it will also check into that branch, right? So we have also switched to a new branch that is new. And over here also, if I want to make changes to my file, I can go ahead and do that. All I have to do is use any editor. Let me edit, say, welcome.py file. Welcome to Edureka. I forgot to close the quotation, so that's the change I'm going to do in this file, right? And then I'm going to git add period. Now git commit. I made a mistake there, so I'll just type in here git commit -m and let it be new, the name message. All right, so it is done now. Now what I'm going to do is I'm going to show you how to connect to a remote repository. So I have a remote repository, that GitHub account. I've created a repository there. So if I want to connect to that repository, what I need to do is I need to add that origin. So I'll just type in here git remote add origin and the SSH link that I will just show you where you can find it. So this is my GitHub account, guys, and this is my repository, that is Git commands. If I want to copy the SSH link, I can just go ahead, copy this and paste it here. So we have successfully added the origin. Now let me just clear my terminal. So we have connected our local repository with the GitHub account. So we have seen how branching works in Git. Let us move forward and we'll see how to work with remote repository. So over here, I've already told you how to add an origin, right? So git remote add origin. And what we did, we connected a local repository with a remote repository. So the Edureka -repo is my local repository and a remote repository I just showed you in my GitHub account. So we have already done this git remote add origin. So now we're going to see how to clone a remote repository. So to create a local working copy of an existing remote repository, we'll use git clone to copy and download the repository to a local computer. Cloning is the equivalent of git init when working with a remote repository. Git will create a directory locally with all the files in repository history. So I'll just open my virtual machine and I'll quickly show you how you can do that. Alright, so what I'm going to do is I'm first going to create one more directory. So let that be mkdir, and the name of the directory, let it be git-repo, right? And let's move into this git-repo repository. So the first thing I'm going to do is git clone and the SSH link. So SSH link, I've already shown you where you can find it in your GitHub account. Just type in here git clone and the remote repository URL, the SSH link that I was talking about. And let me show you how you can do that. And here we go. So it says cloning into Git commands. So let me see what are the files that are there now. So it says Git commands. Let me go to this Git commands. So here we have Edureka and README. And here also you can notice that we have Edureka and README. So I've successfully done that. Let me clear my terminal. And now I can go ahead and pull whatever changes I made to the file that is there in my GitHub account. So let me just show you how to do that. Suppose if I have a file Edureka, and let me just make some changes here. I'll just type in here, my name is Saurabh. So let it be like this. So let's commit changes. So yeah, now it'll be reflected in my repository. Now what I want is I want all the changes that have been made in my remote repository in my local machine. So for that, I'll just type in here git pull origin master, and here we go. So it says it has successfully done that. That means we have pulled all the files that were there in the report repository. So if I check, so I have here Edureka and readme.md files. So if I go ahead and type in gedit Edureka, let's see, all right, so I can see that the changes have been reflected. My name is Saurabh, which was something new that I added to my file. Right, so this was all about the pull operation. Now let us see how you can push changes to the remote repository. Right, so if I go ahead and make some changes, or if I create a file, let's say I create a file, touch git.py, let that be git1.py. Right, so if I make some changes to this particular file, I'll write here print I love Git, save it, close it, right? So now before we push to the remote repository, we need to add these changes to the staging area. We need to make a commit, and then only we can push it, right? So first thing, add the file name. So I'll just type in here git add. I can go ahead and type here if period. That will add all the changes made to the files in the staging area, all the files in the staging area, basically modified files. Or I can type the name of my file, which in my case is git1.py. So I'll just type in here git add git1.py. And now I'm going to commit the changes. So I'll just type in here git commit -m, give a message. So I'll just type in here remote, and it has done successfully. So now I can go ahead and push the changes to my remote repository. So I'll just type in here git push origin master, and here we go. So it says it is done successfully. Let us go back to our GitHub account and we'll see whether those changes are reflected there or not. So I'll just go ahead and run this, basically reload it. So you can see that git1.py file is added here, right? So let me just quickly go to the slides again and we'll see what all topics we have already covered. So we have seen how to perform git clone. We have seen how to pull changes from the remote repository to the local computer. We have seen how to push the local commits to the remote repository. Now let's talk about few advanced git commands. Focus on git stash, git log, git rebase, and git revert. So I'll quickly open my virtual machine and I will explain you there only. So guys, let's discuss about git stash first. So to save changes made when they are not in a state to commit them to a repository, you use git stash. This will store the work and give a clean working directory. If I have to give you an example, imagine when you're working on a new feature that's not complete, but an urgent bug needs attention. So that's when you can use git stash. Let me just quickly show you how you can use it. So the first thing I'm going to do is create a new file. So let the name of my file be stash.py, and I'm going to make some changes to the stash.py. I'll just type in here print stash is cool, save it, close it, and yeah. Now what I need to do is add this to the staging area. So I'll just type in here git add, and now let's see the git status. So my git status says that we have new file which are there in the staging area, that is stash.py, right? Changes to be committed. So these are the changes that I need to commit. So currently it is pretty dirty. So what I can do is I can put all the uncommitted changes to a stash. Let me show you how I can do that. Git stash -u. And here we go. Now go ahead and type git status. Nothing to do, working directory clean. So it has converted my dirty directory to a pretty clean one, right? So with the help of git stash, right? Now the modification stashed away by this command can be listed with git stash list. So I'll just type in here git stash list. Here we go. And if you want to inspect it, so you can just go ahead and type git stash and show. So you can inspect it here, right? Let me clear my terminal now. So now I'm done. I've fixed my bug, and now I'm ready to, work on what exactly I was doing before fixing that bug, right? So what I can do is I just want to type in here git stash apply, and here we go. And now if I type git status, you can see that I again got the dirty directory back. So guys, we have seen how git stash works. Now what I'm going to do, I'm going to show you how a git log and git revert works, right? So for that, I'll quickly create a new repository. So let me do that. I'll just type in here mkdir git-log. So let that be the name of my directory. And I'll go into that directory. Yeah. So now I'm going to initialize it. So I'm just going to type in here git init. It has been done. Now I will create few files here. Let that be edureka1.py. And I'll just type in here print master new technologies at Edureka. All right, save it and close it. Now I'm going to add it here, git add, and then finally commit it. -m, just give a message, and it is done now. So what I did, I created a directory, initialized it. Then what I did, I made a file inside that. In that file, I added that to my staging area. That file has been added to my staging area. And then finally, I made a commit, right? So till now, there is no problem. Now, if I type here git log, let me show you what comes. So you can see that when I type git log, there is a commit hash, right? There is a commit that has been made by author Shubham on this particular date and time, right? So this is what basically git log is. It shows the chronological commit history for a repository. This helps you give context and history for a repository. And it is available immediately on a recently cloned repository to see the history as well. Now I can provide parameters here as well. For example, I can type in here git log -before and give a date here, right? Similarly, I can tell the git log to show me the commits based on the author, right? So if I type in here git log -author and the name of the author, then it will show the logs based on the commit made by the author, right? Similarly, if I type in here -before, right, and give a date, so it will give me according to the date as well. So this is how git log works, guys. So now what I'm going to show you is how to revert to the previous commit, right? So for that, let me just make some changes to my file again. So the name of my file is edureka1.py. So I'll just type in here gedit edureka1.py. And I'll type in here one more print statement that says, don't just simply learn it, master it. Save it, close it. Now I'm going to add it to my staging area. And finally, I'm going to commit it. -m, last commit. All right. So this is done now. Now what I have to do is, suppose I have made some changes. I'm going to go back to the previous change, right? So I've made some change in my code. I've done the commit as well, but I want to go back to the previous commit, right? So for that, what we use git revert. So let me show you how you can do that. So in order to go back to the previous commit, what I have to do is just type in here git log -one line. This will give me one line. So this was my last commit. So I want to go back, right? So for that, I'm just going to type in here git revert. and the hash commit hash, and here we go. So it says that revert last commit. So it has already done that. Now, if I go ahead and check my edureka.1.py file, so it only says master new technologies at Edureka. So this is how you can even perform the revert operation just by using in the commit hash. So with that, you can go ahead and revert back to the previous commit. So I hope this is clear now. Let me clear my terminal. So now what I can do is I can go ahead and revert to the last commit as well. Instead of just typing the commit hash, if I just type in here git revert head, and if I quit, so it says that I've rolled back to the previous version of my file. So if I go ahead and click on ls command, and if I type in here cat edureka1.py, so I've gone back to don't just simply learn it, master it. So my last commit was basically revert operation, right? So whatever file changes that have been done after git revert will be reflected as a commit itself, right? So I hope you're getting my point. So what I did first, I created an empty repository. Then in that, I created a file edureka1.py, made a couple of changes, made 2 commits. Then I used git revert with the hash commit to go back to the previous commit, right? So with that, I got only master new technologies at Edureka. This one I didn't get at that time. Then what I did, I showed you git revert head, which will basically take the last commit, right? It'll revert the last commit. And the last commit was nothing but the revert operation that happened that actually made my file edureka1.py to go back to the previous version. So that was my last commit, right? So because of that, it has revert back to the last commit. This is why you can see that edureka1.py file has both master new technologies at Edureka and don't just simply learn it, master it. Right, so I hope I'm clear with git log and git revert. It's very easy, guys. There's not a lot of things to understand here. It's very basic. So let's talk about rebase now. So basically rebase is again one more way of combining the work between different branches. So what rebasing does, it will take a set of commits, copy them and store them outside your repository. The advantage of rebasing is that it can be used to make linear sequence of commits. All right, so the commit log or history of the repository stays clean if rebasing is done. Right, so let me just show you how it is done. If I just type in here git rebase master, let me just go ahead and do that, git rebase master. So the current master is up to date. That's what the message pops up. So basically this command will move all our work from current branch to the master branch. They look like as if they are developed sequentially, but they are developed parallelly. All right, so let me just give you a better example of this. So I'll just create a branch here, git branch, say Edureka 010 is the name of my branch. And yeah, so if I want to go to this branch, check out Edureka 010. I'm into that branch. And if I make changes to Edureka1.py, I'm going to remove this print statement, save it, close it, clean my terminal. And I'm going to add it, git add period, and git commit -m rebase. All right, so this is done now. And now what I can do is I can go ahead and type in here git rebase master. So it says that current branch Edureka 010 is up to date. So this is how you can perform rebasing. So let me quickly go back to my slides. So we have talked about git stash, we talked about git log, git rebase, and git revert.
Let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Jenkins is an open source automation server which helps to automate the process of development relating to testing, deployment, packaging, and others. It is a server-based system that runs on software Apache Tomcat. It supports VCS tools like Git, Bitbucket, and also support build automation tools like Apache, Maven, Ant. And it helps to make and facilitate our continuous integration and continuous delivery process. Jenkins was first released in the year 2011, and it's a completely open source software as part of the MIT license. Jenkins, guys, is a plugin based software. In Jenkins, you've got plugins which basically used to interact with different tools and components. In Jenkins, plugins are primary releases in languages other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. You can do compiling, you can do packaging, you can create some reports, you can do some logging. All those things are possible using plugins in Jenkins. Another important component that we talk about in Jenkins apart from plugin is Jenkins notification, which we also call as mailer. Using mailer, guys, we can do configure email notification for any results. You can configure a scenario, for example, you want mail notification when build is successful. All those things can be done using mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follows a typical master-slave topology. Now, why do we need a master-slave topology in a CI tool like Jenkins? When you work in an organization, we have got multiple teams which you want to build and deploy their own pipelines or deploy their own soft project codes. Teams don't want that their piece of code runs on a server which is owned by some other team. So what we can do is we can set up a master-slave topology where Jenkins may run on server X, but you can connect multiple other servers which will act as a slave. So when you're deploying a code, executing a pipeline, you can run those code on those XYZ servers. That is the beauty of using Jenkins master slave. Another good thing about Jenkins is Jenkins can be deployed on any operating system. You can run Jenkins on a Windows node, on a Linux node, on a Mac OS. Jenkins can be deployed on any operating system. And similarly, your Jenkins master slave can be of any OS. It is not at all dependent. Both master and slave need to be of the same operating system. Another important core component of Jenkins called as Java doc. This is sort of plugin in Jenkins, which basically is a part of Jenkins core, which helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using Java doc. Let's talk about security in Jenkins. Apart from that, Jenkins have other sort of authorization like project-based strategy, metrics-based authorization, which helps to make Jenkins more secure. We'll talk more about this when we talk about Jenkins overall. So as you can see from the diagram, Jenkins is pulling code from some source control system like Git Bitbucket. Jenkins try to deploy it. In Jenkins, we have got notification management system using Mailer, where if the build successful, we get a war file, a zip file. We can define how we want the build to be created. And if it is failure, send a notification management to a developer that something happened wrongly with the specific code lines and you need to rectify a code. That is the beauty of using Jenkins. So Jenkins, guys, is to the bread and butter in the industry. There are some Jenkins competitor also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI in the industry. Let's talk about what is a pipeline. So far, we talked about Jenkins. Now let's talk about what is pipeline in Jenkins. Now, let's say I want to deploy a code. The code may have certain steps. Like first step, I'm building the code. Second step, I'm compiling, then code reviewing, then packaging, then deploying. How do I automate or combine all these steps which can be executed in one go? To deploy all these scenarios, we create a delivery pipeline. Pipeline is nothing, guys. It's a combination of different steps or different tasks that we need to perform in order to deploy our code. Using a pipeline, instead of doing these tasks or code deployment manually, we combine them and deploy them as sort of a one common approach of a delivery pipeline. There are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from the scenario, are declarative approach, and the second one that is used in the industry is scripted approach. This particular example you're seeing is an example of a Jenkins pipeline script. Here you're seeing we're first doing a stage called build stage, where we're combining multiple tasks. Like first we're using Java, we're printing something called Echo Hello pipeline. Then we're using Maven as the build automation tool and trying to deploy a package. And then we are doing a shell script output of what all things are present in the particular directory structure. A typical example of syntax of how to create a pipeline in Jenkins. It's an example of a scripted pipeline. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Let's talk about what is scripted and declarative and how they're different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was very strict and traditional, while in declarative pipeline, we use something called as groovy syntax. When you use a declarative pipeline, you can get the code from any version system tool like Git and all. You create something called as Jenkins file, and you can download Jenkins file from a version system tool like Git, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as node block. But while in declarative pipeline, we define a code in pipeline block, as we have seen in the previous example. Now let's talk about what is Jenkins file and how it can be used. Jenkins file is nothing, guys. It's like a text file where you define your entire structure and syntax of your Jenkins. You don't need to download the file as in particular. You can just give the path of your Git repo. If it is in Git, credentials, a private repo, and it can pull all the contents from there and just execute your code. It is a modern day deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which helps us. Let's talk about this. First is code review and iteration. When you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before executed. How that works is, in Jenkins file is stored generally in a version control system tool like Git. You can put something called as PR pull request for your code review. Different members of your team can review the code before you actually pull the Jenkins file and deploy it. You can do an audit trail, or referred to as logging. You can log each and every step output that is being executed as part of your Jenkins file and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose logging. Then you can find a single place to store all your data or all your outputs. You no need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tool, and from there code can be downloaded and can work as a single source for your entire pipeline. Let's talk about Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always starts with the version control system, or you can say source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins try to pull the data from that source control system repository system. There is no mandatory or source code need to be Git. It can be Bitbucket, SVN, whatever your organization uses with. Using Jenkins server, we execute tasks like build, deploy, compiling, packaging, code review. All those things happen using Jenkins server, where your Jenkins actually installed or is running. Your Jenkins server can be any operating system. It can be Windows machine, a Linux machine, an Ubuntu machine. It can be any OS of today's modern world availability. Using this Jenkins server, we execute our different tasks and scenarios. In Jenkins server only, we use the mail functionality for the feedback mechanism. We will notify developers the commit or the code deployment successful, it is a failure, it has some challenges, what can be done using the feedback mechanism possible using the Jenkins server. Using Jenkins servers, we always first deploy the code on a lower lifecycle environment. That is a recommended standard practice. We first deploy on a QA server, on a testing server, and once the code deployment is successful on the lower lifecycle, then we go ahead and deploy the code on our production server. That is how the entire Jenkins workflow mainly particularly interacts first. Now guys, let's talk about Jenkins installation, how to install Jenkins in our lab. To give this example, we are going to use a CentOS machine as a reference to install and configure Jenkins. Jenkins by default runs on port 8080, the default port for running Jenkins. So please make sure that if you're using any cloud VMs or any VMs in your organization, that the port 8080 firewall settings are open and configured so that it can be accessible. Jenkins is a GUI based tool. 95% Jenkins job is completely GUI based. We hardly log into our servers Jenkins got installed or using a CLI command to manage or run Jenkins. It is completely run and managed using GUI, the graphical user interface, which comes when we install Jenkins. Another prerequisite to install Jenkins is Java need to be present in our machine. We need to make sure that Java is installed in our machine. So guys, let's go to our lab and see how to install Jenkins. So guys, as I mentioned, we're going to use a CentOS machine. So let's just double check. It's a CentOS VM. So we have got the CentOS VM where we are running CentOS 7. First thing, let's install Java. Install -y. You can install any version of Java. I'm installing 1.8.0. We can go for any version. So this completes my Java installation. Another good thing about Jenkins here is Jenkins has got detailed page published by Jenkins community where we can see how to use Jenkins installation for different types of operating system. If you go to jenkins.io/downloads, here you can see the installation step provided by Jenkins community to install Jenkins on different operating system. You have got the stable release and the release which is like beta release. You can select which release of Jenkins you want to use. I will go for the stable release, that is Jenkins 2.2.493.TA3. And since I'm going to use CentOS, I will click on the CentOS installation step for Jenkins. Just copy the steps mentioned here, how to install Jenkins, and paste it in your installation server. These are the RPM dependencies that are needed to install Jenkins. So I'm just deploying them on my server so that these dependencies are present before I install Jenkins. And now let's install Jenkins. Yum install -y Jenkins. Once your Jenkins software is installed, let's start the Jenkins service. Jenkins start. Let's validate the Jenkins service got started. So now we have got Jenkins up and running. A while back I mentioned Jenkins runs on port 8080. So let's get the public IP address of this machine. So the public IP address of the machine is 35.223.206.46. Let's copy this IP address and try to access Jenkins on port 8080. Firstly, when you install Jenkins, Jenkins for securely asks you to verify the Jenkins code. Just go to this path location and copy the code mentioned there on your Jenkins server. So I will go on the Jenkins server, install Jenkins. I will just cat this directory structure, and I will copy this Jenkins secret follow secret key, which we need to use to install Jenkins. Click on continue. If your key is valid, it will prompt the next page to install plugins. You get two options here. Either you can install the plugins recommended by Jenkins, or you can select your own plugins which you want to install. Here, I will select the install suggested plugins. This step may take a minute or so, since it will install a couple of plugins which are needed for Jenkins to properly function. So you can see, as like in the screen coming up, different plugins are getting installed in our Jenkins. So once your Jenkins installation is complete, it will ask you to create your first admin user. Okay, so let's give some username. I'll give username as Edureka. Give some password. You can give any password of your choice. So I will give some password here. Give some confirm password. Give the same password you give above. Some name. I will give the name as also Edureka, and some email address. Click on save and continue. So you got the base URL, and it's running on port 8080. Click on save and finish. Start using Jenkins. This is how your Jenkins home screen looks like when you configure Jenkins for the first time. Now let's talk about some Jenkins management. On the left side, you see a tab called Manage Jenkins. This is the place where we do the entire administration and management of your Jenkins. You can see you've got a plethora of options here like security, configuration, status information, tools and action, Jenkins CLI. Let's talk about all these tools in depth. Let's first talk about configure system. As the name implies, using configure system, you can configure and edit different Jenkins properties or Jenkins configuration settings. So for example, how many parallel tasks you want to execute at time? There's parallel executor. You can give 2, 3, whatever you want. If you want, you can change the port and specify the default admin address. You can create your own Jenkins email address from where your mail notification should go. Any global properties or variables you want to link are linked at this place called Jenkins configuration. Let's talk about something about Jenkins security. If you go to configure global security, here you see how we can configure security in Jenkins. There are multiple authorization modes you can use in Jenkins. In order to use this authorization strategy, you need to use an authentication strategy. The most common and most widely used is LDAP integration, where you basically integrate the organization's LDAP server with your Jenkins database. Once you've done that, you can use different authorization strategies which are used in Jenkins. The most predominant one used in the industry is project-based metrics authorization strategy. Now, what does this project-based metrics authorization strategy mean? Let's say you have created multiple jobs or pipelines in Jenkins. Now, all these jobs or pipelines belong to different teams in the organization. Using project-based metrics authorization strategy, we can restrict that specific job can only be accessed by team members of a specific group. It is not imperative that anyone who has access in Jenkins can run all the jobs or all the pipelines. Using project-based metrics authorization strategy, we can restrict that. Another one that is used is metrics-based security. Here you restrict the overall access of Jenkins. That means a user A can have admin rights, a user B can have read-only rights. What type of read rights you want to give, like agent-based read-only right, the full job rights, full view right, full source code management right, all those things can be done using metrics-based security strategy. Some of the traditional ways which are not being used so frequently in the industry are anyone can do anything. That means anyone who has access to Jenkins is like full admin. Another one that is being not used these days is legacy mode. Legacy mode is something like you have the default admin role where you're granted the full control over system, or otherwise you have the only read access. It's like read or admin in the legacy mode. And the third one that was not also being used is logged in user can do anything. Logged in user and anyone can do anything is almost like similar. Here also people who log in can basically do any of the tasks which is being done in Jenkins. So in modern day industry for security, we only used metrics-based strategy and the project-based authorization strategy. These are the two things which are basically used in modern day world for using Jenkins. Now let's talk about how does master-slave architecture works in Jenkins. How can we configure that and how that is possible? Let's go back and let's go there. Let's go again back to manage Jenkins. You see an option called manage nodes and clouds. Let's see how we can set up a master-slave architecture using Jenkins. By default, the server where you install Jenkins is called as the master server, where your Jenkins server is running. On the left-hand side of the screen, you can see a tab called as New Node. Using a new node, we can add any nodes belonging to any operating system which can act as a Jenkins slave. There are multiple ways of how we can set up authorization between a master and a slave node. The most common methods of using the master slave nodes are SSH launch agent by execution of command. This is mainly used when you're using Windows machine as your slave node. For any Linux machine, we generally go by the secure shell as the authorization strategy. We can add as many nodes as you want as a slave node. There's no limitation of how many slave nodes we can have in a Jenkins architecture. Now let's talk about plugins in Jenkins. Plugins, another important component of Jenkins. When you go to manage plugins, you see three options available here. Plugins where you find updates, means you have installed and updates are available. Plugins which are installed in your machine, which are already present. So if you guys remember, when we installed plugins, we selected an option called install recommended plugins. These are some plugins which get installed by default when we select that option. Then you've got tab called available plugins. Plugins which are available, which we can use for installation. There's a plethora of plugins which is developed and managed by the Jenkins community, which you can use for installing here. So for example, let's say we want to install a plugin to integrate to any cloud environment. You can find plugin for that also. So if you search for example, Azure, you can find you've got so many plugins to integrate with the Azure cloud. Similarly, if you search for AWS cloud, you can see so many plugins to connect with the AWS services. Same way, you can create your own plugins also. We need to create your own plugins, and you can upload the plugins which can be used for you to installation in your own Jenkins installation. Once your plugin installation has been verified and updated, then it can be used by the Jenkins community as a whole. But initially, when you upload any plugin, it is just for you to use on your own machine. Now, guys, let's talk about how to create a job with Jenkins. When you work in Jenkins, there are a few terms which we use very often. Items, jobs, project, they all are interchangeable words. They all carry the same meaning in terms of Jenkins. How to create a job or item? Just click on the new item, give some name, let's say job 1. For now, select just freestyle project since we are creating a very basic one. Click on OK. Go on the build tab and select how you want to build step. Execute a shell command, a bash command. Now integrate what is your. For example, I want to execute a shell command. And let's say I want to print something, echo hello from Edureka. Simple job. And just click on apply and click on save. Let's try to build this job. In order to build this job, you see the option called build now. Click on build now. See, my job is running right now. See, my job execution got completed and I can see my first job got completed. Let's click on this one button, the first job execution, and click on the console output. Here you can see how the job execution actually happened. My job got successfully completed and I can see a message getting displayed, hello from Edureka. So simple way to see create a first job and to validate job got successfully completed or not. Let's try to create one more job and then we'll try to see how that works out. Let's say I want to print today's date, for example. So let's again say job 2, for example. Again a freestyle project. Again click on OK. Again click on build. Just execute shell. And let's say echo hello. And let's say date. And I want to store this output in /temp/Edureka. And let's click on apply. Click on save. And let's click on build now. You see the job output is successful. Let's click on this. Click on console output. You see it successfully printed this and the output got completed. You see all this job that we execute are done in a specific directory structure on the Jenkins server. So if I go on this Jenkins server, for example, and go inside this directory structure and you do ls, you can see that this job got executed in this directory structure job. Similarly, if I go in the temp directory structure and do an ls, you see when we ran this job, we gave the date should be printed in this Edureka file. If I do a cat and this file name, it is print today's data. Simple example that whatever jobs we execute gets actually executed on the Jenkins server. We just seen the front end in the GUI, what is being done as part of the Jenkins strategy. Now, how do we do a source code management integration in Jenkins? For example, let's say I have got some code in any versioning tool system, let's say like Git or Subversion or Bitbucket, and I download data from there too. Go to the job or create a new job. Let's click on configure. If you go on to source code management, you see an option called Git. Here you can define the GitHub repository path from where you want to download data. your Git repository. If you're using a private repository, add your Git credentials and from which particular branch you want to download or clone your code. You can even add multiple Git branch from where you want to get the data. That is how this thing works in Jenkins. Another beauty about Jenkins is build triggers. So every time when I build a job, I don't want to go manually and run the job. We can automate this process using some simple tasks like build periodically. You can define a schedule where you want your jobs to be run. This schedule is defined in a cron tab basis, like every 5 minutes, every 10 minutes, every hours, once in a day. We define a cron tab entry for that, and accordingly, your jobs will run automatically in that particular schedule manner. If you want to make your life more simpler and want to run the job every time a new commit a developer makes, for that, go with the option of poll SCM. In a poll SCM option, every time a new commit happens made by a developer, at this specific schedule, check for it. If there is no new commit, the job will not build. But if there's a new commit, the poll SCM will trigger that job. That is how we automate the things in Jenkins. When you build a job, you try to get a sort of pipeline. You can create a pipeline on the basis of multiple scenarios. When you say scenarios, what scenario you talk about? For example, let's say I want the next job to be executed only if my build is stable or unstable or failed. You can specify a scenario and then say which job want to trigger. For example, I want to interlink job 2 and job 1. I can give job 2 interbuild after job 2 build job 1, but only trigger job 1 only when job 2 is stable. So it's like sort of creating a sort of interdependent jobs where only if my previous job execution was stable or successful, it will go to the next job. Otherwise, it will skip the next job. That is how we build a sort of pipeline using Jenkins. In Jenkins, your slave nodes or your master slave hierarchy can be a node in the on-premise machine, or it can be any cloud VM also. So for example, you can have your Jenkins master server deployed on-premise or in your own data center, while your slave machine can be running in an AWS cloud or an Azure cloud or even both. That is how good Jenkins is all about. Jenkins, guys, completely open source automated software where there's no cost of using it or there is no licensing cost linked with it. How do we automate all those stages and deploy them in a one single code as a pipeline? So now we're going to see an example on how to create a pipeline. Before using this pipeline, we have just make sure that Maven is installed and present in our environment. So let's go to our Jenkins setup. We have installed and configured our Jenkins. Again, just click on new items as we did previously to create a new job or something. Give some name. Let's say I give a name as code. Select the option as pipeline. Click on OK. And when you scroll down, you see an approach called pipeline script. Here, basically, you write your script on how you want to deploy your pipeline for your example. Here, in my scenario, you see we have created this scripted pipeline. Here, there are 3 steps, or you can say 3 stages for our code deployment. The first is we're preparing our code. Here, as you can see, we're downloading the code from a Git repo or a Git repository. Here, we've defined the Git repo path where we want our code to be downloaded. You can specify whichever GitHub path you want to use. Next thing you can see, we have defined an environment variable that is build the code that is getting downloaded from the preparation step. We have named as stage build. Here you can see we are running the bin mvn, the default Maven directory, and we're trying to build this particular piece of code here. Once our code gets built, we're trying to combine this code and create an artifact file, a jar file. You can define whatever format of output you want, a jar file, a zip file, a war file. Anything can be defined in this approach. Let's click on apply. Let's click on save. And let's see how this pipeline looks like. So click on build now. You can see different stages have happened. The first one is preparation stage. In this stage, the code would have been pulled from the Git repo. Then the build stage, and finally we see a result that something has happened. So let's click on this job and let's click on the console output. You can see the first stage happened, that is pulling the data from the Git repository. It was a public repo, so no code need to be specified. The data got cloned or downloaded from this Git repository. Once the data was downloaded, it then tried to combine it. So it uses different Maven plugin, like the compiler plugin. For test report, the Maven Surefire plugin. It ran some test cases, you see. It ran some 6 test cases where it had no failures in this particular directory structure on your server where you install Jenkins. So if you go inside the directory structure where you install Jenkins and click on ls, you can see the jar file for your code has been done. So using a very simple Jenkins pipeline, we automate the entire process of compiling, packaging, building, unit testing, and I think it took less than a minute for this entire thing to happen, probably some couple of seconds for this entire step level. That is how Jenkins make life so easy. It overall took us 2.785 seconds. And this 2.785 seconds, it pulled the code from VCS, a version control system. It compiled it, it packaged it, it tested it, and now everything looks good. It packaged our code as a jar file. So that is how Jenkins helps us to make our life easier.
Continuous integration is like a software development lifecycle. Now, how does it work? So as you can see here, this pipeline is a logical demonstration of how a software will move along various phases or stages in this lifecycle before it is delivered to the customer or before it is live. So just imagine you're going to build a website which is going to be deployed on the live web servers, and your product is a website or a web app. Now, you will have a set of developers who are responsible for writing the code which will further go and build the web app or website. So once the team of developers write this code and commit the code into the version control system like Git or SVN, it goes to this build phase. So this is the first phase of the pipeline where developers put in their code and code goes into the version control system having proper version tags. So you know which build has what kind of version tag. So any commit that happens and you find an error, you can just go to that particular version and then check the commit. So after you have your version control system phase done, then it goes through a build phase where you compile the code. So you get all the various features of that code from various branches of repositories. Then you merge them, and then finally you have some compiler to compile it, and that is nothing but the build phase. So in build phase, what's happening is the code has been taken from the version control system and then it is compiled. So you know the code of all the features are merged and then it is compiled together. Once the build phase is done, you move on to the testing phase. So in testing phase, we have various kinds of testing depending on the type of the company or depending on the type of the product that the company is delivering. So one of the tests in the testing phase is unit tests. So what happens in unit tests is that you break your complete software into small little chunks. That is, the complete software is divided into chunks based on different parts. So every part has a code. So it is divided into small individual units to understand how it works, and when the test is completed, you have an assurance that that particular part is working. And once each and every part is tested, there is one more test that has to be performed, that is the integration testing. So what happens with integration testing is, now all these individually tested parts are integrated together and seen if they can work with each other or not. A software has many features where they have to work with each other. So that is tested in integration testing. After your testing phase is done, you next move on to the deploy phase. And this is the stage where you deploy your software onto the staging area or the test server where you're going to view the code. So in the deploy phase, the code is deployed successfully, and then you can run another set of sanity tests. And once you think that all the parts are working and everything is fine, you can finally think that it is acceptable, and then it is deployed onto the production stage, right? Meanwhile, in every step, if there's some error, development team fixes that particular bug and then pushes it into the version control system, which goes back to the complete pipeline again. So once again, if there is any error reported during testing, the feedback goes back to the dev team, they fix it, and that particular product goes to the complete pipeline again. That is, it again goes through the build phase, the testing phase, and then it is deployed onto the prod servers. So this is how in every phase, it moves on throughout the life cycle unless we get a code or a product which can be deployed into the production server, and there we can measure and validate that code. So pipeline is a logical step or a series of steps which define how software development lifecycle occurs. So guys, this was all about CI/CD pipeline. So now that you know a brief about all the stages in the CI/CD pipeline, let me tell you what exactly is continuous integration. So let's consider a scenario of a team which has 5 developers building a website which has many features. So let's say if this website to be a shopping website, right? So as we all know that in a shopping website, we have many pages like, the user details, the past orders, the shopping carts, whatever product a person has added to his cart, and so on. And then finally, we also have the checkout page and so on, right? So all these different pages are known as features of the software. So when you have multiple features, you have to combine those features and merge them into a single version control system where you merge the various feature branches of the code and make a single pool of the code which can be now compromising of all the features of various branches committed by the developers, and then you can build it as a product and move on to the testing phase. So what are you basically doing? You're combining all the feature branches, that is all the feature codes, into a single branch, and once you combine it successfully, so you're then moving it to the testing phase. Now, when you merge the code and you build the code to get a single unit of the software, this is nothing but integration. So, integrating means putting all the code together from all the contributing developers and then merging the code and building it as a whole. Now, you must be wondering, why do we call it as continuous integration? The reason is because everything happens in DevOps continuously. So everything is automatic. So as soon as the person commits the code in the version control system, it continuously starts merging the process, and then it continuously starts also building the process simultaneously. So that is the reason that it is known as continuous integration, as nobody has to wait for anything. After the stage of continuous integration, we have continuous delivery. So as and when we move on to the various stages in pipeline, we finally deliver the product, because as soon as it passes the test and new features become functional, it can be used as the final area for the product. So everything happens in a continuous way. So the product is built, the product is tested, the product is then deployed onto the prod servers. So since it is continuously integrated, built, tested, and deployed and delivered, this process, in short, is known as the CI/CD process. Now, once you have the continuous integration and continuous delivery in place, the deployable unit path is called pipeline. Now, what do I mean by deployable unit path? I mean the path to the production servers where it is deployed onto the live servers. So now that you've understood what CI/CD pipeline is, let me show you a real-life use case of a company known as Capital One. So Capital One is one of the well-known brands in America and is among the top 10 largest banks in the nation by deposits. It offers a wide range of financial products and services to commercial clients, small businesses, and individual consumers, both online and inline at branch locations. The company was founded on the vision that the power of IT and testing could be harnessed to bring the highly customized financial products directly to the customers. Now, the initial challenge was to increase the automation while ensuring stability, scalability, and security. As continuous integration practices were becoming increasingly mainstream, Capital One formed a continuous delivery tools team as a part of restructuring their company's technical organization. So this team was created to support thousands of developers by providing a solid service that helps them deliver software applications more quickly and in a more agile fashion. From a platform perspective, the technical makeup had to be extremely flexible to meet a wide variety of use cases, but it also had to be both stable and scalable. Further, as financial services company, Capital One needed its platform to be secure itself and promote improved security for the applications built with it. So, with these objectives in mind, the new shared continuous delivery tools team sought to implement the CI/CD practices that supported security practices without stifling developer innovation with reference to speed and security. So, the solution they found out was to establish a platform for CI/CD to deliver quality software with shorter time to market. So, how did they do that? So, the shared continuous delivery tools team established an internal platform for automating builds, testing, and deployments based on cloud-based Jenkins platform. They used the role-based access control plugin to implement an authorization strategy in which security roles were assigned to a group of users. After the initial platform rollout, the team made incremental refinements over the time to improve operational efficiency. They decoupled their Jenkins agents from masters, giving them the ability to scale masters and agents independently using the Amazon Web Services. The team began using cloud-based Jenkins Operations Center to manage multiple masters and reduce the administrative time by ensuring plugin compliance and version consistency with the update centers. So the team settled on a single default environment for all the groups. On the top of the infrastructure created by the team, a common implementation pipeline layer was also created. So this is how they use the CI/CD pipeline, to solve their challenges. So after implementing the CI/CD pipeline, they saw that 90% of their pipeline was automated. So this increased the deployment frequency with 1300%. So that's a huge number, isn't it? So with the Jenkins platform, they created a service for the developers that was scalable and stable. As a result of this, the time that developers would have spent managing the infrastructure was now spent by developing business applications. And obviously, as I said, this increased the deployment frequency by year on year, right? And also, it was seen that the quality and the security of all the repeatable processes was ensured. So they implemented consistent repeatable processes in an automated fashion every time a developer wanted to commit, or every time a developer wanted to deploy something. So this produced a more secure software, enabling them to deliver it faster. So guys, that was the use case about Capital One. So it was really clear to you, right? How they faced the challenges, they solved the problems with the help of CI/CD, and they could clearly see evident results. So in between the discussion, you must have also observed that I was mentioning Jenkins platform, right? So why do you think that they just used Jenkins? Why not anything else? So why do you think that Capital One went for Jenkins platform? Why was it so important to them? So Jenkins is a really good automation tool that you can use. Now, how is Jenkins going to help us? So let's know. So Jenkins provides us various interfaces and tools in order to automate the entire process. By entire process, I mean the process of the complete development lifecycle. So what happens is that, so suppose you have a Git repository where the development team commits the code and then Jenkins takes over from there. So Jenkins will pull that code and then it will move it to the commit phase where the code is committed to every branch. Then Jenkins moves it and then it goes to the build phase where it will compile the code. Now after the code is compiled and after the code is validated and reviewed, the code is tested, and once all the tests are done, it is finally packaged into an application. It could be either a WAR file or a jar file. So what Jenkins does is it is going to pull your code from your version control system and then it is going to perform the build. It is going to compile your code. It's going to validate your code. It's going to again review the complete code. After that is done, it will perform the unit testing and the integration testing, and then finally it will package your application into a WAR file or a jar file, and then it is ready to be delivered. So that's what Jenkins helps us to do. So now you must have understood that this is the tool for basic continuous integration. But as I just said, Jenkins' role is only till the application is packaged. Now if it has to be delivered, then we need some tools to deliver that product, right? So now that you know a lot of theory about CI/CD pipeline and you know the tools for CI/CD pipeline, that is Jenkins and Docker, let me show you practically how a CI/CD pipeline is created and how it is executed, right? So let's get started with our hands-on. So we're going to build a CI/CD pipeline using Jenkins and Docker. So for that, let me just open my VirtualBox manager where I've installed Jenkins in my system. Let's go to my VirtualBox. Before I start creating my pipeline, let me run the Jenkins service and Docker, right? So let me open the terminal. Let me enable the Jenkins service and the Docker service before creating the pipeline. So let me type in the command. So for that, I'll type in systemctl start Jenkins. So it will ask me my authentication. So I'll type in my password. And then I'll type in systemctl enable Jenkins. So as you can see that I've not got the privileges because I've not entered the command as the super user. So if you wish to enter the command as the super user, you have to type in sudo before the command. So you'll type in sudo systemctl enable Jenkins. And then you'll be asked for the password. So let me type in my password. And then you can see that your Jenkins server has been enabled. Now we also want Docker to run. So for that, we'll type in systemctl start Docker. Again, it's asking my authentication. So I'll type in my password and then Docker has started. So our Jenkins service and Docker has been started. So now let's open our Jenkins dashboard. So for that, I'll open my local host. So let me open my Jenkins dashboard. So when you open your Jenkins dashboard, Jenkins always asks for the user ID and the password. Mention your user ID and the password and click on login. Alright, so this is your Jenkins dashboard. Now what I'm going to do is I'm going to create a pipeline. So for that, I'll be using 3 jobs. The first job would be to build the project. The second job would be to test the project. And the third job would be to finally deploy the project. So for that, we'll be creating 3 jobs. So let me show you how to create new jobs. So for that, you have to go to new item. You have to type in the job names. So let me put in the job name as job 1 and choose as freestyle project and then click on OK. Once this is done, I'll again go back to my dashboard and create 2 more jobs similarly, that is job 2 and job 3. So let me type in the name job 2 and choose it as freestyle project and click on OK. And when it comes to the configuration part, I'll tell you what you have to configure soon. And then similarly, I'll create a new job, that is job 3. So let's go back to our dashboard. So you can see that 3 jobs have been created. Now I want to create a pipeline. So what I'll be doing for this pipeline is I'll be pulling a code from a Git repository, and that code is a Java web code which is basically given to the development team for the testing. So that is job 2 here. And once the testing is done, it will be deployed. So for that, you have to mention the repository's URL in your job to pull that code. So let's mention the repository's URL. So for that, I'll go to job 1, I'll go to configure, and then I'll go to the source code management tab. I'll go to Git because I'm going to mention the repository URL of a GitHub account. So I'll mention the repository's URL. So this repository has all the files related to the project. So this is where from Jenkins will pull the code, and then it will perform the build, test, and deploy operations in a CI/CD pipeline. So I'll click on this and save and apply. Similarly, I'm going to do it for the other 2 jobs also. So we have mentioned our Git repository for all the 3 jobs. Now we have to configure our jobs in such a way that when it performs the build option, it knows what code it has to compile and what all has to be installed respectively. So after mentioning your GitHub repository URLs for all the 3 jobs, our first step is to build the source code to get a WAR file, that is an executable file. Now what does this mean? Basically, when the Jenkins server pulls the code from the Git repository, it uses Maven to install that package. So for that, we have to mention the command of Maven install, and then Maven install installs all the dependencies that are required to compile this application. And once the application passes all the tests successfully, it will then use Docker to deploy it. So this is the process of the CI/CD pipeline that we're going to use. So for that, let's go to our job 1 and then configure it first. So let me open my job 1, go to the configure option, go to the build option here, go to add build step, choose execute shell because we're going to execute the shell commands, and then I'll mention the required commands. So the required commands would be here to mention the directory of our web code and then also mention Maven install. So because we want to install all the dependencies required to compile our project. So let me mention the commands. So as you can see that I've mentioned the required commands. So our first command is to change the directory of our web code. That is the directory in which we want the code to work in. And then we are using the command Maven install to install all the dependencies required to compile the code. After that, we want it to move on to the testing phase so that the testing is performed. So we're going to change the directory to the testing phase, and then we will verify the testing results with the help of this command. So this is what you have to mention in job 1. After you've mentioned this, you can then save this job 1. After that, let's configure job 2. Job 2 is where we want the testing to be done, and then we want it to be copied to the Docker file so that our application is deployed onto the prod servers. So for that, I'll go again onto the option of configure, and then I'll go to the build option. I'll go to add build step. I'll choose execute shell, and then I'll mention the required code. So after our job 1 has been built and tested, we want our application to be deployed onto the prod servers. So for that, we'll build a Docker container. So to do that, you'll use the commands to change the directory as cd java web code, and then to build a Docker container, you will use the command docker build -t DevOps pipeline demo. So that is the name I've given. You can give any other name that you want. After that, you can click on save and apply. Once this is done, let's configure job 3. That is the final stage where everything is tested, and then we just want it to be deployed onto the prod servers. But before that is done, we have to check one thing, and that is if our image has been created previously or not. If there is an image that is previously created, then we have to remove that old files. Else, if it is not created, then we can say that a new image has been created. Or if you say that there is no container existing at all, then you can reply a message that there is no container existing, right? So for that, let me just go to the build option again, go to add build step, go to execute shell, and then I'll mention the commands. Alright, so I've mentioned the required commands. So my container that I've previously created on job 2, that is DevOps pipeline demo, is running, and then over here I'll check if it is previously existing or not. If it is existing, then I'll remove the files by using the command rm, and if it is not, then I'll print a message saying that the container does not exist. So that's how you can make sure that your container is previously existing or not. After you're done with this, you can just save and apply. So now that I've told you that we are creating a pipeline, that means all the jobs must be interconnected. So the pipeline should know after job 1 is built, what has to be built next. And after job 2 is built, what has to be built next. So to do that, we have to mention in the configure options of jobs. So let's go to the first job, that is job 1. Go to the configure option. And over here, I'll go to the post build actions tab. And over here, I'll choose build other projects. So I'll mention the next job that has to be built after job 1, that is job 2, right? So I'll mention job 2 and then I'll save and apply. After this is done, I'll go back to my Jenkins dashboard and I'll go to job 2 over here. I'll then configure job 2 and then I'll mention after job 2 is built, what has to be built, that is job 3. So I'll again go to the post build actions, go to the build other projects option, and then I'll mention job 3 here. So we have mentioned our post build actions. So now what will happen is once job 1 has been successfully built, it will automatically start building job 2, and once that is done, it will automatically start building job 3. So that's how you can build various jobs one after the other. So as I said that we're going to create a pipeline. So to create a pipeline, you have to go to this plus option here. You have to mention your view name. So that is your pipeline's name. So suppose I mention it as DevOps pipeline. So let me mention the name. And then I'll click on build pipeline view. And then I'll click on OK. Now once this is done, as I said, a pipeline should know from where it should start. So we're going to mention job 1. So that is where our pipeline will start. So I'll go to the pipeline flow section and then I'll mention the initial job as job 1. So that is already mentioned here, and once that is done, I'll click on apply and then click on OK. So that means our pipeline has been built. Now, if you have to run this pipeline, you just have to go to this option and run. So you can see that if the job 1 is in yellow, that means it has started running, and job 2 and job 3 are in the sequence. So as you can see that job 1 has been successfully built. So let me open my console output and show you. So you can see that our Git repository has been pulled. So the code has been compiled. All the Maven dependencies are installed that are required for compiling the application. And finally, we can see that our test results have been successful. In the second job, we were creating a Docker container. So let it run. So let me show you how the Docker container was created. Alright, so you can see that our job 2 has also successfully built. So you can see that all the artifacts have been copied and the Docker container has been created. So our job 2 was also successful in building. So let's wait for the job 3, and once it builds, I'll show you that it has been deployed successfully. Alright, so you can see that our job 3 has been successfully built. So that means that our CI/CD pipeline was successful. So before I move on to show you the output, let me show you the console output of job 3. And you can see that yes, our container did not exist previously and a new container was created, right? So guys, that's how you build the CI/CD pipeline. Now let me show you the results. So I'll go to my localhost. So you can see that our application is running fine. So guys, that's how you can build a project and then compile the code by installing the required dependencies. And once that is done, you can push it to the test phase where the product is tested. And once it passes all the tests, it is then deployed using the Docker image. And once that is also successful, it is deployed onto the production that you can see in front of your screen.
So since Docker is a containerization platform, it's important to understand what came before containerization, or what is the history of containerization. So before Docker came into the picture, before containerization came into the picture, there was this concept of virtualization, or basically using virtual machines. So virtualization was this technique of importing a guest OS on top of an operating system. And this technique was a revelation at the beginning because it allowed developers to run multiple operating systems in different virtual machines, all running on the same host operating system, which nothing but eliminated the need for extra hardware resources. Now, the advantages of virtual machines or of virtualization are many. Multiple OSs could be run on the same machine. The maintenance and recovery was easy in case of failure conditions. And the third point here being the total cost of ownership was also less due to the reduced need for infrastructure. So as you can see here on your screen right now, you can see that there is a host operating system on which there are multiple guest OSs running, which is nothing but a virtual machine. So as most concepts have their shortcomings, virtualization also had a few. So running multiple virtual machines on the same host OS, each to the performance of degradation. This is because the guest OS running on top of the host OS will have its own kernel, own set of libraries, and own dependencies. And these take up a large chunk of the system resources, that is the hard disk, processor, RAM, and other resources. Another problem with a virtual machine, which used virtualization, that it takes a lot of time to boot up. So the problem is very critical in case of real-time applications, so these drawbacks were always there. Apart from that, you also have the age-old battle between development and production teams, that the code works at development and does not work in productions, because the developer has a system with their own set of libraries, their own kernel, and the apps running on there, whereas the production team has these resources of their own. So this is a problem that you can blame upon the difference in the computing environment. A code that runs on the developer's system might not run on someone else's computer. So this led to a new technique called containerization. Basically, a container brings virtualization to the OS level, while virtualization brings abstraction to the hardware. Containerization brings abstraction to the OS. So what you might notice here is containerization is basically virtualization, but it's more efficient because there is no guest OS here. It utilizes a host's operating system, shares relevant public libraries and resources when needed, and unlike virtual machines, the application-specific libraries and binaries of containers run on the host kernel. So each app has its own set of libraries and binaries in its own little container, which makes processing and execution extremely fast. Even if you have to boost a process, it takes only a fraction of a second, because in case of containerization, all the containers share only the host operating system, but hold all their application-related binaries and libraries in themselves. They are lightweight and faster than virtual machines. So here, as you can see, there is your host OS or your host kernel, which is shared by all the different containers. So the containers themselves only contain the application-specific libraries which are separate for each container. This is what makes them faster, and they do not waste any resource. All these containers are handled by a containerization layer, which is not native to the host OS. Hence, a software is needed which can enable you to run containers on your host OS. And this is also how containerization solves the difference in computing environment problem. Now, a developer works on containers instead of virtual machines. The app and its required libraries and binaries all are in one container. So when it is passed on to the testing team or the production team, it does not matter whether their host systems have the same libraries. All the dependencies are already present in the container containing the app. So now that you know what is virtualization and what is containerization, and why do we need containerization, let's move ahead and talk about Docker. Why do we need Docker? So a challenge I briefly spoke about earlier is what I would like to elaborate on in this section. Now, when you have a project code in a development lifecycle, there are different environments. You have your virtual server, you have your staging environment, you have your production environment, you have your QA environment. Now, most of the code that we deploy today is done using VMs or virtual machines. Now, how this works is that a developer or certain developers will write the code, and all of it is placed in a version control system such as Git. Now, this could also be placed in a staging server depending on your organization's infrastructure, but most organizations these days use a version control system. So, more often than not, the code is placed in that version control system. Now, this code is never directly deployed in the production server. It's usually first deployed in a lower lifecycle server like your QA server or your staging server. Now, once it is successful in that, then only it is deployed on your production server. Now, this is where the chances of conflicts increase. So, the same piece of code that might be running on your staging server might not run on your production server. And the reason is very simple, it is the difference in the computational environment. This is also known as infrastructure incompatibility. Now, in most cases, your QA servers or your QA environment, staging environment are always updated. In most organizations, that's the case. It usually has the latest libraries, latest binaries, latest jars, all that jazz. But the same cannot be said for the production environment. So, in order to face all these challenges that is faced, difference in environment and lack of optimization of resources, we use Docker. So, this is where Docker comes into picture. Docker does virtualization in the software level, and we call it containerization, as I had mentioned before. So here, as you can see, containers are bundled with their own set of libraries and binaries, but they can communicate with each other with a fixed set of protocols. The thing about containers, however, is that they do not have their own operating systems, which is a great thing, because this is what makes them lightweight and function on very little resources, which makes them really fast as well. So what exactly is Docker? As you can see on your screens, there are two machines. The first one has 3 software applications. One is Angular based, one is React based, and one is Django based. Now all of them are using common resources from the systems, libraries, RAM, processor, etc. And the frameworks are allocated a location in the memory. Now how is it different from your machine with Docker? Since you have a Dockerized machine, you have a Dockerized system, all of your frameworks and binaries and libraries required by your Angular app, your React app, and your Django app can be put into their each isolated containers, which are going to run independently from each other without interfering with another app. And the space in which you had your framework stored has opened up. So now you can add another software application there with its own frameworks and libraries, binaries, etc. And that is what Docker is meant to do. It's a tool designed to make it easier for you to create, deploy, and run applications by the usage of containers. Docker is a containerization solution. Docker containers do not use the guest operating system. They use the host operating system, and on top of that host operating system, there is the Docker engine. And with the help of this Docker engine, Docker containers are formed, and these containers have applications running in them. The requirements for those applications, such as all the binaries, libraries, frameworks, jars, etc., are also packaged in the same container. There can be multiple containers running simultaneously. As you can see, there are 2 containers here in our example, and those containers have applications running in them. And you don't really have to pre-allocate any RAM to those containers. These containers allow a developer to package an application with all its parts, all its needs, and then you can deploy it as one whole package. They are basically lightweight alternatives to virtual machines that use the host operating system. This is basically a general workflow of Docker. So you can see one way of using Docker over here. What is happening is that your developer writes a code and defines an application requirements or the dependencies in an easy to write Docker file. And then this Docker file produces Docker images, so whatever dependencies are required for a particular application is present inside the image. Now, as we have specified many times before, what are Docker containers? Now, the Docker containers we spoke so much about are basically the runtime instances of these Docker images. This particular image is then uploaded onto Docker Hub, from where anyone can pull the image and build a container. Now, Docker Hub is nothing but the GitHub of Docker. It's like a repository for Docker images. It contains public as well as private repositories. So from the public repositories, you can pull your images and you can upload your own images as well to Docker Hub. And then, as I mentioned, from Docker Hub, various teams such as your QA team or production team can pull the images and prepare their own containers, as you can see in the diagram. So this shows a great advantage of Docker is that whatever dependencies that are there that are required for your application to run are present throughout the software delivery lifecycle. If you can recall, the initial problem that was there with VMs was basically that the application worked fine in a development environment, but when it reached the production environment, it was not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have the same environment throughout the software delivery lifecycle, be it a developer, testing, QA, or production. Now, before moving on to the next section, let's look at a case study about containerizing the NASA Land Information System framework using Docker. Now, developed by the Hydrological Sciences Laboratory at NASA's Goddard Space Flight Center, or GSFC, the Land Information System, or the LIS, is a high-performance software framework for terrestrial hydrology modeling and data assimilation. Basically, the LIS enables integrating satellite and ground-based observational products and advanced modeling algorithms to extract land surface states and fluxes. Now, this framework was very difficult for non-experts to install due to many dependencies on specific versions of the software and compilers. This situation then created a significant barrier to entry for domain scientists interested in using the software for their own computing systems or in the cloud. In addition, the requirement to support multiple runtime environments across the LIS community had created a significant burden on the NASA team. Now, to overcome these challenges, NASA had deployed LIS using Docker containers, which allowed installing an entire software package along with dependencies within a working runtime environment. They also used Docker Swarm, which we shall learn about later, to orchestrate the deployment of the cluster of containers. This installation, that used to take weeks or months, was now completed by NASA officials in minutes, either in the cloud or on premises. Now, moving on, let's look at Docker's workflow and architecture. What you see in front of you is the Docker workflow. Now, the Docker engine uses a client-server architecture, where the Docker engine is simply a Docker application that is installed on your local machine. The client-server architecture communicates using a REST API, and the Docker daemon checks the requests to manage the containers. So the Docker architecture includes a Docker client, which is used to trigger Docker commands, a Docker host which runs the Docker daemons, and a Docker registry which stores the Docker images. The Docker daemon running with the Docker host is responsible for images and containers. We'll understand the concept of images a little later in this very section as a part of Docker components. So to build a Docker image, you can use the CLI or the client to issue a bill to command the Docker daemon which runs on the Docker host. Now the Docker daemon will then build an image based on your inputs and save it in the registry, which can either be the Docker Hub or a local repository. So if we do not want to create an image, then we can just pull an image from the Docker Hub, which would have been built by different users. And finally, if we have to create a running instance of any Docker image, we can issue a run command from the CLI or the client, which will create our Docker container. So this is basically the overall architecture or the overall functioning of the Docker architecture. As we move forward in this section, things will be more clear to you. So as you can see, the heart of the Docker architecture is basically the Docker engine. The Docker engine is simply the Docker application that is installed on the host operating system of your host machine. It works like a client-server application which uses a server, which is a type of long-running program called the daemon process. The second point here is the command line interface or the client. The next component here is the REST API, which is used for communication between the CLI client and the Docker daemon. So now if there is a Linux-based OS and there is one Docker client which can be accessed from the terminal and a Docker host which runs the Docker daemon, we build our Docker images and run our Docker containers by passing the commands from the CLI client to the Docker image. So this was all about Docker Engine and its workflow. Now let's talk about the Docker components which you will be most acquainted to hearing. You have your Docker file, which builds into a Docker image, which you run, you get a Docker container, and then you store it in a Docker registry. Let's go ahead and look at all of these components in a little depth, shall we? First of all, you have your Docker file, which is nothing but a text document which contains all of your commands that you as a developer call on the command line to assemble an image. So basically, to create an image, you'll have to write a Docker file and then build it. So Docker file basically has your set of instructions which creates the Docker image. Next, you have the Docker image, which can be compared to a template used to create a Docker container. So Docker images are basically the building blocks of a Docker container. These Docker images are created using the build command, and these are read-only templates. You can then store them, as I had mentioned before, in your Docker Hub or your local registry. Next, after building your Docker image, what you get is a Docker container, and these are read-only templates. You can then go ahead and store them in Docker Hub or your local registry, as I had mentioned before. Docker lets you create and share software through Docker images, and you also don't have to worry about whether your computer can run a software in a Docker image, because a Docker container is always there to run it. So in case of Docker images, you can use a ready-made Docker image from the Docker Hub or create a new image as per your own requirements to run in a container. With that, let's move on to the next component, which is a Docker container. So the Docker containers are the ready applications created from Docker images. It's the running instance of a Docker image, and this Docker container holds the entire package needed to run this Docker application. So a Docker container happens to be the ultimate utility of Docker, and hence this is the part of Docker which is most popular and most widely used. So if you talk about the applications, every application is run inside a container. So it is an isolated application platform that contains all you need to run an application built from one or more images. So finally, let's move on to Docker Registry, which is a storage component for the Docker images. Now this is where the Docker images are stored, which could either be a user's local repository or a public repository like the Docker Hub, which allows multiple users to collaborate building an application even with multiple teams within the same organization who exchange or share containers by uploading them to the Docker Hub. It helps you control where your images are being stored and integrates your image storage with your in-house development workflow as well. Now, Docker Hub, as I mentioned before, is Docker's very own cloud repository, which is similar to GitHub, which is kind of like GitHub but for Docker images. Hope you guys are with me so far. With this, we have seen the architecture and components of Docker. So now we are going to talk about two other components of Docker, Docker Compose and Docker Swarm. So first of all, let's start with Docker Compose. Now, Docker Compose is a tool for defining and running multi-container Docker applications, which basically means you can run different or multiple containers as a single service. The containers are still isolated, but they can interact with each other using a YAML file, which is used to configure your application services. And then with a single command, Docker Compose up, you can create and start all the services from your configuration. A great example of this would be a microservice such as a shopping app. So for example, you can take any online retail store's app. It could be Amazon, it could be Flipkart, it could be Agio. And the idea behind an app like this is that it's a microservice app, which basically means it has multiple services in one big application. So all of these services individually are easier to build and maintain, and when one service is failing, the entire app is not down. So a retail app like Amazon or Myntra or Flipkart or any app of your choice, it'll have multiple services, like it'll have a login account, it'll have your product catalog service, it'll have a shopping cart service and a checkout service, and this is just the bare minimum. And each of these services could be scaled up or down in their own container, tested and built and fixed in their own isolated containers without interfering with any other service in that entire application. So using something like Docker Compose, you can connect all of these isolated containers as a single service. All right? And the next thing I want to talk about is Docker Swarm. Now, Docker Swarm is a service which allows you to create and manage a group of either physical or virtual machines or nodes and schedule containers. Each of the nodes is a daemon which interacts with others using the Docker API. Docker Swarm is basically a technique to create and maintain a cluster of different Docker engines. Services deployed in any node can be accessed on other nodes in the same cluster. It allows for high availability of services, auto load balancing, decentralization of access, easy upscaling and downscaling of deployments, and rolling updates. So basically how it works is that your manager nodes know the status of all the working nodes in a cluster. Your worker nodes then accept tasks sent from the manager node. There is an agent assigned to every single node to give its task updates to the manager. And finally, the workers communicate with the manager using an API over the HTTP protocol. And that is how a Docker Swarm works. Basically, Docker Swarm is an orchestration management tool that runs on Docker applications. It helps you end users in creating and deploying a cluster of Docker nodes. Each node of a Docker Swarm is a Docker daemon, and all the Docker daemons interact using the Docker API. And each container within the swarm can be deployed and accessed by other nodes of the same cluster. So if you consider an environment having Docker containers, if one of the container fails, we can use the swarm to correct that failure. Docker Swarm can reschedule containers on node failures, and the swarm node also has a backup folder which we can use to restore the data onto a new swarm. So with that, we have come to an end to the workflow and architecture of Docker. So now I'm sure all of you might be eager for actually doing something on Docker. So let's go ahead and install Docker. So here are the steps to install Docker on Ubuntu. On your Linux systems, on your Ubuntu systems, you will be using the command sudo apt install docker.io on your Ubuntu systems to install Docker on your system. So let's go ahead and start up with the installation. Today I am using the Ubuntu distribution running on my Oracle VM VirtualBox. So we're going to start out by updating. So sudo apt update. And this might take a little bit time, so kindly be patient. This is a good practice before making any installations, any setups on your machine. All right. As you can see, all my packages are upgraded, and now we can go ahead and install Docker. So to install Docker, we are going to use the command sudo apt install docker.io and then click on Y. And this is also something which takes up quite a considerable amount of time depending on the speed of your machine as well as the speed of your internet, so on and so forth. Now understand this is just one way of doing this, and this is the method I am most comfortable with, and that's why this is the method I will be demonstrating here. There are 2-3 other methods through which you can download Docker on your machine. And not just in Linux, you can also install Docker Desktop on Windows, just in case you do not want to use a virtual machine. And you can also use a cloud platform such as an EC2 instance to run all of these Docker commands that I shall be showing you later in this session. So now we are going to start and enable Docker using sudo systemctl. Okay, with that we have started and enabled our Docker machines. And now we are going to go ahead and check out our Docker version that's running. And as you can see, this is the Docker version and this is the Docker build that we are running. All right, so moving on, we are going to get to our hands-on section. In this section, we will learn how to create a Django project setup using Docker and deploy it on our local host. For that, remember, you need to have a GitHub account and Docker installed on your machine, just the way I showed you right now. We're going to build a backend REST API with Python and Django. We're going to create a new GitHub project that we are going to use to store the source code for our recipe app API. Now, this is a wonderful way to show the versatility of Docker. Now, I found this project while browsing through GitHub, and I came to a conclusion that this was a wonderful way to show how eclectic, how versatile is Docker as a tool. So the first step would include initializing a new project on GitHub and coming back to your Linux machine and navigating to where you wish to store your API. There, we are going to create our Docker file using an editor. You can obviously use the VI editor or Nano editor if you please. There, using the editor in our working directory, we are going to be creating our Docker file, our requirements file, and our Docker compose file, which is our YAML file. And then we are going to run our app on the terminal. So this is a basic breakdown of how we are going to create our Django project setup using Docker. So let's go on straight to our demo machine and put all of this into action. So we are going to navigate to GitHub and we are going to create a new public project or repository on GitHub. So let's create a new repository and let's call it Docker Demo API App. And the description, we're just going to write Demo App Setup. We're going to keep this public and we're going to initialize this with a README file. All right. So let's go ahead and create our repository. So as you can see, this is a blank repository, Docker Demo API App, just the README file there. So here on our repository page, I'm going to click on this green button, code button, and copy the URL from here, from your clone or download option. We're going to copy this to our clipboard so that we can clone this particular repository using our terminal. I'm going to move on to the terminal and I'm going to load my terminal and navigate to the directory where I want to store my app. So maybe I'll just save it here. I'm just going to clone this repository to my local machine. All right, and that's done. Now you can go ahead and change your directory to the repository. So now I'm going to use the command ls to see if my repository has been cloned. Yes, it has been cloned. You can see the Docker Demo API app is cloned right here on my local machine. So I'm going to change my directory to this repository I just created by typing the command cd docker demo API app. Now what I'm going to do is I'm going to open up this project in the editor. Like I had mentioned, you can use any other editor. You can use the VI editor, the Nano editor, any editor that you're comfortable with. So now I'm going to clear all of this. And I'm going to use the Nano editor to create the Docker file first. So just Nano and Docker file. There's no spaces between Docker and file. And I am going to put in this code over here. All right. So this is my Docker file. So the first line of the Docker file is the image that you're going to inherit your Docker file from. With Docker, you can basically build images on top of other images. The benefit of this is that you can find an image that has pretty much everything that you need for your project. So you can just add customized bits that you need just for your specifications. So we are going to create our Docker file from Python 3.7 Alpine image. Now you can find this if you head over to the Docker Hub. You can find a list of available images that you can use to base your project off of. If you search for Python, it'll take you to a list of items where you can choose this one. So we're going to use the 3.7 Alpine image. So what it is that it's basically a lightweight version of Docker, and that's what Alpine means, and it runs Python 3.7. And the next line is optional. It's usually a maintainer line, but it's useful just to know who is maintaining the project. So I'm going to leave that one out, but you can go ahead and put in your maintainer line. You can put your name or your company's name, whatever name you basically use to keep track to show that who is maintaining this Docker image. Next, we are going to set the Python unbuffered environment variable, the way you set unbuffered environment variable. Now, the way you set an environment variable in a Docker build file is that you type env and then the environment variable that you want to set. We're going to set one called Python, and it's got to be in all capitals, unbuffered, and then we're going to set it to 1. So what this does is that it tells Python to run in the unbuffered mode, which is the recommended mode when running Python within Docker containers. The reason for this is that it doesn't allow Python to buffer the outputs. It just prints them directly and then avoids some complications and things like that. So when you're running your Python application, we are going to install our dependencies. We are going to store our dependencies in a requirements.txt list or file, which we are going to create in a moment. So that what we need to do here is we need to copy our requirements.txt file. And what this does is it says copy from the directory adjacent to the Docker file copy. So we're going to copy the requirements.txt file. Further, we're going to copy it on the Docker image, which is what this /requirement.txt file means. Next, we're going to run pip install our /requirements.txt. So what this does is that it takes the requirements that we have just copied and installs it using pip into your Docker image. Next, we're going to make a directory within our Docker image that we can use to store our application source code. So you have your run mkdir /app all in lowercase. And below that, we are going to type workdir /app. And below that, we are going to type copy./app /app. What this does is it creates an empty folder in our Docker image called /app at this location. And then it switches to that as the default directory. So any application we've run using our Docker container will run starting from this particular location, unless we specify otherwise, of course. Next, what it does is that it copies from our local machine the app folder to the app folder that we have just created on our image. This allows us to take the code that we created in our project here and copy it to our Docker image. So here we have run add user -D and user. And finally, we are going to switch to that user by typing user. Now this might be a little confusing because I've added the username user for our user, but what this command means is that it says add user which creates a user. User -D says create a user that is going to be used for running applications only. So not for basically having a home directory that someone will log in. It's going to be used simply to run our processes from our particular project. Finally, this user switches Docker to the user that we've just created. The reason we do this is for security purposes. If you don't do this, then the image will run our application using the root account, which is not recommended, because that means if someone compromises our application, they can have the root access to the whole image and they can go ahead and do other malicious things. Whereas if you create a separate user just for the application, then that kind of limits the scope that the attacker would have within our Docker container. All right, so we can go ahead and we can save this file and move ahead to creating our requirements file. So this is what your requirements.txt file will look like. It's just 2 lines. In the first line here, we are installing Django. We are using version 2.2.4, which is the latest stable version that I could find. And that's the version that we are going to use for the project. And then type Django more than equals to 2.2.4. So basically what it says is that install Django that is equal to or higher than this particular version. And we do this to take the minor version, which is the last number, and make sure that we install the latest available version, because typically it's the version that has the security features and security fixes and things like that. But it typically doesn't have breaking changes, so we can be confident that our application, when we rebuild our Docker image, will have the latest security patches, even if it does not have the latest version. Okay, in the next line, we're going to install the Django REST framework. So we are using 3.9.0. And in the same way which we did with Django, we're going to make the install one less than 3.10.0 to get the latest version of 3.9, which is whatever is the latest minor version at the time we build our project. So now we're going to go ahead and save this file as well. Now what we're going to do is we're going to go ahead and create an empty directory called app here for our Docker file to call, because when our Docker file will run and it's going to ask for an app folder, we're not going to have one, then we're going to face issues. So now if I do an ls here, you see we have a Docker file, we have our requirements file, and we have our app folder. Now understand why this is required for our Docker file for us to build it now. So now if you try to copy it without the app folder actually existing, it will give you an error. So now we can go ahead and build our Docker image. So we are already at our terminal. If you're not on your terminal, you can load up your terminal. And if you're on Windows, it'll be your command prompt. Let's make sure that you navigate to your project folder, which I am already at. And then I'm going to type docker build dot. Now what that's going to do is that it's going to build whichever Docker file is in the root of our project that we are currently in. The reason we call it Docker file in the first place is because it's the standard convention that Docker uses to identify the Docker file within our project. So we're going to wait for it to complete, and it should be fairly quick because we are using an Alpine image. It's a very lightweight, minimal image that runs Python. That's how we create a Docker file for our project. And go ahead and create our Docker Compose configuration for our project. So we're going to use Docker Compose as a tool to allow us run our Docker image easily from our project location. So it allows us to easily manage the different services that make up for our project. So for example, one service might be the Python application that we run. Another service might be a database, for example. So let's go ahead and create the Docker Compose file for our project. So nano docker compose dot YAML or YML. So this is a YAML file that contains the configuration for all services that make up our project. The first line of the Docker Compose configuration file is the version of Docker Compose that we are going to be writing our file for. So version : and 3. Next, we define the services that make up our application. Right now, we only need one service for our Python Django application. So services : and in the line below, you're going to type app. This is the name of our service. So we are going to call it out, and then we are going to type build, and then context code on context. So what this says is that we are going to have a service called app, and the build section of the configuration we are going to set the context to dot, which is our current directory that we are running Docker Compose from. Next, we're going to type the port configuration. So we're going to type them in open speech marks. 8080 is our host to port 8080 on our image. So we're going to type that. And then we're going to add a volume. The volume allows us to get the updates that we make to our project into our Docker image in real time. So it basically maps a volume from our local machine here into our Docker container while we'll be running our application. Now this means whenever you change a file or you change something in the project, you will automatically update it in the container. Now the good part is you don't have to restart Docker to get the changes into effect. So then you have a /app /app. So what this does is it maps the app directory which we have here in our project. And this it maps to the app directory in our Docker image. Then you have the command to run your application in your Docker container. So just make sure that the indentation is one indent from where your command starts, and then you type the command. So we're going to use to run our application be sh-c. This means we are going to run the command using the shell, the Python manage py run server. Then we're going to run the server on our local host at port 8080. So this will run the Django development server available on all IP addresses that run on the Docker container. And it's going to run on port 8080, which is going to be mapped through the POS configuration on our local machine so we can run our application. So again, we are going to move on to our terminal and build the Docker Compose file. And what this does is it will build our image using the Docker Compose configuration, and this should not take too much time. So if we're going to build our Docker file, so now we're going to add sudo Docker Compose build. And as you can see, it's successfully built. Clear it out. So now we're going to use Docker Compose to create the project files for our application. And for that, you can either log in as super user or just type sudo. So Django admin.py, we're going to start project. Now, after running the command, you will realize that if you go into your empty app folder, which was the folder that you created initially and list out, it's not empty anymore. It has another app folder in it, which contains all of our app setup. I will show you. There you go. You have these files, 1, 2, 3, 4, 5 Python files, which is basically your Django app's entire setup, and all of this Docker created and set it up for you. So a teensy little detail, let's just open up our settings.py file, and we're going to go down to allowed hosts, and just in case it's empty between the close brackets, you can go ahead and add your local host or put in the asterisk, which allows all hosts. All right, so I'm just going to do that, and then I'm going to go back. And now all we have to do is deploy the application through your terminal. So we're going to go sudo docker compose up. So now, as you can see, your Django application is up and running. And all of this was possible because of Docker.
With the ever-changing requirements of modern software development, it is known that Kubernetes is one such system that will fulfill these needs. If you are someone who wants to get started with Kubernetes, you're definitely in the right place. Let us start off by understanding what it really is with the help of a simple example. Imagine you're building a web application. So within this web application, the structure might be monolithic. It might comprise several modules, components, or even layers. But externally, it is a single web application, or you could also say it is a single service. Despite having different modules, the application is built and deployed as one service for all platforms, that is desktop, personal computer, mobile, etc., within a single container that is a virtual machine. Let us assume the web application grows over time and becomes large. It is now extremely challenging to make changes over the code accurately. Also, the size of the application can slow down the startup time. Moving on, what if you want to add new updates to this web application? You must redeploy the entire application as one. And during this process, in case you stop and try to restart the service, the customers on your website will not be able to access anything for that period of time, which could eventually lead to a potential loss of money. Also, bugs in any one of the components can bring down the entire process. And since all the components of the application are identical, bugs can definitely impact the availability of the application. Now, what if you have a sudden spike in traffic and have to serve 20 times the number of your usual customers? In such a situation, you have to very quickly deploy new servers, which takes a lot of effort. Later, when traffic dies down to a normal level, you now have 20 times the number of your usual servers. It can also be challenging to scale when different modules have conflicting updates or resource requirements. So instead of creating a monolithic application, we can define each component as a separate, loosely coupled service. And then we could virtualize each of these services using a Docker container. Not only can the application start easily, but the services can also be deployed independently. With Docker containers, we can easily scale any number of instances up and down according to the application's requirements. But this is definitely easy to manage when we're dealing with just 3 or 4 containers. Now let's say we had to deal with 1,000 such containers. How do we really keep track of the containers that are healthy and the ones that are not? Orchestrating and managing these containers at the same time can be an extremely tedious task. And this led to the need for container orchestration tools. So this is where Kubernetes comes into the picture. Kubernetes was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. With Kubernetes, you package your website files as containers or pods, which you can run on any instance in your Kubernetes cluster. As you can see, pods are running on nodes, which are physical systems having hardware components that are a part of the Kubernetes cluster. This implies that every service that you create runs on separate containers, and this will allow you to work and manage services independently. Pods can be running on any available node in the cluster, which has enough resources for a pod to work. In simple words, Kubernetes is an open source system for automating deployment, rolling updates, scaling services, and managing containerized applications. Kubernetes works with Amazon EC2, Rackspace, GCP, IBM Cloud, etc. Also, hypergrowth companies like GitHub, Weaveworks, CloudBoost, Walmart are becoming acclimated to building, shipping, and managing containers via Kubernetes. On average, anyone with Kubernetes knowledge can expect to earn between 5 to 6 lakhs per annum in India, whereas they can expect an average salary of $140,000 per annum in USA. As the Fortune 500 are using Kubernetes, the demand for expertise in this field is rapidly increasing, which in turn requires IT professionals who can work on this tool. So what are you waiting for? Begin your journey with Edureka's interactive Kubernetes certification training that is curated to help you learn how to set up your own Kubernetes cluster, configure networking between pods, and secure the cluster against unauthorized access.
Why do we need Kubernetes? Now, to understand why do we need Kubernetes, let's understand what are the benefits and drawbacks of containers. Now, first of all, containers are good. They are amazingly good, right? Any container for that matter of fact, a Linux container or a Docker container or even a Rocket container, right? They all do one thing. They package your application and isolate it from everything else, right? They isolate the application from the host mainly. And this makes the container fast, reliable, efficient, lightweight, and scalable. Now, hold your thought. Yes, containers are scalable, but then there's a problem that comes with that. And this is what is the resultant of the need for Kubernetes. Even though containers are scalable, they are not very easily scalable. Okay, so let's look at it this way. You have one container, you might want to probably scale it up to 2 containers or 3 containers. Well, it's possible, right? It's going to take a little bit of manual effort, but yeah, you can scale it up. You're not going to have a problem. But then look at a real world scenario where you might want to scale up to like 50 to 100 containers. Then in that case, what happens? I mean, after scaling up, what do? You have to manage those containers, right? You have to make sure that they're all working, they're all active, and they're all talking to each other. Because if they're not talking to each other, then there's no point of scaling up itself. Because in that case, the servers would not be able to handle the loads if they're not able to talk to each other, correct? So it's really important that they are manageable when they are scaled up. And now let's talk about this point. Is it really tough to scale up containers? Well, the answer for that might be no. It might not be tough. It's pretty easy to scale up containers, but the problem is what happens after that. Okay. Once you scale up containers, you'll have a lot of problems. Like I told you, the containers first of all should have to communicate with each other because there are so many in number, and they work together to basically host the service, right? The application. And if they are not working together and talking together, then the application is not hosted and scaling up is a waste. So that's the number one reason. And the next is that the containers have to be deployed appropriately, and they have to also be managed. They have to be deployed appropriately because you cannot have the containers deployed in just random places. You have to deploy them in the right places. You cannot have one container in one particular cloud and the other one somewhere else. So that would have a lot of complications. Well, of course it's possible, but yeah, it would lead to a lot of complications internally. You want to avoid all that. So you have to have one place where everything is deployed appropriately, and you have to make sure that the IP addresses are set everywhere and the port numbers are open for the containers to talk to each other and all these things, right? So these were the two other points. The next point, or the next problem with scaling up, is that auto scaling is never a functionality over here. Okay. And this is one of the things which is the biggest benefit with Kubernetes. The problem technically is there's no auto scaling functionality. Okay, there's no concept of that at all. And you may ask at this point of time, why do we even need auto scaling? Okay, so let me explain the need for auto scaling with an example. So let's say that you are an e-commerce portal, okay, something like an Amazon or a Flipkart. And let's say that you have decent amount of traffic on the weekdays, but on the weekends you have a spike in traffic. Probably you have like 4x or 5x the usual traffic. And in that case, what happens is maybe your servers are good enough to handle the requests coming in on weekdays, right? But the requests that come on the weekends, right, from the increased traffic, that cannot be serviced by your servers, right? Maybe it's too much for your servers to handle the load. And maybe in the short term, it's fine. Maybe once or twice you can survive, but there will definitely come a time when your server will start crashing because it cannot handle that many requests per second or per minute. And if you want to really avoid this problem, what do? You have to scale up. And now, would you ideally keep scaling up every weekend and scaling down after the weekend, right? I mean, technically, is it possible? Will you be buying your servers and then setting it up, and every Friday would you be again buying new servers, setting up your infrastructure, and then the moment your weekday starts, would you just destroy all your servers, whatever you built? Would that what you be doing? No, right? Obviously, that's a pretty tedious task. So that's where something like Kubernetes comes in. And what Kubernetes does is it keeps analyzing your traffic and the load that's being used by the container. And as and when the traffic is reaching the threshold, auto scaling happens, wherein if the servers have a lot of traffic and if it needs more such servers for handling requests, then it starts scaling up the containers on its own. There's no manual intervention needed at all. So that's one benefit with Kubernetes, and one traditional problem that we have with scaling up of containers. Okay, and then the one last problem that we have is the distribution of traffic. That is still challenging without something that can manage your containers. I mean, you have so many containers, but how will the traffic be distributed? Load balancing, how does that happen? You just have containers, right? You have 50 containers. How does the load balancing happen? So all these are questions we should really consider, because containerization is all good and cool. It was much better than VMs. Yes, containerization, it was basically a concept which was sold on the basis of scaling up, right? We said that VMs cannot be scaled up easily, so we told use containers, and with containers you can easily scale up. So that was the whole reason we basically sold containers with the tagline of scaling up. But in today's world, our demand is ever more that even the regular containers cannot be enough. So scaling up is so much or in so detail that we need something else to manage your containers. Correct? Do we agree there? We need something, right? And that is exactly what Kubernetes is. So Kubernetes is a container management tool. All right. So this is open source, and this basically automates your container deployment, your container scaling and descaling, and your container load balancing. The benefit with this is that it works brilliantly with all the cloud vendors, with all your public cloud vendors, all your hybrid cloud vendors, and it also works on premises. So that is one big selling point of Kubernetes, right? And if I should give more information about Kubernetes, then let me tell you that this was a Google developed product. Okay, it's basically a brainchild of Google. And that pretty much is the end of the story for every other competitor out there, because the community that Google brings in along with it is going to be huge. Or basically the head start that Kubernetes would get because of being a Google brainchild is humongous. And that is one of the reasons why Kubernetes is one of the best container management tools in the market, period. And given that Kubernetes is a Google product, they have written the whole product on Go language. And of course, now Google has contributed this whole Kubernetes project to the CNCF, which is nothing but the Cloud Native Computing Foundation, or simply Cloud Native Foundation, right? You can just call them either that, and they've donated their open source project to them. And if I have to just summarize what Kubernetes is, you can just think of it like this. It can group like a number of containers into one logical unit for managing and deploying an application or a particular service. So that's a very simple definition of what Kubernetes is. It can be easily used for deploying your application. Of course, it's going to be Docker containers which you will be deploying. But since you will be using a lot of Docker containers as part of your production, you will also have to use Kubernetes, which will be managing your multiple Docker containers, right? So this is the role it plays in terms of deployment. And scaling up, scaling down is primarily the game of Kubernetes. From your existing architecture, it can scale up to any number you want. It can scale down anytime. And the best part is the scaling can also be set to be automatic, like I just explained some time back, right? You can make Kubernetes would analyze the traffic and then figure out if the scaling up needs to be done or the scaling down can be done, and all those things. And of course, the most important part, load balancing, right? I mean, what good is your container or group of containers if load balancing cannot be enabled, right? So Kubernetes does that also. And these are some of the points based on which Kubernetes is built. So I'm pretty sure you would have got a good understanding of what Kubernetes is by now, right? A brief idea at least. If you have any doubts, then I would request you to put your comments or queries on the comment section below. All right, my Edureka team will get back to you at the earliest. So moving forward, let's look at the features of Kubernetes. Okay, so we've seen what exactly Kubernetes is, how it uses Docker containers or other containers in general. But now let's see some of the selling points of Kubernetes, or why it's a must for you. Let's start off with automatic bin packing. When we say automatic bin packing, it's basically that Kubernetes packages your application and it automatically places containers based on their requirements and the resources that are available. So that's the number one advantage. The second thing, service discovery and load balancing. There is no need to worry. I mean, if you're going to use Kubernetes, then you don't have to worry about networking and communication, because Kubernetes will just automatically assign containers their own IP addresses and probably a single DNS name for a set of containers which are performing a logical operation. And of course, there will be load balancing across them. So you don't have to worry about all these things. So that's why we say that there is service discovery and load balancing with Kubernetes. And the third feature of Kubernetes is that storage orchestration. With Kubernetes, you can automatically mount your storage system of your choice. You can choose that to be either a local storage or maybe on a public cloud provider such as a GCP or AWS, or even a network storage system such as NFS or other things, right? So that was the feature number 3. Now, feature number 4, self-healing. Now, this is one of my favorite parts of Kubernetes. Actually, not just Kubernetes, even with respect to Docker Swarm, I really like this part of self-healing. What self-healing is all about is that whenever Kubernetes realizes that one of your containers has failed, then it will restart that container on its own, right? It will create a new container in place of this crashed one. And in case your node itself fails, then what Kubernetes would do in that case is whatever containers were running in that failed node, those containers would be started in another node, right? Of course, you would have to have more nodes in that cluster. If there's another node in the cluster, definitely room would be made for this failed container to start its service. So that happens. So the next feature is batch execution. So when we say batch execution, it's that along with services, Kubernetes can also manage your batch and CI workloads, which is more of a DevOps role, right? So as part of your CI workloads, Kubernetes can replace your containers which fail, and it can restart and restore the original state. That is what is possible with Kubernetes. And secret and configuration management. That is another big feature with Kubernetes. And that is the concept of where you can deploy and update your secrets and application configuration without having to rebuild your entire image and without having to expose your secrets in your stack configuration or anything, right? So if you want to deploy and update your secrets, only that can be done. So it's not available with all the other tools, right? So Kubernetes is one that does that. You don't have to restart everything and rebuild your entire container. That's one benefit. And then we have horizontal scaling, which of course you people might be aware of already. You can scale your applications up and down easily with a simple command. The simple command can be run on the CLI, or you can easily do it on your GUI, which is your dashboard, your Kubernetes dashboard, or auto scaling is possible, right? Based on the CPU usage, your containers would automatically be scaled up or scaled down. So that's one more feature. And the final feature that we have is automatic rollbacks and rollouts. Now, Kubernetes, what it does is whenever there's an update to your application which you want to release, Kubernetes progressively rolls out these changes and updates to the application or its configurations by just ensuring that one instance after the other is sent these updates. And it makes sure that not all instances are updated at the same time, thus ensuring that, yes, there is high availability. And even if something goes wrong, then the Kubernetes will roll back that change for you. So all these things are enabled, and these are the features with Kubernetes. So if you're really considering a solution for your containers, for managing your containers, then Kubernetes should be your solution, right? So that should be your answer. So that is about the various features of Kubernetes. Now, moving forward, here let's talk about a few of the myths surrounding Kubernetes. And we are doing this because a lot of people have confusion with respect to what exactly it is. So people have this misunderstanding that Kubernetes is like Docker, which is a containerization platform, right? That's what people think. And that is not true. So this kind of a confusion is what I intend to solve in the upcoming slides. I will talk about what exactly Kubernetes is and what Kubernetes is not. Let me start with what it's not. Now, the first thing is that Kubernetes is not to be compared with Docker because it's not the right set of parameters which you are comparing them against. Docker is a containerization platform and Kubernetes is a container management platform, which means that once you have containerized your application with the help of Docker containers or Linux containers, and when you are scaling up these containers to a big number like 50 or 100, that's where Kubernetes would come in. When you have like multiple containers which need to be managed, that's where Kubernetes can come in and effectively do it. You can specify the configurations and Kubernetes would make sure that at all times these conditions are satisfied. So that's what Kubernetes is. You can tell in your configurations that at all time I want these many containers running, I want these many pods running, and so many other needs, right? You can specify much more than that. And whatever you do, at all times, your cluster master or your Kubernetes master would ensure that this condition is satisfied. So that is what exactly Kubernetes is. But that does not mean that Docker does not solve this purpose. So Docker also have their own plugin. I wouldn't call it a plugin. It's actually another tool of theirs. So there's something called as Docker Swarm, and Docker Swarm does a similar thing. It does container management, like mass container management. So similar to what Kubernetes does, when you have like 50 to 100 containers, Docker Swarm would help you in managing those containers. But if you look at who is prevailing in the market today, I would say it's Kubernetes, because Kubernetes came in first, and the moment they came in, they were backed by Google, and they had this huge community which they just swept along with them. So they have like hardly left any market for Docker and for Docker Swarm. But that does not mean that they are better than Docker, because they are at the end of the day using Docker. So Kubernetes is only as good as what Docker is. If there are no Docker containers, then there's no need for Kubernetes in the first place. So Kubernetes and Docker, they go hand in hand. Okay, so that is the point you have to note. And I think that would have also explained the point that Kubernetes is not for containerizing applications, right? And the last thing is that Kubernetes is not for applications with a simple architecture. Okay, if your application's architecture is pretty complex, then you can probably use Kubernetes to uncomplex that architecture. Okay, but if you're having a very simple one in the first place, then using Kubernetes would not serve you any good, and it could probably make it a little more complicated than what it already is, right? So this is what Kubernetes is not. Now, speaking of what exactly Kubernetes is, the first point is Kubernetes is robust and reliable. Now, when I say robust and reliable, I'm referring to the fact that the cluster that is created, the Kubernetes cluster, right? This is very strong. It's very rigid, and it's not going to be broken easily. The reason being the configurations which you specify, right? At any point of time, if any container fails, a new container would come up, right? Or that whole container would be restarted. One of the things will definitely happen. If your node fails, then the containers which are running in a particular node, they would start running in a different node, right? So that's why it's reliable and it's strong, because at any point of time, your cluster would be at full force. And at any time, if it's not happening, then you would be able to see that something's wrong and you have to troubleshoot your node, and then everything would be fine. So Kubernetes would do everything possible, and it pretty much does everything possible to let us know that the problem is not at its end, and it's giving the exact result that we want. That's what Kubernetes are doing. And the next thing is that Kubernetes actually is the best solution for scaling up containers, at least in today's market, because the two biggest players in this market are Docker Swarm and Kubernetes. And Docker Swarm is not really the better one here, because they came in a little late. Even though Docker was there from the beginning, Kubernetes came after that. But Docker Swarm, which we are talking about, came in somewhere around 2016 or 2017, right? But Kubernetes came somewhere around 2015, and they had a very good head start. They were the first ones to do this, and their backing by Google is just icing on the cake, because whatever problem you have with respect to containers, if you just go up and if you put your error there, then you will have a lot of people on github.com and GitHub queries, and then on Stack Overflow, who will be resolving those errors, right? So that's the kind of market they have. So it's backed by a really huge community. That's what Kubernetes is. And to conclude this slide, Kubernetes is a container orchestration platform and nothing else. All right. So I think these two slides would have given you more information and more clarity with respect to what Kubernetes is and how different it is from Docker and Docker Swarm, right? If you guys still have any doubts, then I would request you to put your comments in the comment section below, and my team will get back to you at the earliest. Okay, so now moving on, let's go to the next topic, where we will compare Kubernetes with Docker Swarm. And we are comparing with Docker Swarm because we cannot compare Docker and Kubernetes head on. Okay, so that is what you have to understand. If you are this person over here, if you are Sam who is wondering which is the right comparison, then let me reassure you that the difference can only be between Kubernetes and Docker Swarm. Okay, so let's go ahead and see what the difference is actually. Let's start off with your installation and configuration. Okay, so that's the first parameter we'll use to compare these two. And over here, Docker Swarm comes out on top, because Docker is a little easier. You have around 2 or 3 commands which will help you have your cluster up and running. That includes the node joining the cluster, right? But with Kubernetes, it's way more complicated than Docker Swarm, right? So you have like close to 10 to 11 commands which you have to execute, and then there's a certain pattern you have to follow to ensure that there are no errors, right? Yes, and that's why it's time consuming, and that's why it's complicated. But once your cluster is ready, that time Kubernetes is the winner, because the flexibility, the rigidness, and the robustness that Kubernetes gives you cannot be offered by Docker Swarm. Yes, Docker Swarm is faster, but yes, not as good as Kubernetes when it comes to your actual working. And speaking of the GUI, once you have set up your cluster, you can use a GUI with Kubernetes for deploying your applications, right? So you don't need to always use your CLI. You have a dashboard which comes up, and the dashboard, if you give it admin privileges, then you can use it. You can deploy your application from the dashboard itself. Everything just drag and drop, click functionality, right? With just click functionality, you can do that. The same is not the case with Docker Swarm. You have no GUI in Docker Swarm, okay, period. So Docker Swarm is not the winner over here. It's Kubernetes. And yes, going to the third parameter, scalability. So people again have a bad misconception that Kubernetes is better. It is the solution for scaling up, and it is better and faster than Docker Swarm. Well, it could be better, but yes, it's not faster than Docker Swarm. Even if you want to scale up, right? There's a report where I recently read that the scaling up in Docker Swarm is almost 5 times faster than the scaling up with Kubernetes. So that is the difference. But yes, once your scaling up is done, after that, your cluster strength with Kubernetes is going to be much stronger than your Docker Swarm cluster strength. That's again because of the various configurations that should have been specified by then. That is the thing. Now, moving on to the next parameter we have is load balancing. Requires manual service configuration. Okay, this is in case of Kubernetes. And yes, this could be a shortfall, but with Docker Swarm, there is inbuilt load balancing techniques, which you don't need to worry about. Okay, even the load balancing, which requires manual effort in case of Kubernetes, is not too much. There are times when you have to manually specify what are your configurations. You have to make a few changes, but yes, it's not as much as what you're thinking. And speaking of updates and rollbacks, what Kubernetes does is it does the process scheduling to maintain the services while updating. Okay, yeah, that's very similar to how it works with Docker Swarm, wherein you have like progressive updates and service health monitoring happens throughout the update. But the difference is when something goes wrong, Kubernetes goes that extra mile of doing a rollback and putting you back to the previous state, right, before the update was launched. So that is the thing with Kubernetes. And the next parameter we are comparing those two upon is data volumes. So data volumes in Kubernetes can be shared with other containers, but only within the same pod. So we have a concept called pods in Kubernetes. Okay, now pod is nothing but something which groups related containers, right? A logical grouping of containers together. So that is a pod. And whichever containers are there inside this pod, they can have a shared volume, okay, like storage volume. But in case of Docker Swarm, you don't have the concept of pod at all. So the shared volumes can be between any other container. There is no restriction with respect to that in Docker Swarm. And then finally, we have this parameter called logging and monitoring. So when it comes to logging and monitoring, Kubernetes provides inbuilt tools for this purpose. Okay, but with Docker Swarm, you have to install third-party tools if you want to do logging and monitoring. So that is the fallback with Docker Swarm, because logging is really important. One, because you will know what the problem is, you'll know which container failed, what happened, where is exactly the error, right? So logs would help you give that answer. And monitoring is important because you have to always keep a check on your nodes, right? So as the master of the cluster, it's very important that there's monitoring. And that's where Kubernetes has a slight advantage over Docker Swarm. Okay, so that's my take on the difference between Kubernetes and Docker Swarm. And I would also love to hear what's your take on this, right? I would like to know if you would use Kubernetes or Docker Swarm, and I would also know why, if you prefer simplicity or if you prefer stability. That choice could be yours, and it's something that's arguable, right? It's a debatable topic. So I would like to hear what are your thoughts. So please drop in your comments at the bottom. We have a comment section, right? Our videos. So put it right there. And probably in one of our future videos, we will discuss about that. But before I finish this topic, there is this one slide I want to show you, which is about the statistics. So this stat, I picked it up from this Platform 9, which is nothing but a company that writes about tech. Okay, and what they've said is that the number of news articles that were produced, right, in that one particular year had 90% of those covered on Kubernetes compared to the 10% on Docker Swarm. Amazing, right? That's a big difference. That means for every one blog written or for every one article written on Docker Swarm, there are 9 different articles written on Kubernetes. And similarly for web searches. For web searches, Kubernetes is 90% compared to Docker Swarm's 10%. And publications, GitHub stars, the number of commits on GitHub, all these things are clearly won by Kubernetes everywhere. So Kubernetes is the one that's dominating this market, and that's pretty visible from this stat also, right? So I think that pretty much brings an end to this particular topic. Now moving forward, let me show you a use case. Let me talk about how this game, this amazing game called Pokemon Go, was powered with the help of Kubernetes. I'm pretty sure you all know what it is, right? You guys know Pokemon Go. It's the very famous game, and it was actually the best game of the year 2017. And the main reason for that being the best is because of Kubernetes. And let me tell you why. But before I tell you why, there are a few things which I want to just talk about. I'll give you a overview of what Pokemon Go is, and let me talk about a few key stats. So Pokemon Go is an augmented reality game developed by Niantic for your Android and for iOS devices. Okay, and those key stats read that they've had like 500 million plus downloads overall and 20 million plus daily active users. Now that is massive. Daily, if you're having like 20 million users plus, then you have achieved an amazing thing. So that's how good this game is. Okay, and then this game was actually initially launched only in North America, Australia, New Zealand. And I'm aware of this fact because I'm based out of India and I did not get access to this game because the moment news got out that we have a game like this, I started downloading it, but I couldn't really find any link or I couldn't download it at all. So they launched it only in these countries. But what they faced, right, in spite of just releasing it in these 3 countries, they had like a major problem. And that problem is what I'm going to talk about in the next slide. Right, so my use case is based on that very fact that in spite of launching it only in these 3 countries or in probably North America and then in Australia and New Zealand, they could have had a meltdown, but rather with the help of Kubernetes, they used that same problem as the basis for their success. So that's what happened. Now let that be a suspense, and before I get to that, let me just finish this slide. One amazing thing about Pokemon Go is that it has inspired users to walk over 5.4 billion miles in a year. Okay, yes, do the math. 5.4 billion miles in 1 year. That's again a very big number. And it says that it has surpassed engineering expectations by 50 times. Now, this last line is not with respect to the Pokemon Go, the game, but it is with respect to the backend and the use of Kubernetes to achieve whatever was needed. Okay, so I think I've spent enough time over here. Let me go ahead and talk about the most interesting part and tell you how the backend architecture of Pokemon Go was. Okay, so you have a Pokemon Go container which had 2 primary components. One is your Google Bigtable, which is your main database where everything is going in and coming out. And then you have your programs, which is run on your Java cloud, right? So these 2 things are what is running your game. MapReduce and Cloud Dataflow were something which was used for scaling up. Okay, so it's not just the container scaling up, but it's with respect to the application, how the program would react when there are these increased number of users and how to handle increased number of requests. So that's where the MapReduce is the paradigm comes in, right? The mapping and then reducing that whole concept. So this was their one deployment. Okay, and when we say into 5, it means that they had their server capacities which could go up till 5 times. Okay, so technically they could only serve X number of requests, but in case of failure conditions or heavy traffic load conditions, the max the server could handle was 5x, because after 5x the server would start crashing. That was their prediction. Okay, and what actually happened at Pokemon Go on releasing in just those 3 different geographies is that the moment they deployed it, the usage became so much that it was not X number of times, which is technically their failure limit, and it is not even 5x, which is the server's capability, but the traffic that they got was up to 50 times more than what they expected. So you know that when your traffic is so much, then you're going to be brought down to your knees. That's a definite and that's a given, right? This is like a success story, and this is too good to be true kind of a story. And in that kind of a scenario, if the requests start coming in are so much that if they reach 50x, then it's gone, right? The application is gone for a toss. So that's where Kubernetes comes in, and they overcome all the challenges. How do they overcome the challenges? Because Kubernetes can do both vertical scaling and horizontal scaling at ease. And that is the biggest problem, right? Because any application and any other company can easily do horizontal scaling, where you just spin up more containers and more instances and you set up the environment. But vertical scaling is something which is very specific, and this is even more challenging. Now it's more specific to this particular game because the virtual reality would keep changing. Whenever a person moves around or walks around somewhere in his apartments or somewhere on the road, then the RAM, right, that would have to increase. The memory, the in-memory and the storage memory, all this would increase. So in real time, your server's capacity also has to increase vertically. So once they have deployed it, it's not just about horizontal scalability anymore. It's not about satisfying more requests. It's about satisfying that same request with respect to having more hardware space, more RAM space, and all these things, right? That one particular server should have more performance abilities. That's what it's about. And Kubernetes solved both of these problems effortlessly. And Niantic were also surprised that Kubernetes could do it. And that was because of the help that they got from Google. I read an article recently that the head of Niantic's lab, he met with some of the top executives in Google and in GCP, right? and then they figure out how things are supposed to go. And they of course met with the heads at Kubernetes, and they figured out a way to actually scale it up to 50 times in a very short time. So that is the challenge that they were presented, and thanks to Kubernetes, they could handle 50 times the traffic that they expected, which is like a very one-off story, and which is very, very surprising that something like this would happen. So that is about the use case, and that pretty much brings an end to this topic of how Pokemon Go used Kubernetes to achieve something. Because in today's world, Pokemon Go is a really revered game because of what it could, right? It basically beat all the stereotypes of a game, and whatever anybody could have anything negative against the game, right? So they could say that these mobile games and video games make you lazy, they make you just sit in one place and all these things, right? And Pokemon Go was something which was different. It actually made people walk around, and it made people exercise, and that goes on to show how popular this game became. If Kubernetes lies at the heart of something which became so popular and something that became so big, then you should imagine how big Kubernetes or how useful Kubernetes is, right? So that is about this topic. As said before, Kubernetes master controls your nodes, and inside nodes you have containers, okay? And now these containers are not just contained inside them, but they are actually contained inside pods, okay? So you have nodes inside which there are pods, and inside each of these pods there will be n number of containers depending upon your configuration and your requirement, right? Now these pods which contain n number of containers are a logical binding or a logical grouping of these containers. Supposing you have an application X which is running in node 1, okay? So you will have a pod for this particular application, and all the containers which are needed to execute this particular application will be a part of this particular pod, right? So that's how pod works, and that's what the difference is with respect to Docker Swarm and Kubernetes. Because in Docker Swarm you will not have a pod, you just have containers running on your node. And the other two terminologies which you should know is that of replication controller and service. Your replication controller is the master's resource to ensuring that the requested number of pods are always running on the nodes, right? So that's like a confirmation or an affirmation which says that, okay, this many number of pods will always be running, and these many number of containers will always be running, something like that, right? So you say it, and the replication controller will always ensure that's happening. And your service is just an object on the master that provides load balancing across a replicated group of pods, right? So that's how Kubernetes works. And I think this is good enough introduction for you. And I think now I can go to the demo part, right, guys? If you guys have any doubts, I would request you to again put it in the comment section, and my team will get back to you. And in the meanwhile, let me get to the final part of this video, wherein I will show you how to deploy applications on your Kubernetes via either your CLI or either via your YAML files or via your dashboard. Okay, guys, so let's get started. And for the demo purpose, I have two VMs with me, okay? So as you can see, this is my kube master, which would be acting as my master in my cluster. And then I have another VM, which is my kube node 1, okay? So it's a cluster with one master and one node, all right? Now, for the ease of purpose for this video, I have compiled the list of commands in this text document, right? So here I have all the commands which are needed to start your cluster, and then the other configurations and all those things. So I'll be using these. I'll be copying these commands, and then I'll show you side by side, and I will also explain when I do that as to what each of these commands mean. Now, there's one prerequisite that needs to be satisfied, and that is the master should have at least 2 core CPUs, okay, and 4 GB of RAM. And your node should have at least 1 core CPU and 4 GB of RAM. So just make sure that this much of hardware is given to your VMs, right? If you're using Ubuntu or a Linux operating system, well and good. But if you're using a VM on top of a Windows OS, then I would request you to satisfy these things, okay? These two criteria. And I think we can straight away start. Let me open up my terminal first of all. Okay, this is my node. I'm going back to my master. Okay, yes. So first of all, if you have to start your cluster, you have to start it from your master's end, okay? And the command for that is kube adm init. You specify the pod network flag and the API server flag. We are specifying the pod network flag because the different containers inside your pod should be able to talk to each other easily, right? So that was the whole concept of self-discovery, which I spoke about earlier during the features of Kubernetes. So for the self-discovery, we have like different pod networks using which the containers would talk to each other. And if you go to the documentation, the Kubernetes documentation, you can find a lot of options there. You can use either Calico, pod, or you can use a flannel pod network. So when we say pod network, it's basically acronymed as CNI, okay, Container Network Interface, okay. So you can use either a Calico CNI or a flannel CNI or any of the other ones. These are the two popular ones, and I will be using the Calico CNI, okay. So this is the network range for this particular pod, and this we'll have to specify over here, okay. And then over here we'll have to specify the IP address of the master. So let me first of all copy this entire line, and before I paste it here, let me do an if config and find out what is the IP address of this particular machine, of my master machine. The IP address is 192.168.56.101, okay. So let's just keep that in mind, and let me paste the command over here in place of the master IP address. I'm going to specify the IP address of the master, okay, which I just read out. It is 192.168.56.101, and the pod network, I told you that I'm going to use the Calico pod. So let's copy this network range and paste it here. So all my containers inside this particular pod would be assigned an IP address in this range, okay. Now let me just go ahead and hit enter, and then your cluster would begin to set up. So it's going as expected. So it's going to take a few minutes, so just hold on there. Okay, perfect. My Kubernetes master has initialized successfully, and if you want to start using your cluster, you have to run the following as a regular user, right? So we have 3 commands which is suggested by Kubernetes itself, and that is actually the same set of commands that even I have here, okay. So I'll be running the same commands. This is to set up the environment, and then after that we have this token generated, right, the joining token. So the token along with the init address of the IP of the master, if I basically execute this command in my nodes, then I will be joining this cluster where this is the master, right? So this is my master machine. This just created the cluster. So now before I do this though, there are a few steps in the middle. One of those steps is executing all these 3 commands, and after that comes bringing up the dashboard and setting up the pod network, right? Mine is the Calico pod, so I'll have to set up the Calico pod, and then I have to also set up the dashboard. Because if I do not start the dashboard and this before the nodes, then the node cannot join, and I will have various other complications. So let me first of all go ahead and run these 3 commands one after the other, okay. Since I have the same commands in my text doc, I'll just copy it from there, okay. I'll say Control C, paste, enter, okay, and I'll copy this line. So remember, you have to execute all these things as regular user, okay. You can probably use your sudo, but yeah, you'll be executing it as your regular user. And it's asking me if I want to override the existing whatever is there in this directory. I would say yes, because I've already done this before. But if you are setting up the cluster for the first time, you will not have this prompt, okay. Now let me go to the 3rd line, copy this and paste it here, okay, perfect. Now I've run these 3 commands as I was told by Kubernetes. Now the next thing that I have to do is, before I check the node status and all these things, let me just set up the network, okay, the pod network. So like I said, this is the line, this is the command that we have to run to set up the Calico network, okay, to allow the nodes to join our particular network. So it will be copying the template of this calico.yaml file which is present over here in this docs, okay. So hit enter, and yes, my thing is created. Calico cube controller is created. Now I'll just go back here and see, at this point of time I can check if my master is connected to the particular pod, okay. So I can run the kubectl get nodes command, okay. This would say that I have one particular resource connected to the cluster, okay, name of the machine, and this role is master, and yeah, the status is ready, okay. If you want to get an idea of all the different pods which are running by default, then you can do the kubectl get pods along with a few options, okay. You should specify these flags, and they are all namespaces, and with the flag O specify wide, okay. So this way I get all the pods which are started by default, okay. So there are different services like etcd for kube controllers, for the Calico node, for the etcd master. For every single service there's a separate container and pod started, okay. So that's what you can understand from this part, okay. That is the safe assumption. Now that we know the cluster is ready and the master is part of the cluster, let's go ahead and execute this dashboard, okay. Remember, if you want to use a dashboard, then you have to run this command before your nodes join this particular cluster. because the moment your nodes join into the cluster, bringing up the dashboard is going to be challenging and it will start throwing errors. Okay, it will say that it's being hosted on the node, which we do not want. We want the dashboard to be on the server itself, right, on the master. So first, let's bring the dashboard up. So I'm going to copy this and paste it here. Okay, enter. Great. My Kubernetes dashboard is created. Now, the next command that you have to get your dashboard up and running is kubectl proxy. Okay. With this, you'll get a message saying that it's being served at this particular port number. And yes, you are right now there. You can, if you access localhost, what was the port number again? Localhost, yeah, 127.0.0.1 is localhost. Okay, followed by port number 8001. Okay. Yeah, so right now we are not having the dashboard because it is technically accessed on another URL. But before we do that, there are various other things that we have to access. I mean, we have to set. Okay, because right now we have only enabled the dashboard. Now, if you want to access the dashboard, you have to first of all create a service account. Okay, the instructions are here. Okay, you have to first of all create a service account for your dashboard. Then you have to say that, okay, you are going to be the admin user of this particular service account, and you have to enable that functionality here. You should say dashboard admin privileges, and you should do the cluster binding. Okay, the cluster role binding is what you have to do. And after that, to join to that or to get access to that particular dashboard, we have to basically give a key. Okay, it's like a password. So we have to generate that token first, and then we can access the dashboard. So again, for the dashboard, there are these 3 commands. Well, you can get confused down the line, but remember, this is separate from the above. Okay, so what we did initially is ran these 3 commands which Kubernetes told us to execute, and after that the next necessity was bring up a pod. So this was that command for the pod, and then this was the command for getting the dashboard up, and right after that run the proxy, and then on that particular port number it'll start being served. So my dashboard is being served, but I'm not getting the UI here, and if I want to get the UI, I have to create the service account and do these 3 things, right? So let's start with this and then continue. I hope this wasn't confusing, guys. Okay, I can't do it here, so let me open a new terminal. Okay, here I'm gonna paste it, and yes, service account created. Let me go back here and execute this command where I'm doing the role binding. I'm saying that my dashboard should have admin functionalities, and that's going to be the cluster role. Okay, cluster admin, and then the service account is what I'm using, and it's going to be in default namespace. Okay, so when I created the account, I said that I want to create this particular account in default namespace. So the same thing I'm specifying here. Okay, dashboard admin created. Good. So let's generate the token that is needed to access my dashboard. Okay, before I execute this command, let me show you that once. So if you go to this URL, right, /API/v1/namespaces. Yep, let me show it to you here. Okay, so this is the particular URL where you will get access to the dashboard. Okay, login access to the dashboard, localhost 8001 API v1 namespaces /kubesystem/services/https Kubernetes dashboard :/proxy. Okay, remember this one. That is the same thing over here, and like I told you, it's asking me for my password, so I would say token, but let me go here and hit the command and generate the token. So this is the token. I'm gonna copy this from here till here. I'm gonna say copy, and this is what I have to paste over here. All right, so sign and update. Yes, perfect. So this is my dashboard, right? This is my Kubernetes dashboard, and this is how it looks like. Whatever I want, I can get an overview of everything. So there is workloads. If I come down, there is deployments. I have option to see the pods, and then I can see what are the different services running among most of the other functionalities. Okay, so right now we don't have any bar graph or pie graph showing you which cluster is up, which pod is up and all, because I have not added any node and there is no service that is running, right? So I mean, this is the outlay of the dashboard. Okay, you will get access to everything you want from the left. You can drill down into each of these namespaces or pods or containers, right? Now, if you want to deploy something through the dashboard, right, through the click functionality, then you can go here. Okay, but before I create any container or before I create any pod or any deployment for that matter of fact, I have to have nodes, because these will be running only on nodes, correct? Whatever I deploy, they run only on nodes. So let me first open up my node and get the node to join this particular cluster of mine. Now, if you remember, the command to join the node got generated at the master end, correct? So let me go and fetch that again. So that was the first command that we ran, right? This one. So Let's just copy this and paste this one at my node end. This is the IP of my master, and it will just join at this particular port number. Let me hit enter. Let's see what happens. Okay, let me run it as root user. Okay, perfect. Successfully established connection with the API server, and it says this node has joined the cluster, right? Bingo. So this is good news to me. Now if I go back to my master, and in fact if I open up the dashboard, there would be an option of nodes, right? So initially now it's showing this master. Master is the only thing that is part of my nodes. Let me just refresh it, and you would see that even node-1 would be a part of it, right? So there are two resources, two instances. One is the master itself and the other is the node. Now if I go to overview, you will get more details. If I start my application, if I start my servers or containers, then all those would start showing up here, right? So it's high time I start showing you how to deploy it. To deploy it using the dashboard, I told you this is the functionality. So let's go ahead and click on this create. And yeah, mind you, from the dashboard is the easiest way to deploy your application, right? So even developers around the world do the same thing. For the first time, probably they create it using the YAML file, and then from there on, they start editing the YAML file on top of the dashboard itself, or they create or deploy the application from here itself. So we'll do the same thing. Go to create an app using functionality, click functionality, you can do it over here. So let's give a name to your application. I'll just say Edureka demo. Okay, let that be the name of my application. And I want to basically pull an Nginx image. Okay, I want to launch an Nginx service. So I'm going to specify the image name in my Docker hub. Okay, so it says either the URL of a public image or any registry, or a private image hosted on Docker hub or Google Container Registry. So I don't have to specify the URL per se, but if you're specifying a Docker hub, if you're specifying this image to be pulled from Docker hub, then you can just use the name of the image which has to be pulled. That's good enough, right? Nginx is the name, and that's good enough. And I can choose to set my number of pods to 1 or 2. In that way, I will have 2 containers running in the pod, right? So this is done. And the final part is actually, without the final part, I can straight away deploy it. Okay, but if I deploy it, then my application would be created, but I would just not get the UI. I mean, I won't see the Nginx service. So that I get the service, I have to enable one more functionality here. Okay, the servers here, click on the drop down, and you will have external option, right? So click on external. This would let you access this particular service from your host machine, right? So that is the definition. So you can see the explanation here. An internal or external service can be defined to map an incoming port to a target port seen by the container. So Nginx, which would be hosted on one of the container ports that could not be accessible if I don't specify anything here. But now that I've said access it externally on a particular port number, then it would get mapped for me. By default, Nginx runs on port number 80. So the target port would be the same, but the port I want to expose it to, that I can map it to anything I want. So I'm going to say 82. All right. So that's it. It's as simple as this. This way your application is launched with 2 pods. So I can just go down and click on deploy. And this way my application should be deployed. My deployment is successful. There are 2 pods running. So what I can do is I can go to the service and try to access the UI, right? So it says that it's running on this particular port number 82153. So copy this and say localhost 32153. Okay, hit enter. Bingo. So it says welcome to Jenkins, and I'm getting the UI, right? So I'm able to access my application which I just launched through the dashboard. It was as simple as that. So this is one way of launching or making a deployment. There are 2 other ways, like I told you. One is using your CLI itself, your command line interface of your Linux machine, which is the terminal, or you can do it by uploading the YAML file. You can do it by uploading the YAML file because everything here is in the form of YAML or JSON. Okay, that's like the default way. So whatever deployment I made, right, that also, those configurations are stored in the form of YAML. So if I click on view or edit YAML, all the configurations I specified, the default ones have been taken. So I said the name should be Edureka demo. That is what has been taken over here. That is the name of my deployment. Okay, so kind is deployment. The version of my API, it's this one, extension / v1 beta 1. And then under metadata, I have various other lists. So if you know how to write a YAML file, then I think it will be a little more easier for you to understand and create your deployment, because YAML file is everything about lists and maps. and these YAML files are always lists about maps and maps about lists. So it might be a little confusing. So probably we'll have another tutorial video on how to write a YAML file for Kubernetes deployment, but I would keep that for another session. Okay, let me get back to this session and show you the next deployment. Okay, the next deployment technique. So let me just close this and go back to overview. Okay, so I have this one deployment. Very good. Okay, so let's go to this. Yeah, so what I'll do is let me delete this deployment. Okay, or let me at least scale it down, because I don't want too many resources to be used on my node also, because I will have to show 2 more deployments, right? So I have reduced my deployment over here, and I think it should be good enough. Great. So let's go back to the kube setup, this document of mine. So this is where we were, right? We could check our deployments, we could do all these things. So one thing which I might have forgotten is showing the nodes which are part of the cluster, right? So this is my master. Yeah, so I kind of forgot to show you this kubectl get node. So the same view that you got on your dashboard, you get it here also. I mean, these are the 2 nodes, and this is the name and all these things. Okay, and I can also do the kubectl get pods, which would tell me all the pods that are running. Edureka demo is the pod which I have started. Okay, this is my pod. Now if I specify with the other flags, right, with all namespaces and with wide, then all the default pods which get created along with your Kubernetes cluster, those will also get displayed. Let me show you that also, just in case. Okay, yeah, so this is the one which I created, and the other ones are the default deployments that come with Kubernetes. The moment you install set up the cluster, these get started. Okay, and if you can see here, this particular Edureka demo which I started is running on my node 1 along with this kube proxy and this particular Calico node. So these 2 services are running on master and node, and this one is running only on my node 1, right? You can see this, right? The Calico node runs both on my node over here and on my master, and similarly the kube proxy runs on my node here and on my master. So this is the one that's running only on my node. Okay, so getting back to what I was about to explain you, the next part is how to deploy anything through your terminal. Now to deploy your same Nginx application through your CLI, we can follow these set of commands. Okay, so there are a couple of steps here. First of all, to create a deployment, you have to run this command. Okay, kubectl create deployment Nginx, and then the name of the image that you want to create. This is going to be the name of your deployment, and this is the name of the image which you want to use. So Control C, and let me go to the terminal here. On my master, I'm executing this command, kubectl create deployment. Okay, so the deployment Nginx is created. If you want, we can verify that also over here. So under deployments, right now we have 1 entry, Edureka demo, and yes, now you can see there are 2, Nginx and Edureka demo. So this is pending. I mean, it would take a few seconds. So in the meanwhile, let's just continue with the other steps. Once you have created your deployments, you have to create the service. Okay, you have to say which is the node port which can be used to access that particular service, right? Because deployment is just a deployment. You're just deploying your container. If you want to access it, like I told you earlier, from your from your host machine or all those things, then you have to enable the node port. If you want to get your deployments on your terminal, you can run this command, kubectl get deployments. Okay, Nginx also comes up over here, right? If you want more details about your deployment, you can use this command, kubectl describe. You'll get like more details about this particular deployment as to what is the name, what is the port number it's residing on, and all these things. Okay, let's not complicate this. You can probably use that for your understanding later. So once that is done, the next thing that you have to do is you have to create the service on the nodes. You have created the deployment, but yes, create the service on the nodes using this particular command, kubectl create service and say node port. Okay, this means you want to access it at this particular port number. You're doing the port mapping 80 is to 80. Okay, container port 80 to the internal node port 80. Okay, so service for Nginx is created. And if you want to check which of the deployments are running in which nodes, you can run the command kubectl get svc. Okay, this would tell you, okay, you have 2 different services, Edureka demo and Nginx, and they are running on these port numbers and on these nodes, right? So Kubernetes is the one which got created automatically. Edureka demo is the one which I created. Okay, Nginx is again the one which I created. Kubernetes comes up on its own. I'm just specifying to you because this is a container for the cluster itself. Okay, so let's just go back here, and then yes, and similarly, if you want to delete a deployment, then you can just use this command kubectl delete deployment followed by the name of the deployment. Right, it's pretty simple. You can do it this way. Otherwise, from the dashboard also you can delete it, like how I showed you earlier. Click over here and then you can click on delete, and then if you want to scale it, you can scale it. So both of these deployments of mine have one pod each, right? So let's do one thing. So let's just go to the Nginx service, and here let's try accessing this particular service. Localhost. Okay, perfect. Here also it says welcome to Nginx, right? So with this you can understand that the port mapping worked, and by going to service you will get to know on which port number you can access it on your host machine, right? So this is the internal container port mapped to this particular port of mine. Okay, now if not for this, if this doesn't work, you can also use the cluster IP for the same thing. Cluster IP is going to basically the IP using which all your containers access each other, right? So for your pod you will have an IP, so whatever is running in your containers, that will again be accessible on your cluster IP. So it's the same thing, right? So let me just close these pages, and that's how you deploy an application through your CLI. So this comes to our last part of this video, which is nothing but deployment via YAML file. So for again deployment via YAML file, you have to write your YAML code, right? You have to either write your YAML code or your JSON code, correct? So this is the code which I have written, which is in YAML format, and in fact I already have it in my machine here. So how about I just do an ls? Yeah, there is deployment.yaml, right? So let me show you that. So this is my YAML file. Okay, so here I specify various configurations similar to how I did it using the GUI, or I did it using the CLI. It's something similar. It's just that I specify everything in one particular file. Here, if you can see that I've specified the API version. Okay, so I'm using extensions dot slash b1 or beta 1. Okay, I can do this, or I can just simply specify version 1. I can do either of those. And then the next important line is the kind. So kind is important because you have to specify what kind of file it is. Is it a deployment file, or is it for a pod deployment, or is it for your container deployment, or is it the overall deployment? What is it? So I've said deployment, okay, because I want to deploy the containers also along with the pod. So I'm saying deployment. In case you want to deploy only the pod, which you realistically don't need to, okay, why would you just deploy a pod? But in case if you want to deploy a pod, then you can go ahead and write pod here and then just specify what are the different containers. Okay, but in my case it's a complete deployment, right, with the pods and the services and the containers. So I will go ahead and write other things, and under the metadata I will specify the name of my application. I can specify what I want. I can put my name also over here, like Vardhan. Okay, and I can save this. And then the important part is this spec part. So here is where you set the number of replicas. Do you remember I told you that there's something called as replication controller, which controls the number of pods that you will be running? So it is that line. So if I've set 2 over here, it means that I will have 2 pods running of this particular application of Vardhan. Okay, what exactly am I doing here? Under spec, I'm saying that I want 2 containers. So I've intended a container line over here, and then I have 2 containers inside. So the first container which I want to create is of the name front end. Okay, and I'm using an Nginx image. And similarly, the port number that this would be active on is container port 80. All right, and then I'm saying that I want a second container, and the container for this I could rename this to anything. I can say backend, and I can choose which image I want. I can probably choose a HTTPD image also. Okay, and I can again say the ports that this will be running on. I can say the container port that it should run on is port number is 88, right? So that's how simple it is. All right, and since it's your first video tutorial, the important takeaways from this YAML file configuration is that under spec you'll have to specify the containers, and yes, everything in JSON format with all the indentations and all these things. Okay, even if you have an extra space anywhere over here, then your YAML file would throw an invalid error. So make sure that is not there. Make sure you specify the containers appropriately. If it's going to be just 1 container, well and good. If it's 2 containers, make sure you indent it in the right way, and then you can specify the number of pods you want to give a name to your deployment, and mainly establish these rules. Okay, so once you're done with this, just save it and close this YAML file. Okay, so this is your deployment.yaml. Now you can straight away upload this YAML file to your Kubernetes, okay, and that way your application would be straight away deployed. Okay, now the command for that is kubectl create -f and the name of the file. Okay, so let me copy this, and then the name of my file is deployment.yaml. So let me hit enter. Perfect. So my deployment, the third deployment, Vardhan, is also created, right? So we can check our deployments from the earlier command, that is nothing but kubectl get deployments. Okay, it's not get deployment.yaml, sorry, it's get deployments. And as you can see here, there is an Edureka demo, there is Nginx, and there is Vardhan. And the funny thing which you should have noticed is that I said I want 2 replicas, right? 2 pods. So that's why the desired is 2. Currently we have 2, up to date is 1. So okay, up to date is 2. Brilliant. Available is 0 because let's just give it a few seconds. In 23 seconds, I don't think the pod would have started. So let's go back to our dashboard and verify if there's a third deployment that comes up over here. Okay, perfect. So that's how it's going to work. Okay, so probably it's going to take some more time because the container is just restarting. So let's just give it some more time. This could well be because of the fact that my node has very less resource, right? So I have too many deployments. That could be the very reason. So what I can do is I could go ahead and delete other deployments so that my node can handle these many containers and pods, right? So let me delete this particular deployment, Nginx deployment. And let me also delete this Edureka demo deployment of mine. Okay, now let's refresh and just wait for this to happen. Okay, so what I can do instead is I could have a very simple deployment, right? So let me go back to my terminal and let me delete my deployment. Okay, and let me redeploy it again. So kubectl delete deployment. Okay, so Vardhan, this deployment has been deleted. Okay, so let's just clear the screen and let's do gedit of the YAML file again. And here let's make things simpler. Let me just delete this container from here. Let me save this. All right, and close this. Now let me create a deployment with this. Okay, so Vardhan is created. Let me go up here and refresh. Let's see what happens. Okay, so this time it's all green because it's all healthy. My nodes are successful, or at least it's going to be successful. Container creating. Perfect. So 2 pods of mine are up and running, and both my pods are running, right? And both are running on node 1. Pods 2 out of 2. Those are the 2 deployments, and replica set, and then services, right? So it's Nginx, which is the base image which is being used. So well and good. This is also working. So guys, yeah, that's about it, right? So when I tried to upload it, maybe there was some other error, probably in the YAML file. There could have been some small mistake, or it could have been because my node had too many containers running. Those could have been the reasons. But anyways, this is how you deploy it through your YAML file.
Let's look into the architecture of Kubernetes. Kubernetes architecture has mainly 3 components: the master nodes, the worker nodes, and the distributed key value stores like etcd. Talking about the master node is responsible for managing the Kubernetes cluster, and it is the entry point for all the administrative tasks. So we can communicate to the master node via the CLI or GUI or APIs. So for the fault tolerance purposes, there can be more than one master node in the cluster, and if we have more than one master node, then there would be high availability mode and only one of them will be the leader performing all the operations. All the other master nodes would be the followers of that node. Also, to manage the cluster state, Kubernetes uses etcd and all the master nodes connect to it. So etcd is a distributed key value store, which I'll tell you in a little while. Also, let me tell you that the key value store can be the part of the master node, and it can also be configured externally, and in that case, master nodes would connect to it. So now that I've told you what a master node is and what are the responsibilities of the master node, let's discuss the components of master nodes. A master node has mainly 4 components: the API server, the scheduler, the control manager, and etcd. So now let me tell you about all these components one by one. So starting with API server, all the administrative tasks are performed via the API server within the master node. A user sends the REST commands to the API server, which then validates and processes the request. After executing the request, The resulting state of the cluster is stored in the distributed key value store. After that, we have scheduler. So as the name suggests, the scheduler schedules the work to different worker nodes. The scheduler has the resource usage information for each worker node and also knows about the constraints that the users may have set. Before scheduling the work, the scheduler also takes into account the quality of service requirements, data locality, affinity, anti-affinity, and many other such parameters, and then the scheduler schedules the work in terms of pods and services. The next component that we have is controller manager. Now, what do you think are the responsibilities of controller manager? Well, as the name suggests, controller manager manages different non-terminating control loops which regulate the state of the Kubernetes cluster. Now, each one of these control loops know about the desired state of the object it manages, and then they watch their current state through the API servers. Now, in a control loop, if the current state of the object it manages does not meet the desired state, then the control loop itself takes the corrective steps to make sure that the current state is same as the desired state. So what does a controller manager do? It basically makes sure that your current state is same as the desired state. After that, the last component that we have is etcd. So as I mentioned earlier, etcd is a distributed key value store which is used to store the cluster state. So either it has to be a part of the Kubernetes master or you can configure it externally. So guys, that were the various components of master node. Now, let's move on to the next component of Kubernetes architecture, that is the worker node. A worker node is a machine or a virtual machine or any physical server which runs the applications using pods and is controlled by the master node. So you understand the master-slave concept. It has its own machine, but yes, it is controlled by the master node. Now, pods are scheduled on the worker nodes which have the necessary tools to run and connect them. So you can say that the pod is basically the scheduling unit in Kubernetes. It is a logical collection of one or more containers which are always scheduled together, and to access the applications from the external world, we have to connect to the worker nodes and not the master nodes. So now that I've briefed you about the worker node, let's discuss the various components of worker node. So a worker node has mainly three components: the kubelet, the kubeproxy, and container runtime. So let's start the discussion with container runtime. So a container runtime is basically used to run and manage a container's lifecycle on the worker node. So some examples of container runtimes that I can give you are the container, RKT, LXT, etc. Now, it is often observed that Docker is also referred to as container runtime. But to be precise, let me tell you that Docker is a platform which uses containers as container runtime. Alright, so now that you've understood what container runtime is, let's move on to the second component, that is kubelet. So kubelet is basically an agent which runs on each worker node and communicates with the master node. So if you have 10 worker nodes, then kubelet runs on each and every worker node. Then it receives the pod definition via various means and runs the containers associated with that pod. It also makes sure that the containers which are part of the pods are healthy at all times. So what does a kubelet do? It basically runs in all the containers. It makes sure that your containers which are part of various pods are always healthy at all times. So the kubelet connects to the container runtime using the container runtime interface, which consists of various protocol buffers, gRPC APIs, and libraries. So as you can see on the screen, the kubelet connects to the CRI shim to perform containers and image operations. Now, CRI implements two services, that is the runtime service and the image service. The image service is responsible for all the image-related operations, while the runtime service is responsible for all the pod and container-related operations. So these two services have two different operations to perform. Now let me tell you something interesting here. Container runtimes used to be hard-coded in Kubernetes, but with the development of CRI, Kubernetes can now use different container runtimes without the need to recompile. So any container runtime that implements CRI can be used by Kubernetes to manage pods, containers, and container images. So now let me give you an example of a CRI shims. So Docker shim and CRI container are two examples of CRI shim. With Docker shim, containers are created using Docker installed on the worker nodes, and then internally Docker uses container to create and manage containers. With CRI container, we can directly use Docker's small offspring containers to create and manage containers. So these were two simple examples of CRI shims. Now let's move on to the third component of worker node, that is kubeproxy. So kubeproxy is the network proxy which runs on each worker node and then listens to the API server for each service point creation or deletion. So for each service point, kubeproxy sets the route so that it can reach to it. So guys, that were the components of the worker node. So now let me move on with the session by discussing the third component of Kubernetes architecture, that is etcd. So as I mentioned before, Kubernetes uses the etcd to store the cluster state. So etcd is a distributed key value stored based on the raft consensus algorithm. So the raft allows a collection of machines to work as a coherent group that can survive the failures of some of its members. So basically this algorithm works in such a way that even if some of the members fail to work, it can still work. At any given time, one of the nodes in the group will be the master and rest of them will be the follower. As I told you before in the starting of the session, that there can be only one master and all the other masters have to follow that master, right? Not only this, but let me tell you that etcd is written in the Go programming language. Besides storing the cluster state, etcd is also used to store the configuration details such as the subnets and the config maps.
What is Docker? Docker is a containerization platform that packages your application and all its dependencies together in form of a Docker container to ensure that your application works seamlessly in any environment. It is basically an open platform for developing, shipping, and running applications. Now, Docker enables you to separate your applications from your infrastructure so you can deliver software very quickly. With Docker, you can also manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code very quickly, you can significantly reduce the delay between writing code and running it in production. Basically provides the ability to package and run an application in a loosely isolated environment called a container. The isolation and security allow you to run many containers simultaneously on a given host. As we've already discussed, containers are lightweight and contain everything needed to run an application, so you don't really need to rely on what is currently installed on the host. You can easily share containers while you work and be sure that everyone you share with gets the same container that works in the same way. Now, there are some important features of Docker that I'd like to address. The first feature is that it is extremely fast and there is a consistent delivery of your applications. Now, Docker streamlines the development lifecycle by allowing developers to work in standardized environments using local containers, which provide your applications and services. Containers are great for continuous integration and continuous delivery workflows. Now, let me explain this with a tiny example. Your developers write code locally and share their work with their colleagues using Docker containers. Now, they use Docker to push their applications into a test environment and execute automated and manual tests. When developers find bugs, they can easily fix them in the development environment and redeploy them to the test environment for testing and validation. Now, when finally testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. This is how easy it is to use Docker and to get your work done. The second feature is that it has a responsive deployment and scaling. Docker containers can run on a developer's local laptop, on physical or virtual machines in a data center, on cloud providers, or even in a mixture of environments. Its portability and lightweight nature also makes it very easy to dynamically manage workloads, scaling up or tearing down applications and services as business needs dictate in near real time. The third feature is running more workloads on the same hardware. Docker is lightweight and fast. It provides a viable, cost-effective alternatives to hypervisor-based virtual machines, so you can use more of your compute capacity to achieve your business goals. It is perfect for high-density environments and for small and medium deployments where you need to do more with fewer resources. So there is a relationship between Kubernetes and Docker. We're going to discuss them now. So if Docker is containers and Kubernetes is container orchestration, why would anyone ask, should I use Docker or Kubernetes? Now, in reality, the two tools are actually complementary to each other and help build cloud native or microservice architectures. Docker is mostly used during the first days of a containerized application. It really actually helps build and deploy the application's container or containers. In cases where the application's architecture is very simple, Docker can address the basic needs of the application's lifecycle management. Now, if the case or the scenario where the application is broken down into multiple microservices, with each of these services having their own lifecycle and operational needs, Kubernetes comes into the picture. It is not only used to create the application containers, it actually needs a container platform to run, and Docker being the most popular one, it runs on that. Kubernetes integrates with a large toolset built for and around containers and uses it in its own operations. Containers created with Docker or any of its alternatives can be managed, scaled, and moved by Kubernetes, which also ensures failover management and health maintenance of the system. As you can see in the diagram, the container lifecycle has been explained. You can see that in the Docker, there is the build and deployment of the application that has been successfully done. Once the Docker has been successfully deployed, then Kubernetes takes the responsibility to monitor and scale the application. There are great benefits to using Kubernetes with Docker. Firstly, the applications are easier to maintain as they are broken down into smaller parts. Also, these parts run on an infrastructure that is much more robust, and the applications are more highly available. Here, applications are able to handle more load on demand, improving the user experience and reducing resource waste. As applications become more scalable, there is no need to pre-allocate resources in anticipation of load peak times. Now here, both Docker and Kubernetes are backed by strong open source communities and are part of the Cloud Native Computing Foundation, a Linux Foundation project aiming to advance container technologies and align the industry around specific standards. Now that we understand that Docker and Kubernetes have a really great relationship together, let's move ahead and address the main topic of today's session, that is Kubernetes versus Docker. Firstly, we will compare them in terms of setup and installation. As you can see on the screen, Kubernetes really requires a series of many manual steps to set up the master and worker node components in a cluster of nodes. It's really hard and complicated to install Kubernetes. But on the other hand, that is installing Docker is a matter of one-liner commands on Linux platforms like Ubuntu and CentOS. So compared to Kubernetes, Docker is much more easy to install and set up. Moving on to the next difference, that is logging. Kubernetes provides no native storage solution for log data, whereas logging driver plugins are available in Docker 17.05 and much higher. So in terms of monitoring Kubernetes applications, you can use various open source tools like Prometheus, Grafana, InfluxDB, etc. Docker, on the other hand, also has tools like Prometheus, Docker API, etc. for monitoring purposes. Kubernetes supports up to 5,000 nodes, whereas Docker supports only up to 2,000 nodes. And in terms of compatibility, Kubernetes is more comprehensive and highly customizable, whereas Docker is less extensive and customizable. So for all of y'all who don't know what load balancing is, it is an efficient distribution of network or application traffic across multiple servers in a server farm. So usually each load balancer sits between client devices and backend servers, receiving and then distributing incoming requests to any available server capable of fulfilling them. As you can see in Kubernetes, you must manually configure your load balancing settings, whereas in Docker, it does auto load balancing. That is, it is automated. Now, there are various companies that use Kubernetes and Docker. Companies like Google, Shopify, Udemy, Slack, Robinhood, Delivery Hero, Stackshare, Nubank, etc. use Kubernetes every day. On the other hand, various companies like Twitter, Business Insider, Spotify, PayPal, eBay, Oxford University Press, the New York Times, New Relic, all of these companies and organizations make use of Docker. Now that we've compared Kubernetes and Docker, let us understand in what situation to use Kubernetes and Docker. So what are the choices when it comes to Kubernetes and Docker? What happens if you do choose to use only one and not the other? So there are three scenarios that I'll be addressing. The first one is Docker without Kubernetes. The second one is Kubernetes without Docker. And the third one is Kubernetes with Docker. We've already discussed the benefits of using Kubernetes with Docker, but we'll just brief up that again. So firstly, let's understand the scenario where Docker can be used without Kubernetes. Docker by itself will allow you to build container images, manage them in a registry, run containers, and communicate with them, and eventually put them together in a multi-container application using Docker Compose. So is Docker all that you need? Now, when it comes to producing and managing container images and putting containers into operation at the runtime level, the answer for the most part is definitely yes. It has become the industry standard for creating containers and getting them off the ground. Now, under Docker's current developer-centric definition of its mission, however, it has moved away from earlier attempts to go beyond its core functions. It is no longer attempting to compete with Kubernetes and other companies at the infrastructure or orchestration level. Now let's talk about the second scenario. Kubernetes does not include functionality for creating or managing container images, and it does not by itself run containers. It really needs to work with an external container source and runtime. It is, however, capable of using containers from a variety of sources, and it is compatible with runtimes other than Docker, so it is not inherently dependent on Docker and Docker alone. What Kubernetes does is it provides a rich and a very flexible and powerful framework for defining applications and orchestrating containers at scale. It is very well designed for key enterprise level tasks such as automated scaling, maintaining high availability, and operating in a multi-platform environment. It also has a large community of users and developers with a corresponding large number of add-ons and support tools. So finally, in the third scenario, what is the best choice? This is a tricky question, and the answer is most obvious, that is, use both. The truth here is that although Kubernetes can use other container sources and runtimes, it is designed to work well with Docker, and much of Kubernetes documentation was very well written with Docker in mind. The most basic Kubernetes use case is Kubernetes plus Docker, and Kubernetes includes Docker-centric tools such as Compose, which converts Docker Compose commands and settings so they can be used by Kubernetes. For its part, Docker has embraced Kubernetes and has in fact offered its very own integrated Kubernetes distribution. So the bottom line is that Kubernetes and Docker are both industry standards in their respective core areas of expertise, and together they provide a well-integrated platform for container management, deployment, and orchestration at scale. It was never really a question of Kubernetes versus Docker. It was always Kubernetes and Docker, and today this is even more true.
So what is configuration management? Why do you need configuration management? Now, system administrators usually perform repetitive tasks such as installing servers, configuring those servers, so on and so forth. They can automate this task by writing scripts, but it is a very hectic job when you are working on a very large infrastructure. So meet our team. We have Dave, the developer, Sam, the sysadmin, and Alice, the manager. How the workflow goes is Dave passes updates to the operations team, which is Sam. So when Dave is done with a certain software update, he pings Sam to deploy it on the servers. But Sam then has to deploy the update on each and every individual server, and it's going to take him a significant amount of time just to deploy this new update to servers. Meanwhile, the manager Alice comes in with great news. They've been getting traffic on all of their servers, and she wants Sam to add 200 more servers to their system. But Sam hasn't even updated the current 20 servers with Dave's changes. How is he going to do that for 200 more servers? Now, there are a couple of issues here that Sam is facing. A few major ones are having to configure a large number of servers together, scaling to new servers manually without any configuration management tool, and the fact that there is always a development and deployment environment mismatch, which is going to halt his work from time to time. Now, to solve this problem, configuration management was introduced to workplaces. Configuration management is the practice of handling changes systematically so that a system maintains its integrity over time. Configuration management, or CM, ensures that the current design and build state of the system is known, good, and trusted, and doesn't rely on tacit knowledge of development teams. It allows access to an accurate historical record of system state for project management and audit purposes. So with configuration management, you overcome the following challenges. You figure out which components to change and when the requirement changes. You also redo an implementation because the requirements have changed since the last implementation. You can also revert to a previous version of the component if you have replaced it with new but flawed versions. And finally, you can replace the wrong component just in case you couldn't accurately determine which components needed replacing. So now, in an automated scenario, Dave passes updates to Sam, and scaling up is no longer an issue. And adding 200 more servers, as said by the manager, is not really a problem with the help of configuration management. Sam can easily scale, deploy, and configure as many servers as his manager wants. The best example for this that I know is that of the New York Stock Exchange. A software glitch had prevented the NYSE from trading stocks for almost an hour and a half, that is 90 minutes. This led to millions of dollars of loss. A new software installation was actually the cause of this problem. The software was installed on 8 of NYSE's 20 trading terminals. However, despite being tested out the night before, it failed to operate in the morning properly on its 8 terminals. So there was a need to switch back to the old software. As a result of proper configuration management, NYSE recovered from that situation in 90 minutes, which is pretty fast for a scenario like this. Had the problem continued longer, the consequence would have been far more severe. Now, I hope you understand the importance of configuration management, which is considered the backbone of DevOps. It allows more frequent software releases in the safest and most reliable way possible. Configuration management is all about bringing in consistency in the infrastructure. It is done by ensuring that the current design system, state, and environment is known, trusted, and agreed upon by everyone. It also helps record all the changes made in the system. Configuration management tools provide an easy approach to manage and configure servers. It enables users to manage and configure the entire infrastructure and its environment. It makes writing individual scripts for servers time and time again just to get little things done obsolete. And it does so by one concept in particular: infrastructure as code. Now here is a shell script and a configuration management tool script that you see in front of you. Both are adding a user to a host, but while the CM tool script is easy to understand and write, as you can see, it's almost pure English, the shell script is harder to understand and you'll have to learn to write shell scripts of your own in the first place. Now, infrastructure as code enables the automation of IT operations, which is to build, deploy, and manage by provisioning of code rather than manually handling each phase of different environments. Basically, what it does is that it bridges the environment differences sysadmins have encountered every time they had either tried to deploy new code or set up new servers. And it obviously has its own advantages. For example, provisioning servers using infrastructure as code is way easier than writing shell scripts. Shell scripts will require workflow definitions, as you just saw, whereas the CM tool scripts have predefined workflows. So that basically makes the CM tool script easy to understand and write, while eliminating the requirement for learning how to write shell scripts separately. Now there are a few very popular configuration management tools such as SaltStack, Ansible, CF Engine, and Chef. But the one that we want to talk about today is Puppet. Now Puppet is a configuration management tool that helps orchestrate, provision, deploy, and configure the entire infrastructure of an organization. It enables users to concentrate more on making delivery faster and more reliable rather than continually fixing mistakes. It defines distinct configurations for each and every host and continuously checks and confirms whether the required configuration is in place and is not altered. And if altered, Puppet immediately reverts back to the required configuration on the host. It also helps in dynamic scaling up and scaling down of machines while providing control over all of your configured machine. So a centralized or a master server or repo-based change gets propagated to all automatically. So Puppet uses a master-slave architecture. The diagram in front of you depicts what basically happens. So let me break it down for you a little bit. There's something known as a Puppet agent which sends facts to the Puppet master. The facts are basically your key value data pair that represent some aspect of the slave state, like its IP address, its uptime, operating systems, or whether it's a virtual machine or not. The Puppet master uses these facts to compile a catalog that defines how the slave should be configured. The catalog is a document that describes the desired state for each source that the Puppet master manages on a slave. And finally, the Puppet slave reports back to the master, indicating that the configuration is complete, which is visible in the Puppet dashboard. The Puppet master and slave communicate with each other through a secure encrypted channel with the help of SSL. The Puppet slave asks for the Puppet master certificate. After receiving the Puppet master certificate, the master requests for a slave certificate. Once master has signed the slave certificate, the slave requests for configuration or data, and finally the Puppet master sends the configuration to the Puppet slave. And that is how this architecture works. Now let us take a look at a few important Puppet components. Starting out, we have manifests. Now each slave has got its configuration details in Puppet master written in the native Puppet language. These details are written in the language which Puppet can understand, and these are termed as manifests. Now they are composed of Puppet code and their file names using the .pp extension. They are basically like programs of Puppet. For example, you can write a manifest in Puppet master that creates a file and installs Apache server on all Puppet slaves connected to the Puppet master. Next, you have a module. Now, Puppet module is a collection of manifests and data such as your facts, files, templates, etc. And they have a specific directory structure. Modules are used for organizing your Puppet code because they allow you to split your code into multiple manifests. Hence, they are also known as self-contained bundles of code and data. Now, the next component of Puppet is a resource. Now, resources are the fundamental unit for a modeling system configuration. Each resource describes some aspect of a system, like a specific service or a package. Next, you have a factor, which gathers your basic information or facts about a Puppet slave, such as hardware details, network settings, operating system type, version, IP addresses, MAC addresses, SSH keys, and more. These facts are then made available in Puppet master's manifests as variables. Then you have something known as an M collective. It is a framework that allows several jobs to be executed in parallel on multiple slaves. It performs various functions such as interacting with clusters of slaves, whether in small groups or very large deployments, using a broadcast paradigm to distribute requests where all slaves receive all requests at the same time. Requests have filters attached, and only slaves matching the filter can act upon the requests. You can also use simple command line tools to call the remote slaves and write custom reports about your infrastructure using the M collective. Next, and the final component I'm going to talk about is a catalog, which basically describes the desired state of each managed resource on a slave. It is a compilation of all the resources that the Puppet master applies to a given slave, as well as the relationships between those resources. Now, catalogs are compiled by a Puppet master from manifests and slave-provided data, which includes facts, certificates, and environment if one is provided, as well as an optional external data such as an external slave classifier, exported resources, and functions. The master then serves the compiled catalog to the slave when requested. Now that you know about Puppet, its architecture, and the various components of Puppet, let's understand why should you opt for Puppet or a configuration management tool like Puppet. Now, if you're a poker enthusiast or a card enthusiast, or you've ever played online games, then you must have heard about something called Zynga. It's the world's largest social game developer. Its infrastructure uses tens of thousands of servers in both public cloud and private data centers. Early on, they were using manual processes, including Kickstarters and post installs to get hundreds of servers online. Now, during the process, they faced a number of different problems. First of all was scalability and consistency. The platform was experiencing phenomenal growth, and its infrastructure needed to keep pace with the industry. Script-based solutions and manual approaches were not really sufficient for these needs. The second problem they were facing was portable infrastructure. Zynga needed a way to leverage a consistent configuration management approach in both their public cloud infrastructure and their own data centers. Now, given the diversity of the various Zynga gaming properties, it was important for the team to be able to quickly match the right configuration to the right machine. Hence, flexibility turned out to be another problem. And finally, infrastructure insights. As the organization matured, it became more important to have an automated method of visualizing the properties of each machine. Now, this company was smart enough to quickly realize the need for an automated process even before they hit rapid scaling, and that's when they got Puppet into the picture. So with Puppet, the first thing they could expect was speed of recovery. The production operations team could rapidly deploy the right configuration to the right box. If a system got inappropriately reconfigured, Puppet automatically reverted it back to its last stable state and provided the details necessary to manually remediate a system rapidly. The next thing was the speed of deployment. Apart from the speed of recovery, the speed of deployment was also increased manyfold. Puppet provided significant time savings in a way the operations team delivered services for the gaming studios. The next benefit of using Puppet was consistency of servers. Puppet's model-driven framework ensured consistent deployments. According to Mark Stockford, who was the vice president of production operations at Zynga, it was evident that they had experienced many ways to save time. The beauty of using Puppet is that, according to him, was that it allowed them to deliver consistent configurations across their servers in a very short period every time. And finally, having a model-driven approach using Puppet made it easier for them to share configurations across the organization, which helped enable developers and operations teams to work together and ensure new service delivery was of extremely high quality. Hence, it furthered collaboration. Over a dozen people from the team got trained in Puppet. This knowledge had been disseminated throughout the team and to the operations team within each individual gaming studio. So speed of recovery, speed of deployment, consistency of servers, and collaboration were the four main benefits of having used Puppet.
So first of all, guys, this is my AWS Management Console. I am going to launch a virtual machine with EC2 using this option. All right, here I'm going to pick my AMI, just filtering it out to free tier only. And if you go down, you'll get an option of Ubuntu Server 18.04, which I'm going to select. And once you've chosen your AMI, in type, I'm going to choose the T2 micro. And next, move on to configure instance details. All right. So the number of instances we'll be needing is 2, one for master and one for agent. So going on next to add storage, add tags, this is unnecessary. You could obviously go ahead and add tags for yourself, but I don't find it significant for this particular demonstration. So I'm going to move on straight to configure security group. So here what I'm going to do is I'm going to add rule, and what we need right now is something that will allow all TCP connections for our agent. So I'm going to go ahead and click on TCP, or you can always go ahead and use a custom TCP for your agent. Okay, so I'm going to do that, and here select from anywhere. All right, and once I'm done with this, I'm going to review and launch. Okay. So basically I created a new key pair and I launched the instances. Now your instances are going to be launched in a while. Okay. So all right, what I'm going to do is I'm going to edit the names of both of the instances. I'm going to name one as master, and I'm going to name the other one as slave. All right. So both the instances are running. We'll start with the master first. So now that we have connected to our machines using PuTTY, we're going to start by installing ntpdate packages to sync all the date and time on your servers. So first,
We're going to sudo apt update. And then we are going to apt install your ntpdate. Now what you need to take care of while running these commands, that all of your commands in this installation are run as root. So all of your commands are going to proceed by sudo. All right. Now we have installed our ntpdate packages and synced our data time on our servers. And all of this is being done in your master machine. Next, we are going to set up hosts file on our machines, and remember to run all these three commands on both of your machines, right? So now on our masters, we're going to edit the host file and add the IP address of the master itself in the hosts file and name it Puppet. So we're going to open nano. All right. On the master, we are going to edit the host file and add the IP address of the master itself, and we are going to name it Puppet. And in the agent, we are again going to go. And nano, again, we are going to open the hosts file, add the master, and add the Puppet agent. And then we are going to write out of both. Okay. Next, what we're going to do is we are going to add Puppet repo or repositories on both of your machines. So your Puppet uses port 8140 to communicate through SSL. And we are going to open it through the UFW command. So UFW enable. And then click on Y. All right. And then UFW. And we are going to allow our port number 8140. All right. And remember to do that on all of your machines that we are using, right? So here again, UFW enable and UFW allow 8140. Okay. Now we're going to add the Puppet 6 repository on all of the machines. So we're going to app update first. We're going to get our Puppet 6 package. And we're going to update our system again. And we're going to be doing the same thing on all of the machines that we have, right? All right. Moving on, we are going to install the Puppet server on the master machine. So for that, we are going to apt install an extension Y, your Puppet server. Okay. Now, after this installation, what we're going to do is we're going to change the memory allocation for the Puppet server. Now, the default setting is 2 GB. So we are going to basically set it to half of it or 1/4 of it, which is 1 GB or 500 MB, according to the memory allocated to your particular VM that you have whipped up. All right. So once this is done, what I'm going to do is I'm going to open the default Puppet server file and change one line. All right. So everything is pretty simply explained here. Here we have this one line which says modify this if you'd like to change the memory allocation, enable JMX, etc. So here we have our 2 GB which we are going to change to 1 G. Also remember you can change it to 502 MB as well. Yeah. So it's either half or 1/4. And remember to press I before you try to make any edits to it. Go into insert mode. Remember to be logged in as a root user. So I'm going to click on escape to get out of insert mode. Now you can see I'm not able to insert anything, right? And then I'm just going to exit it. All right. Next, what we have to do is edit our configuration file of Puppet. So we go into Puppet Labs and puppet.conf. Okay. So here you'll have to add the following lines. Just going to add main cert name equals puppet, server equals puppet, environment will be production, and the run interval. Then I'm going to escape and get out of this. Now that you have edited the configuration file, you're going to need to set up the Puppet server certificate. So for that, you have to go to Puppet Labs. And certificate setup. And this might take some time. And once it's done, you can start and enable your Puppet server. So we're going to do a systemctl start Puppet server, followed by systemctl enable Puppet server. So now that we've started it, we are going to enable it. All right, now you can see something along the lines of executing and your Puppet server is enabled. Now this was all about setting up the Puppet server on the master. So now we are going to install the Puppet agent the same way that we installed the Puppet server by using apt install. And now since I'm using an AWS instance, you can see this takes very little time as opposed to if I were using an actual VM. Yeah. So now I'm going to go into the Puppet configuration file on the agent machine and make a few changes. Think I forgot a space here. All right, we are here. Hit the I so you can make edits in there. Like we had done previously, we have main, we have certification name, we have server, we have environment and runtime. So cert name will be Puppet agent. Server will be Puppet. Environment will be production. And run interval will be 15 minutes. We're going to hit escape and we're going to quit the VI editor. Next, what we're going to do is we are going to start and enable the Puppet server on the agent machine. So for that, we're going to use this command op/puppet/bin/puppet. We're going to call resource service. You can call the master, ensure it's running and enabled. So now you can see that your service, that is Puppet, it's running, it's enabled, and you can see its provider. Now running the Puppet service on the agents will send the certificate for authentication on the master server. So now we're going to move on to signing the certificate, right? We had seen this in our architecture section. For that, we'll first move on to our master machine. Okay, so finally here's an extra bit, which is signing the certificate. This is a small little section which consists of not more than 3 commands. First of all, you're going to list all the certificates left for signing on the master machine. For that, you're going to use the Puppet server CA list command. Then you can choose either to individually sign the certificate or all of them together. So you can either use this command and put the cert name, or you can do a -all. And to verify, you can open the agent and use the test command. And with that, your Puppet installation and setup is complete.
What is Ansible? Well, Ansible is a simple open source IT engine which automates the application deployment, intra-service orchestration, cloud provisioning, and many other IT tools. Not only this, but Ansible also is very easy to deploy because it does not use any agents or custom security infrastructures. So Ansible uses playbook to describe automation jobs, and playbooks use very simple language, that is the YAML. So what do you think this YAML is? Well, YAML is a human readable data serialization language and is commonly used for configuration files, but it can be also used for many applications where data is also stored. So this means it is very easy for the humans to understand, read, and write, isn't it? So the advantage of YAML file is that even the IT infrastructure support guys can read and understand the playbook and debug if needed. So it's basically a really simple language and makes it really easy for the humans to read, write, and understand. Now moving on with the session, as Ansible is designed for the multi-tier deployments, Ansible does not manage one system at a time. It models the IT infrastructure by describing all of your systems which are interrelated. So Ansible is completely agentless, which means that Ansible works by connecting your nodes through SSH by default. But if you want any other method for connection like Kerberos, Ansible also gives you that option. So after connecting your nodes, Ansible pushes some small programs called as the Ansible modules, and Ansible runs that modules on your nodes and removes them when they are finished. So it also manages your inventory in simple text files. Those are basically the host files that you can see on the screen, where Ansible uses the host files where one can group the hosts and control the actions on a specified group in the playbooks, right? Next, as I was telling you about Ansible, and Ansible is the tool for configuration management, you should also understand configuration management before you understand how to deploy it with the tools. So talking about configuration management in terms of Ansible means that it maintains the configuration of a product performance by keeping a record and updating detailed information which describes an enterprise hardware and software. So such information typically includes the exact versions and updates that have been applied to install software packages and the locations and also the network addresses of the hardware devices. So for example, if you want to install the new version of the WebLogic server on all the machines present in your enterprise, it is not feasible for you to manually go and update each and every machine, right? So you can install the WebLogic server in one go on all your machines with the Ansible playbooks and inventory written in most simple way. So all you have to do is that you have to list out the IP addresses of your nodes in the inventory and write a playbook to install the WebLogic server. After that, you have to run the playbook from your control machine and then it will be installed on all your nodes. So guys, now that you've seen what configuration management is, let me show you how does Ansible work. So basically, Ansible works by connecting your nodes and pushing out small programs called as Ansible modules to them. So Ansible then executes these modules over SSH by default and then removes them when finished. So your library of modules can reside on any one machine and there are no servers, daemons or databases required. So the management node that you can see on the screen is basically the controlling node which controls the entire execution of the playbook. It's the node from which you're running the installation, and the inventory file provides the list of the host where the Ansible module needs to be run, and the management node does a SSH connection, and then it executes these small modules on the host machine and installs the product. So the beauty of Ansible is that it removes the modules once those are installed so that it effectively connects to the host machine, and then it executes those instructions, and if it's successfully installed, then it removes the code which was already copied on the host machine and that was which was executed. So guys, that's how Ansible works. Now, if you talk about the features of Ansible, let's take a look at them one by one. So the first is that it is agentless. By agentless, I mean that there's no kind of software or any kind of agent managing your node, unlike Puppet or Chef, where you need to install a Puppet agent or a Chef client on all your node machines. But for Ansible, what you just have to do is you just have to install Ansible in your control machine and then you're good to go. After that, it is built on top of Python, and this helps to provide a lot of functionalities of Python, right? Now coming to SSH, Ansible uses SSH for secure connections. Now SSH is a very simple passwordless network authentication protocol which is very secure. So our responsibility is to just generate a public key in your control machine and copy the same key onto your node machines. So coming to the final feature, the Ansible is also a push-based architecture for sending configurations. So in the case of Ansible, where you want to make any kind of configuration changes on your nodes, all you have to do is you just have to write down those configurations and then you just have to push them all at once in your nodes. So if you talk in simple terms, what it does is that it gives you full control on whenever you want to make changes on your nodes, and also makes it very easy and fast to set up and needs very minimal requirements. So guys, the features of Ansible are it's agentless, it's built on top of Python, it uses SSH and also uses the push-based architecture. Now, as in the features section, I was talking about that Ansible is a push-based architecture. What do you think is the difference between the push-based architecture and the pull-based architecture? Well, tools like Puppet and Chef are basically pull-based configuration management tools, whereas Ansible is push-based configuration management tool. Now, in the case of Puppet and Chef, their agents present the agent software that Puppet has and is basically called the Puppet agent, and in case of Chef, it is known as the Chef client. So what this agent actually does is that it keeps on pulling the central server periodically for any kind of configuration information, and whatever it finds, it pulls those changes and then gets them affected on your node machines. Whereas in the case of Ansible, since there are no agents present, whenever you want to make any changes, you can make those changes directly and you can push those configurations directly whenever you want to, as you've got full control over it. Not only this, but also in a push-based configuration management system. So as you can see on the screen, there's a version control system which manages all the changes in the code base, and then we have a server. So basically this server will have Ansible or any other configuration management tool system installed there, and then we'll have a bunch of nodes. So these bunch of nodes are basically the collection of web servers and application servers and also the database servers, and all these are connected to the main server via SSH. Now, what happens here is that these main servers constantly pull the version control system for any changes in the code base. By this, I mean that it constantly keeps on checking the status of version control system at regular intervals of time. And whenever there are any kind of changes, those specifications are sent to the main server, and then the server decides on how to take those configuration changes according to the changes in the code base. Now, in the situation where you want to write all these new configurations, you can directly push them all at once onto your node machines. So you've got full control here, and whenever you want to make any changes, you can make the required changes. Now, coming to the pull-based configuration, the relation between the version control system and the central server is the same. It basically constantly pulls for the changes to the version control system for any changes in the code base, and whenever there are changes, it pulls those changes. But the main difference between both the architectures is that from a push-based configuration management tool, it has got an agent present, and then this agent or the client is a software that manages all the nodes. So what this agent does is that it constantly pulls the central server for any configuration changes. By this, I mean that it keeps on checking the central server for any changes in the configuration that needs to be made, and whenever it finds any kind of configuration changes, it pulls those changes and then only it gets affected onto the node machines. So at this point, you have to wait for an agent to pull those changes and only then the configuration changes will get affected onto your nodes. So the basic point is you have to be a little bit dependent on the agent here and the improvement tools, right? So as I was chanting from the beginning of the session that Ansible is really simple, it's very easy to learn because it gives us the simplicity of push-based system. But there's a disadvantage with the system. That's because you cannot achieve full automation with the push-based system because it's not usually possible to boot a server and have it configured without some sort of client or server protocol, and also it gives you a lack of scalability as well as when you're dealing with hundreds of servers, a push-based system will start showing its limits unless you make use of threading or multiprocessing. Alright guys, so those were the differences between the push-based configuration and the pull-based configuration. So Ansible is basically a push-based configuration management tool. Now moving on with the session, as I've talked so much about Ansible, you would be interested to install it. So how do you think that you can install Ansible? So before I start telling you the steps to install Ansible, let me tell you that there are basically two types of machine when we talk about deployment. Those are the control machine and the remote machines. So the control machines are the machines from where we can manage other machines, and the remote machines are those machines which are handled or controlled by the control machine. So there can be multiple remote machines which are handled by a single control machine. So for managing remote machines, we have to install the Ansible on the control machine. So now let me tell you the steps to install Ansible. So for that, you just have to type in the command sudo apt-get update. So this command will basically update your repositories. Now once that is done, you have to, install the common software properties. So for that, you'll type in the command sudo apt-get install software-properties-common. So you can see that, on the screen that your installation is going on. Now once that is done, you'll type in the command sudo apt-add-repository space ppa:/Ansible. So this will basically include your Ansible's repository. So you can see a description about Ansible. Now if you want to continue, you just have to press on enter. So once you press on enter, you can see that it is getting continued. Now once this is done, you again have to update your repositories. So for that, type in the command sudo apt-get update. Now once you're done updating your repositories, you have to install Ansible. So for that, you'll type in the command sudo apt-get install Ansible. So this will basically install the Ansible tool. So you can see that your Ansible has been installed. So guys, that's how you can install Ansible. Now let's move on with the session. So now let me just give you a summary of the commands that you need when you install Ansible. You just have to update your repositories. Once you're done with that, you have to install the common software properties. Once that is also done, you'll add a new repository on the name of Ansible, and then you'll update your own repositories, and then finally you'll install Ansible. So these are the commands that you have to use. Now moving on with the session, what do you think this host inventory is? Well, inventory defines a group of hosts which are alike in any way. So for example, you would want to group your web servers in one group and application servers in another, right? So a group can have multiple servers or a single server that can be a part of multiple groups. So the name of the group is enclosed in square brackets, and the server names can be their DNS names or IP addresses. So by default, Ansible looks at the inventory file, but that can be modified by passing the inventory part to the Ansible command line. So we can modify the way Ansible connects to our host by supplying the additional information in the inventory file. So as you can see on the screen, this is just a list of IP addresses on my nodes. And also you can name the groups of your different IP addresses. So for example, if I want to group my web servers together and my data servers together, all I have to do is I have to write a group name between the two square brackets and a big group together. So whenever you want to make configuration changes just on the web server and not on the database server, all you have to do is you just have to mention the group name on the host, and then it will automatically configure your web server. So guys, that was about host inventory. Now if you talk about another key term in Ansible, that is Ansible modules. So modules are those executable plugins that get the real job done. So usually modules can take the key value arguments and run in a customized way depending upon the arguments themselves. So a module can be invoked by command line or can be included in the Ansible playbook. Now, let me tell you some commands related to Ansible modules. Now, if you want to use the modules from command line, you have to type in the command Ansible all-m ping. Now, if you want to use the ping module to ping all the hosts defined in the inventory, then you have to type in the command Ansible web servers -m command -a ls. So this will basically list all the modules present and then it will ping. Now, if you want to flush IP table rules on all the hosts in the inventory, then you have to type in the command Ansible -i inventory all -m command -a IP tables f -become -ask -become -pass. So this will basically tell Ansible to execute the command with sudo privileges. So if you want Ansible to gather facts about the host, then you have to type in the command Ansible all-m setup. And also if you want to extract particular facts in the documentation of the setup module, you have to type in the command Ansible-doc setup. So guys, these were few commands that you can use with Ansible modules. Now moving on with the session, let me tell you about the YAML files because that is the file that has been used. So Ansible uses YAML syntax for expressing Ansible playbooks. Ansible uses YAML because it's really simple for humans to understand, read and write when compared to the other data formats like XML or JSON. So every YAML file optionally starts with 3 hyphens and ends with 3 dots. So as you can see on the screen here, it starts with 3 hyphens and ends with 3 dots. Now, you can also use abbreviation in YAMLs to represent dictionaries. So as you can see on the screen, it basically follows the pattern of a key value pair. So here the key value is James and it has various values like its name, roll number, division, sex, everything. So the key James has many values like the name James John, the roll number to be 34, the division to be B and the sex to be male. Not only this, but we can also represent the list in YAML file. So every element of the list should be written in a new file with the same indentation starting with a hyphen and a space. So for example, as you can see on the screen, after writing countries, we have written America with a hyphen and a space, and then the next value comes in the next line with a hyphen and a space, that is China, similarly Canada and Iceland. So if you have to represent this list in an abbreviation form, it can be represented in the form of countries, colon, and in a square bracket, you can type in America, China, Canada and Iceland, right? Now further talking about YAML files, you can also represent a list of dictionaries. So YAML uses the pipeline to include new lines while showing multiple lines and uses the greater than symbol to suppress new lines while showing multiple lines. So due to this, we can read and edit large lines, and in both the cases, indentations are ignored. So guys, that was about the YAML files. Now talking about Ansible playbooks, let me tell you how to write an Ansible playbook. But before that, let's see what exactly Ansible playbook is. So as I've told you before, that the playbooks are the files where Ansible code is written, and these are written in the YAML format. So YAML stands for yet another markup language, and playbooks are one of the core features of Ansible and tell Ansible what to execute. So they're like the to-do list for Ansible that contains a list of tasks, and playbooks contains the step which the user wants to execute on a particular machine. So playbooks run sequentially, and playbooks are the building blocks for all the use cases of Ansible. So each playbook is an aggregation of one or more plays in it, and playbooks are structured using the plays. So they can be more than a play inside a playbook, and the function of a play is to map a set of instructions defined against a particular host. So since YAML is a strict type of language, we need to take extra care while writing the YAML files. So now let me tell you how can we create a playbook. So as I mentioned before, YAML starts with 3 hyphens and then we have different YAML tags. So now let's go through each and every YAML tag. So the different tags that are included are the name, host, vars, and task. So the name tag specifies the name of the Ansible book. So basically I'm talking about as in what this playbook will be doing, or any logical name that can be given to this playbook. Coming to the host tag specifies the list of hosts or the host group against which we want to run the task. The host field or tag is mandatory and it tells Ansible on which host to run the listed task. So the task can run on the same machine or on a remote machine, and one can run the task on multiple machines, and hence the host tags can have a group of host entry as well. Coming to the vars tag, the vars tag lets you define the variables which you can use in your playbook, and usage is very similar to the variables in any programming language. Now coming to the final tag, that is the task. All the playbooks should contain tasks or a list of tasks to be executed. So the tasks are the list of actions one needs to perform. So task field contains the name of the task, and this works as a help text for the user. Well, it's not mandatory, but proves useful in debugging the playbook. So each task internally links to a piece of code called module. Now let's move on to the hands-on part where we'll basically, create a playbook, and then I'll show you the working of Ansible. So let's get started with our hands-on part. So first we have to create an SSH connection, right? To create an SSH connection with the node, so for that you have to type in the command SSH-keygen. So this will basically, generate your key. So once you type in the command, you can see an output that it is generating a RSA key pair. Now if you have to mention the directory where you want to store the key, but if you press enter, it will store it as a default location. So let me just press enter. And once you press enter, you can see an output that it has created a directory for SSH. Now you have to enter the passphrase. So for that, let me just press enter again. And again, we have to mention the same passphrase. So for that, let me just mention it again. And you can see that, our key has been generated. Alright, now once your key has been generated, you have to create a host inventory file. So we're creating a host inventory file so that we mention the specifications of the node IP address that we want to connect with. So for that, you'll type in the command. Sudo, and then you'll mention the directory of your host. So I've just mentioned the directory, and then I'll press on enter. So it will ask for my password. So I'll mention the password. So as you can see on the screen, this is the default host inventory file. Now, as we have to mention the name of our servers, I'll just mention it in the square brackets. Let's say I mention the name to be test servers. So for that, I'll type in test servers, and then I'll mention the name of the node. So let me just type in the name of the node. So over here, my name of the node is knode. So I've mentioned that. Now, once this is done, just save this file and close this file. So for that, you'll press the keyboard shortcut Control X and then press on Y. So this will save your host inventory file. So once you're done with that, you have to mention the SSH generated key in the K node. That is the node that we just configured, right? So for that, you'll type in the command SSH-copy-ID space -I space and the name of the node. So over here, my name of the node is K node. Once I'm done with that, I'll press on enter. And you can see that, it will ask for a confirmation. So let's just say yes. So you can see the output that our key has been copied. Once you're done with that, you'll be asked for your password. So let's just type in the node password. And you can see, your key has been successfully added to your node. Now, before I move forward, I've just cleared my terminal. So just in case if you want to know the command is clear. So once you type in clear, the terminal gets cleared. Now moving on with the hands-on. Now, once your key has been generated, you have to, create a playbook. So before I start creating a playbook, let's just check if our test servers are running or not. So for that, you have to type in the command Ansible space -m ping and the name of the server. So here I've given test servers. So I'll just type in that command and then I'll press on enter. Now, once this is done, you can see an output that, it is successful. So now let's start creating playbooks. So to start creating playbooks, you have to first create a YAML file. So for that, you have to type in the command sudo nano. Let's say I give the name to be edureka demo.yaml. So this opens up a YAML file. Now let's start mentioning the specifications required. So first I'll mention the host. So as I mentioned before, that YAML file starts with 3 hyphens. So let me just mention 3 hyphens and then I'll press on enter. So let's start by mentioning the YAML tags. So let's start with the host. So for that, I'll type in -host space : I'll mention the name of the server, that is the test servers. Then I'll mention become. And over here, you make sure that, you do not miss out the space. So it has to come in one go. And then let's say I put it true. Then I'll mention variables. So for that, I'll type in the command vars. And then you have to make sure that, you're maintaining the syntax. So I'll type in vars, mention a colon, and then inside which I'll type in Ansible -become -pass to Edureka. That is basically our password. Then I'll again mention task space : and then inside which I'll mention the name. That is basically the name of the task. So for that, I'll type in -name space : install Nginx. And then let's mention the package also. Space : space pkg is equal to Nginx space state is equal to installed. And then I'll put in a space. And then after that, so let me just put in spaces. And then I'll mention notify : I'll press on enter. I'll go inside that. I'll mention -start Nginx. After that, let's press on enter, and now let's mention the handlers. So for that, let's again maintain the spaces, space colon, inside which we'll again mention the name. So for that, we'll mention name space colon start space Nginx, and then mention the service. So that is name Nginx state is equal to started. So guys, this was my YAML file to create a playbook. So for that, I'll press the keyboard shortcut Control X and then I'll press on Y. So this will save my file. Now, once you have saved this file, you have to run your playbook. So for that, you'll type in the command Ansible -playbook and the name of the YAML file. So over here, it's Edureka demo. So I'll mention Edureka demo.yaml and then I'll press on enter. So you can see on the screen that the playbook is running. So as you can see, the playbook has run. So basically it mentions name of the server, that is the test servers. It mentions the task. So we wanted to install Nginx. So it has mentioned the task. Then it also mentions the running handler node, that is the K node over here. And then it also mentions whether it is unreachable, failed or not. So guys, this is how playbook runs. Now, once the playbook runs, it automatically installs your Nginx container. That is basically the task that we mentioned. Now, to check whether it is running on the other node or not, you have to switch to your other node. So let me just switch to my other node. So now to check whether Nginx has been installed or not on the other node, let's type in the command ps aux, that is WAUX space pipeline space grep, the name of the file that we installed, that is Nginx. Now let's press on enter. So you can see the output that it has been installed. So guys, that's how Ansible basically works. It's really simple to do, right? So you just have to mention on one node and all the actions will happen on all the other nodes connected to it.
Let's start with understanding why should you use Terraform. There are some great pre-existing tools like Ansible, Chef, Puppet, and SaltStack. But then what makes Terraform better than these tools? First reason is that Terraform is a server orchestration tool. All the above mentioned tools were created for server configuration, meaning that their primary goal is to install and manage software on the already existing server. Terraform concentrates more on server provisioning, with software container deployment left to Docker and Packer. The next reason is the immutable infrastructure. With Chef, Salt, Puppet, or Ansible, any software update must be run in place. Thus, every server grows a unique record of updates throughout its life cycle. This can quite often lead to so-called configuration drift when the differences in these configurations lead to bugs. Terraform addresses the issues by utilizing an immutable infrastructure approach, where every new update of any parameter creates a separate configuration snapshot. This way, updating the development environment goes smoothly and is completely bug-proof. The next reason is the declarative code style. While Chef or Ansible forces you to write step-by-step procedural instructions for reaching the desired state, Terraform prefers describing the desired each state of the system, and the tool itself deals with reaching the goal state. But why is it better? With the procedural code, you need to think of all the recent events and processes that took place in order to write clear instructions. But with Terraform, you simply order the tool to do something with the currently active state of the system. This is why the code base remains quite small and easily understandable. The fourth reason is the client-only architecture. Terraform leverages the cloud provider's API for provisioning the infrastructure, which removes the need of additional security checks, running a separate configuration management server, and multiple software agents. Ansible does this by connecting through SSH, yet the capabilities are quite limited. So, what is Terraform? Terraform is an open source infrastructure as a code tool developed by HashiCorp. It is used to define and provision the complete infrastructure using an easy-to-learn declarative language called HCL, or HashiCorp Configuration Language. Terraform supports multiple providers such as AWS, Azure, Kubernetes, Google Cloud, and many more. Now let's understand Terraform better through a use case. Rapider is an agile, innovative company. They are providers of strategic cloud consulting, cloud migration, DevOps automation, managed services, and security consulting. So once their client was looking for a cloud agnostic tool to orchestrate the infrastructure onto multiple public clouds. They wanted the infrastructure to be up in a matter of few minutes. The client had different environments like production, staging, and QA to test. Database backups were also included as a part of infrastructure setup. DevOps engineers at Rapider reviewed and analyzed the client's requirements and came up with a solution of using Terraform to codify the provisioning of infrastructure onto public cloud. Not only infrastructure, but Rapider also automated the application deployment process by integrating GitLab to improve the software development and accelerate the software delivery. The solution provided by Rapider also took care of database backup for a situation when the infrastructure is destroyed. Using this solution, the client is now able to test their application and deploy it on production environment without downtime. So the overall benefits that a client could experience include the client's ability to create the infrastructure over multiple public clouds within a matter of few minutes. Next is that the client has the flexibility to launch the infrastructure as and when needed. Furthermore, the automated deployments help the client push the application into production seamlessly, thereby reducing the time to market. Also, the automated backup of the database ensures that they always have a copy of their latest database. Moving ahead, let's understand Terraform lifecycle. It includes initialize, plan, apply, and destroy. Terraform init initializes the working directory which consists of all the configuration files. Terraform plan is used to create an execution plan to reach a desired state of the infrastructure. Terraform apply then makes the changes in the infrastructure as defined in the plan, and the infrastructure comes to the desired state. Terraform destroy is used to delete all the old infrastructure resources which are marked tainted after the apply phase. Now let's see how Terraform works. Terraform core uses two input sources to do its job. The first input source is a Terraform configuration that you as a user configure. Here you define what needs to be created or provisioned. The second input source is a state where Terraform keeps the up-to-date state of how current setup of infrastructure looks like. So what Terraform core does is it takes the input and it figures out a plan of what needs to be done. It compares the state and checks what is the current state and what is the configuration that you desire in the end result. It figures out what needs to be done to get that desired state in the configuration file. The second component of architecture is providers for specific technologies. This could be cloud providers like AWS, Azure, or other infrastructure as a service platform. It gives you the possibility to create infrastructure on different levels. Terraform has over hundreds of providers for different technologies, and each provider then gives Terraform user access to its resources. For example, AWS provider gives you access to hundreds of AWS resources like EC2 instances, the AWS users, etc. With Kubernetes provider, you can access commodities, resources like services and deployments, namespace, etc. So this is how Terraform works, and this way it tries to help you provision and cover the complete application setup from infrastructure all the way to the application. Moving ahead, let's see how to install Terraform. Now to install Terraform, let's go to its official website. So the system I'm using is a 64-bit Linux system, so I'll install Terraform for that. I'll copy the link first. Then what we need to do is open the terminal. Then we write wget and we paste the link we had copied and enter. So now Terraform will get installed. Okay, so Terraform has been installed. Since it's a zip file, let's unzip it now. And this is the file name. Let's copy that. Now let's move Terraform to a location. Let's see what the location will be. So we'll be moving Terraform to this location. Okay. Now that it has been successfully moved, let's see the Terraform version that we have. So it's 14.5. Okay. So by writing Terraform and entering, you'll see what all commands Terraform provides you. So these are all the commands. It also includes init, plan, apply, destroy, as we discussed before. There's something also called as validate that you can use, and several other commands. Now that we have installed Terraform in our system, let's move ahead with our demo. So let's just clear screen. Okay. Now what we need to do is we are going to create a directory and we are going to name it Terraform demo. Okay. So let's move into that directory now. Now what we are going to do is we are going to create a configuration file, Terraform configuration file over here. So let's write gedit and the file name. So let's name it demo1.tf. So this is the extension that we need to put for any Terraform configuration file that we are going to create here, and hit enter. Okay, so the gedit file, Terraform configuration file, has been created. Here is where we are going to put all the configuration we need. So initially, let's try to create an EC2 instance in Amazon Web Services and then destroy that EC2 instance. Okay, so what we need to do here is Terraform provides you with everything, every support that is there for your code online. So let's say AWS provider, Terraform. Okay, so you can see the usage here. This is what we need to define, that we want to create or use AWS service. Let's paste this here. Okay, so it asks for region, access key and secret key. So what are access key and secret key here? We'll get that from Amazon Web Services. Let's see how. So I'm going to create a user over here. I'm going to give it Terraform. And I'm going to give it a programmatic access. Along with that, administrator access. And next. So let's give this as my demo. And value as Terraform. Okay, let's just keep it to Terraform. So this is the summary. And let's create it. So user has been created, and this CSV file is what we need to download to get the, the access key and the secret key. Okay, we have the file here. Let's open it. So this is the access key here. Let's copy this and we are going to paste it here. And we have the secret key. Again, let's copy and paste it here. Okay, so for region, let's create this for US East 2. Okay, now we are going to put what resources we need. Since we are creating EC2 instance, let's so what we need is just this part for now. for creating our instance. Let's paste it here. Okay, so it says we want to create AWS instance. Let's change this to, and this AMI is for US West 2. So every time you change the region, AMI is going to change. So let's find it for US East 2. So let's check. So we are on US East 2 right now. And you can see there are no instances running. Okay. So suppose we want to create an instance. We want to launch one. So here you can see the AMI for US East 2. Let's copy that. And we'll paste this here. Okay. So I think this is enough. We don't need to add anything else. We have provider AWS and we have given the region, access and secret key. We want to create AWS instance and AMI and instance type as T2 micro. Let's keep it that way. Okay. Let's save the file and close it. Now let's go back to the terminal. And now what we are going to do is initialize it. Then let's apply Terraform plan. Okay, you can see here one in the plan, which is the EC2 instance we want to create. And then finally Terraform apply. So it asks for an approval from you. So you just write yes over here. Okay, it says one added. Let's go back to AWS and see if the EC2 instance in US East 2 has been created. Okay, so you can see the instance has been created here. Okay, yeah. So one instance is running and we are in US East 2. So the instance has been created. Okay. Now what we need to do is we want to destroy this instance that we have created. Now simply what we need to do here is Terraform destroy. And this will destroy that instance. Okay, you can see one destroyed over here. Let's see if it has been destroyed. So you can see we had an instance over here, but it has been destroyed now. So this was a very simple and basic demo that I have shown you here. Now let's do something a little more complicated. Let's try to add some more services that AWS provides you. So let's clear the screen. Okay. Now what I'm going to do is we have the same gedit file over here. You can see the demo 1. Okay. So we have written a code partially over here. Let's include some more things and additional features in this code itself. So just remember that this instance has been already destroyed. So while we initialize plan and apply, this instance is going to be created again if we keep this code. Okay. So I want to create this instance again. But apart from that, what I want to do is I want to create another EC2 instance in some another region. So let's see how to do that. For that, let's copy this. Okay. So all I need to do is suppose I want to create another instance in US East 1. So let's change this. The access key, secret key is going to remain same because we are making it through the same user. Okay. Let's create another resource here because we want to create one more instance. Okay, let's name this something like US East 1. Okay, And just remember the AMI is going to change for US East 1. Okay, so let's search for that AMI now. Okay. Yeah, okay, there is no instance over here. So suppose we want to create one. So you can see the AMI here for Linux. So let's copy this, and so this is the US East one. Let's paste this here. So you can see the AMI differs from region to region. Okay, so we have done this now. What we need to do is, how will this resource understand that it wants to create an EC2 instance in US East 1? So for that, what we are going to do is we are going to create an alias. So let's put this as okay. So this is done. We have added the alias over here. So let's refer this to this part. Okay, this alias that we have created. How we are going to do that is by writing provider is equal to AWS dot whatever alias we have provided here, copy paste it. Okay, so this is done. Now apart from this, let's see, we want to create an S3. So okay, S3 bucket. Okay, so for S3, this is what we need. So let's copy these and paste it here. Okay, so let's change this to something. Let's keep this. So one thing to remember is that the bucket name has to be unique. So let's try to make a unique name over here. Okay, let's keep this. Let ACL be private. Let's change this to my Terraform bucket. And let's keep this dev-env. Okay. Apart from this, what we are going to do is we are going to add versioning over here. So why we are adding versioning here is because we want to preserve, retrieve, and restore every version of every object stored in our Amazon S3 bucket. So that's the reason we have added the versioning block over here. Okay, so looks fine. Let's save this. Okay, so we have one EC2 instance in US East 2, another in US East 1, and one S3 bucket. So remember that in case of US East 2, we haven't used any alias. So what it is going to do is it is going to refer to this default one where there are no alias, nothing provided for it, to refer. So it's going to refer this by default, US East 2. Okay, let's save this. And let's close this. Okay. Let's open the terminal and let's initialize again. Then plan. Okay, so you can see 3 over here, 2 EC2, 1 S3. Let's apply it. Okay, so you can see 3 added. Let's check it now in AWS. Okay, so we are in US East 1. So we will have 1 EC2 here. Okay, so we can see 1 instance running. Okay, so we have 1 instance running over here. Let's check it in US is 2. Okay, so we have one instance successfully running over here as well. And let's check our S3 bucket. Okay, so you can see we have one S3 bucket created over here successfully. Great. Now, let's say we want to add a VPC, one subnet, and also want to create relational database system. Okay, so more three things: VPC, subnet, and RDS. So what we can do is we can actually add to this rather than creating another file. So let's open this again. Okay, so below this, let's start adding. But one thing to remember is that we haven't destroyed any of this yet. The two EC2 instances and S3, we haven't destroyed them. So what we are going to do is we are going to add to this. Okay, so what we are going to add, let's start with VPC. So okay, so let's copy this. This is what we need to create a VPC and paste it here below. Okay, so it says resource we want to create is AWS VPC. Let's give this a name as dev. Okay, cider block. Okay, let's keep this and let's keep this default. Okay, let's change the tag name to something else. Let's keep it dev VPC. Okay, so that's done. Now suppose you also want to create subnet. So let's search for that. Okay, let's copy this and paste it here. Let's again change a little bit. Let's give it a name as sub. Let's keep the cider block same. And let's change it to dev subnet. Okay. So one thing to see over here is we need VPC ID over here. But since we haven't created our VPC yet, how will we give the VPC ID over here? So there is a way to do that. So what we are going to do is let's just copy the whole thing that we have over here. Copy this and paste it here. We don't want the double inverted commas. Okay. So this is how we are going to give the VPC ID to our subnet. Okay. It's the same as this over here. Just AWS VPC dot dev dot ID. Okay. This is how it will get the ID of the VPC. Okay. So this is done. Apart from that, as we said, suppose we want to create RDS. Let's see what to do for that. So you can see the basic usage here. Let's copy this. And let's make some changes. We want engine version as 8.0.19. Okay. And let's change this to 8.0. Okay. So we are going to add one more line over here, which is we don't want to create a snapshot of this RDS that we are creating. Okay. Suppose this is some dummy RDS that we have created. We don't want any backup for this. So we are going to provide it that we don't want a snapshot. Okay. Okay. So we have written skip final snapshot and we have kept it true. Okay, so it won't create a snapshot. Okay, so that is done. Let's maybe change the name to my Terraform DB. Okay, username. Let's keep this the same. Okay, this is just an example. So overall, what all we have added to this, we have created one VPC, subnet, and RDS. Let's save this. Okay, and close it. Let's go back to the terminal and initialize it. Then Terraform plan. Okay, so you can see here that 3 to add. So we already have 2 EC2, 1 S3, and apart from that, we are adding one VPC, subnet, and RDS. Okay, so let's apply. Okay, so we can see 3 added. Let's go and check. Let's check this in our AWS console. So we can see that S3 is still running, the one we had created before. So the 3 things we have created now is VPC, subnet, and RDS. Okay, let's check those now. So we can see the VPC we have created is now available. It's running. And this one is a default VPC that was already present. Apart from that, let's check subnets. So see, our subnet is present over here and it's running. Rest are default. Okay, apart from that, let's check RDS. So we can see one database instance here. Let's see. Okay, so you can see the RDS we had created for MySQL, that's running now. Okay, now suppose everything that we have created now, we want to destroy it. Okay, imagine how much time would it take to destroy all of these through console. Now let's see how we are going to destroy it through Terraform. So all we need to do here is Terraform destroy. So what all will it destroy? Everything that we have created in that file, everything is going to be destroyed, which includes our 2 EC2s, 1 S3, VPC, subnet, and RDS. Okay, everything has to be destroyed through one single command. Okay, let's see. So you can see 6 over here. So let's see if it destroys everything. Okay, so it says 6 destroyed. Let's check one by one, okay? Now currently we are in RDS. Let's refresh this and see. Okay, so you can see the RDS has been deleted now. It is destroyed. So let's next see VPCs. So we can see the VPC we had created is deleted. The one present over here is the default one. Let's check the subnet. Okay, again the subnet we had created has been destroyed, and these are just the default subnets that are present. Apart from that, let's see EC2. So currently we are in US East 2, right? Okay. So you can see there are no instances running over here. Okay. So the instance we had created has been destroyed now. Let's check S3. As you can see, no buckets over here. So the S3 we had created is also destroyed. Okay, now let's go back to EC2 and we are going to change our region to US East 1. So remember we had created one more instance in different region using alias. Let's see if that has been destroyed as well. Okay, so you can see there are no running instances. Okay, so the instance we had created in US East 1 also has been destroyed. This is just one example of how multiple services AWS provides, and you can do everything through infrastructure as code rather than going through console, okay? So you can do this with other cloud platforms as well, like Azure, Google Clouds, and there are many more. So this was just a simple example for AWS.
What is Prometheus? Prometheus is a free software application used for event monitoring and alerting. Now, what it really does is it records real-time metrics. We'll talk about metrics later on in the session. Now, this metrics that it records is stored in a time series database built using a HTTP pull model. And with this, you also have flexible queries and real-time alerting. Prometheus basically pulls these metrics, which are in a key value format, and stores the data as time series, allowing users to query data and alert in a real-time fashion. At given intervals, Prometheus will hit targets to collect metrics, aggregate data, show data, or even alert if some thresholds are met, in spite of not having the most beautiful graphical user interface. Now that we know that Prometheus is basically an alert monitoring system, now let's move on and understand why we need Prometheus. As I've already mentioned in the introduction, it basically contributes to the DevOps system by monitoring cloud-native applications and infrastructure, and also by watching over hundreds of microservices. Now, it really works well for recording any purely numeric time series data. Now, another really important benefit of Prometheus is that it fits both machine-centric monitoring as well as monitoring of highly dynamic service-oriented architectures. This is a real advantage. Now, in a world full of microservices, its support for multidimensional data collection and querying is a particular strength. Now, another advantage of Prometheus is that it is designed for reliability. To be the system you go to during an outage to allow you to quickly diagnose problems. Now, each Prometheus server is standalone. Not depending on network storage or other remote services, you can easily rely on it when other parts of your infrastructure are broken, and you do not really need to set up an extensive infrastructure to use it. Now, you must be wondering why Prometheus really, because there are other time series databases that can be used too, right? So one of the noticeable differences between Prometheus monitoring and other time series databases is that it is a pull-based tool, unlike Nagios, Sensui, etc. Now, because it is a pull-based tool, what it really does is it actively scrapes targets in order to retrieve metrics for them. For example, the node exporters or application exporters. So Prometheus expects to retrieve metrics via HTTP calls done to certain endpoints that are defined in Prometheus configuration. Node exporter and application exporters will listen on particular ports, and Prometheus server initiates a HTTP call to this particular exporter and fetch system or application metrics from the end. Now that we know why Prometheus is so important, let's move on and understand continuous monitoring in Prometheus. Monitoring applications and application servers is an important part of today's DevOps culture and process. Now, via continuous monitoring, you obviously want to continuously monitor your applications and servers for application exceptions, server CPU, memory usage, or storage spikes. And you also want to get some type of notification if the CPU or memory usage goes up for a certain period of time, or a service of your application randomly stops responding, so that you can perform appropriate actions against those failures or exceptions. This is why Prometheus is used in continuous monitoring. Now, with monitoring, the number of tools out there such as Amazon CloudWatch, Nagios, New Relic, and many others. But Prometheus is a very popular free and open source project for monitoring dozens of servers, as I've already mentioned, even microservices. Now that we know what is Prometheus used for in continuous monitoring, let's move on and check out the Prometheus architecture. So in Prometheus terms, we call the main monitoring service the Prometheus server. You can see that on the screen. And the things that Prometheus monitors are called targets. So the server is the monitoring service, and the targets is what the Prometheus monitors. So I hope that is clear. So in short, the Prometheus server monitors targets. I said earlier, targets can also refer to an array of things. It could be a single server or a target for probing of endpoints over HTTP, HTTPS, DNS, TCP, or it could simply be a HTTP endpoint that an application exposes, through which the Prometheus server gets the application's health status from. So now let me explain a little bit about metric. Each unit of target, such as current CPU status, memory usage, or any other specific unit that you would like to monitor, is called a metric. So Prometheus server collects metrics from targets over HTTP, stores them locally or remotely, and then displays them back in the Prometheus server. Now, the Prometheus server scrapes targets at an interval that you define to collect metrics from specific targets. For example, for a minute or 30 seconds or whatever you want, you can give the target as, and then it will finally store it in a time series database. You can see the storage box that is in between. That is your time series database. Now, you define the targets to be scraped and the time interval for scraping metrics in the prometheus.yml configuration file. You get the metrics details by querying from the Prometheus time series database, where the Prometheus stores metrics, and you use a query language called PromQL in the Prometheus server to query metrics about the targets. So in other words, you ask the Prometheus server via PromQL to show us the status of a particular target at one particular time. As you can see in the third white box, it accepts queries, that is, it accepts PromQL queries. Now, Prometheus provides client libraries in a number of languages that you can use to provide health status of your application. But Prometheus is not really only about application monitoring. You can use something called exporters to monitor third-party systems. Now, exporter is a piece of software that gets existing metrics from a third-party system and eventually export them to metric format that the Prometheus server can eventually understand. Now, a sample metric from a Prometheus server could be the current usage of free memory or file system free via a node exporter in the Prometheus server. We'll learn all of this in the demo part of this session. Now, I hope Prometheus server is clear to you. So the main component here is the Prometheus server, which is divided into three parts: the retrieval part, the storage part, and the HTTP server. So the HTTP server really accepts queries and displays it in the graphical user interface. Also, we'll be learning about Alert Manager later on in this session. So I hope all of these are clear. Let's move on to the next part of this session and learn about Prometheus metrics and its types. So here each unit of a target, such as the current CPU status, memory usage, or any other specific unit that you would like to monitor is simply called the metric. So the server collects the metrics and stores them either locally or remotely, and then eventually displays it on the Prometheus graphical user interface. Now, moving on, let us check out the 4 different types of metrics that are available. The first one that we'll be talking about is the counters. A counter is simply a cumulative metric that represents a single monotonically increasing counter whose value can only increase or be reset to 0 on restart. Now, for example, you can use a counter to represent the number of requests served, tasks completed, or errors. You always have to remember this to not use a counter to expose a value that can decrease. Now, for example, do not use a counter for the number of currently running processes. Instead, use a gauge. We'll be talking about gauges in a bit. Now, client library usage documentation for counters are Go, Java, Python, and Ruby. Let's move on and understand the next metric type, that is gauges. I'm sure you must be aware of gauge. Now, a gauge is a metric that represents a single numerical value that can arbitrarily go up and down. Gauges are typically used for measured values like temperatures or current memory usage. If you check out a speedometer in a car, it looks like a gauge, right? That is a gauge. That's exactly what we're talking about here. So the client library usage documentation for gauges are Go, Java, Python, and Ruby. The next metric type is the histogram. Now, a histogram samples observations and counts them in configurable buckets. It also provides a sum of all observed values. A histogram with a base metric name of base name exposes multiple time series during a scrape. Now, when you're operating on buckets, remember that histogram is cumulative. Now, moving on to the next metric, we have summary, which is very similar to histogram. A summary samples observations, while it also provides a total count of observations and a sum of all observed values. It really calculates configurable quantiles over a sliding time window. Now, a summary with a base metric name of base name exposes multiple time series during a scrape. Now, the difference between summary and histogram is that here you do not know what the range of values will be upfront, so you cannot use histograms. Whereas in histogram, you know what the range of values will be upfront, so you can just define it on your own. Now, with this, let's move on to the demo part of this session and install Prometheus on our Linux virtual machine. So I'm just going to check out my Ubuntu machine number. So the first thing what we're going to do is we're going to install Prometheus from the official website. So I'm going to go to my web browser. So I'm just going to type in Prometheus in my web browser and I'm going to click the first link. And as you can see, this is the official website of Prometheus. I'm going to click on the download button. So once I click on the download button, it will redirect me to a page. So as you can see here, there are a lot of products: Prometheus, Alert Manager, Black Box Exporter, and a lot more if you keep scrolling down. Right now, we're going to be downloading Prometheus. So we're just going to stay here and I'm just going to click on the operating system as Linux. And this will just show the tar file for the Linux operating system. I'm just going to right click on that and I'm going to click on copy link location. And I'm going to switch back to my terminal and click on wget. And this will download Prometheus for me in my Linux operating system. Now that it's downloaded, I just want to see the list of files in my tar file. So as you can see, there's the Prometheus Linux tar file, which is present currently in my Prometheus folder. Now what I'm going to do is I'm going to copy this file and then untar it using the command tar -xvf. And then I'm just going to paste this file. This will immediately untar the file for me. Once that is done, now I'm just going to list down the number of files that are currently present in my Prometheus file. Now you can see that there's an file which has been untarred here. Clear my screen. Okay, now I'm again going to just list it so you can see it clearly. Now I'm just going to copy this file and enter this directory. So I'm just going to list down all the files that are present. You can see there's console libraries, there's consoles, license, notice,
There's a file that's named Prometheus. So this is the application, the Prometheus application. So I've already mentioned before that the Prometheus.yml configuration file really just defines the targets that has to be scraped, right? And also the time interval for scraping metrics. Now let's just check if all of those parameters that I just mentioned are there in the configuration file. So I'm just going to use scat command for it. You can see that there's a scrape interval parameter of 15 seconds. You can set the scrape interval to every 15 seconds. Default is every 1 minute. So I also have an alert manager configuration. Right now, we haven't set that up, but it's just there. You can also load your own rules and evaluate them according to the global evaluation interval. And you can see by default, it is currently active on the 9090 port. Okay. And by default, a scrap configuration containing exactly one endpoint to scrape is given. That is the Prometheus itself, right? As I've already mentioned before, Prometheus is a tool or an application that will scrape out metrics from different applications. But by default, right now, we have the Prometheus itself to be scraped, and that is currently present on the port number 9090. So I hope that is clear. We will learn about the rules in the next part of the session. We'll also learn about the alert manager configuration in the later part of the session. So both of these will be clear later. But I hope the scrap interval and the scrap configs are clear to you. Now let's move on to the next part. Now I'm just going to clear the screen. Now I'm just going to execute Prometheus by using /Prometheus, and this will immediately activate and get my Prometheus application running. If we move back to my web browser and just type in localhost 9090, this will redirect me to my Prometheus application, as you can see. Now, if I come out of my terminal, right, okay, and I reload my page, you can see that it is unable to connect to my Prometheus. So what I'll have to do is I will have to create a Prometheus service and get that running. So let's learn how to do that. I'm just going to clear my screen. So now to be able to run Prometheus as a service, I'm going to use the copy command. I'm just going to use the cp-r command. I'm just going to copy all of these files that are consisting in this folder to the destination folder. And I'm going to use this command -user local -bin Prometheus. Now for any application to be run as service, you will have to compulsorily have a .service file. So let's go ahead and create one. So to create the service file, I'm just going to use the command sudo vi, and I'm going to enter that particular folder. So as you can see, I just typed out a tiny piece of code. And as you can see here, this is my executable command and this is my configuration file. Let's go ahead and save this. Okay, great. So now that our service file has been created, I'm just going to clear my screen, and now we're just going to start our service file. Now, once that is done, I'm just going to check the status of Prometheus. It is active and running. Great. Now, if I want to stop Prometheus, I'm just going to type in the command sudo service Prometheus stop. Okay. Now that I refresh my page, you can see that Prometheus is up and running. So that's great. I hope it's clear how to create your own service file so you can get Prometheus up and running. I hope it was very clear, and I hope you understood how to install Prometheus into your virtual machine. Now, in the next part of the demo, I'm just going to brief you all about the graphical user interface of Prometheus, so stay tuned. Okay, so now we're going to check out the user interface of Prometheus.
So in the previous session, we installed Prometheus and we got the instance running. Now, if I click on Prometheus, this is where it will take me. Now you can see that there are three options that says enable queue history, use local time, enable autocomplete. You can use the local time if you'd like to enter some time to evaluate the queries. So there's a search bar here for you to type in the expression that you'd like to execute. Now the expression or query that you'd like to execute is usually executed in two different forms, that is the table form and the graph form. As of now, since you don't have any expression and query, it says no data queried yet. Now on the top, you can see three options that says enable query history, use local time, enable autocomplete. So this option will allow you to use your local time. Since I'm in India and it's 10:08 right now, so that's my local time. Now, if I want to also enable my query history, that is all the queries that I have executed in the past. So this option will simply enable me to check out the queries that I've executed in the past. So I'm just going to untick that because I don't have any queries that I've executed in the past anyway. Another interesting thing in this page is that you can add several panels, right? So you can execute different queries all at once. This is great. And this option add panel has been added in the recent times. So this is the new user interface. You also have a classic user interface. I'll shift to that. And you can see that here you can enable query history. That's the only option that's common from the new user interface. Also, you have a bar that will allow you to type in your expression or query. You can also insert metric at cursor. Now, since Prometheus is written in Golang, so you have a lot of metrics that are related to that. You also have metrics related to Prometheus. Now, if I want to execute any of these metrics, I can just click that and I can execute it. You can see that the instance localhost of port 9090 is currently up and running and the job is Prometheus. I can view the graph too if I'd like to. Now let's just execute another query. I'm just going to click Go Info and this will just give me the version of the Golang and the job, etc. So you can just really execute all the queries directly from this option in your classic UI. But as you can see in the new user interface, that option is unavailable. Now let's move on and check out the other options that are available in this panel. Let's click on alerts. Currently, we have no alerts. As I've already mentioned before, that alerts are simply conditions that you will have to specify. And if these conditions are satisfied, so the alert will be triggered to that particular maintainer or manager. So currently, as we have none, it just shows nothing here. So these options will allow me to check my inactive alerts, my pending alerts, my firing alerts. So usually it's an inactive state if the condition is not satisfied. If the condition has been satisfied, then it'll go to the pending stage. And finally, if it exceeds the critical limit or the critical amount, it will enter the firing stage. So you can view the alerts based on these three states, that is the inactive state, pending state, and firing state. Moving on, we have graph. So this is the same as the homepage of Prometheus, right? So we've talked about that. So once I click the status option, you can see that there are 7 different options that drop down. The first one is runtime and build information. This just really gives me, the information about Prometheus. That is the start time of Prometheus, the working directory, the configuration reload. Extra information about my runtime and build is given in this option. Now the alert managers, there are none, so it just says endpoint. Now you can also see the Go version here. You can see the build user, build date, all of that. The version of the build information also is given here. So this is what the runtime and build information is all about. The next option in the status is TSDB status. What is TSDB? TSDB is simply the time series database. So this option allows me to check out my database's status, right? The number of series, the number of chunks. So I can just view the statistics of the head cardinality. So I can just view the top 10 label names with value count. I can view the series count by metric names. And I can also check out the label names with high memory usage. In fact, I can also, take the queries from this top 10 series count by metric names. I can just execute it as a query. And you can see that this gives me the data of and this just executes the information and gives me the data, the list of data that allows me to check out my HTTP request duration in seconds. So also I can view this in graph. So I'm just going to click on that. And this just gives me information of all of the data that is available in the table in terms of graph. So I hope this is clear. Now moving on, we'll check out command line flags. This is just the command line flags that I can use to really make changes in my service file. We created a service file, right, to run this particular service of Prometheus. So this just really gives all the information about my service file. So you can see that there's config file currently in this location. There is also query timeout, and you can view all of that, all of the extra information here. You can check out the web listen address. It's in port number 9090. You can also check out the web page title. Currently, the web page title is Prometheus Time Series Collection and Processing Server. You can change this if you'd like to. You could also check out the web read timeout. So all the information basically about this service that we've created is given in the command line flags. So moving on, we will check out a configuration file. This configuration file we've already seen before, right? This is our prometheus.yml file, right? So this is simply the same file that is given here. You can see global, alerting, scrap configs. You can check out the targets and then finally the port number. Okay, so if you'd like to copy this, you could just copy to clipboard. Moving on to the next option, we have rules. There's none right now, so it shows nothing. Later on in the session, we'll be creating our rules, so stay tuned for that. Now, the next option is targets. There's only one Prometheus service that is up and running, and that is of port number 9090. So the state is up. You can see the instance, you can see the job, and the last scrape, the scrape duration, and if there are any errors that will appear here. Before we move on to the next option, so I'm just going to show you the metrics of this instance, the Prometheus instance that we're running. I'm just going to click on metrics. Now you can see that Prometheus defines a very nice text-based format for its metrics. I'll just zoom this a bit so you can view it better. So now you can see that the data is relatively, human readable. And we even have the help and type decorators to really increase the readability, right? As I've already discussed before, Prometheus has only 4 types of metrics, right? To keep everything really simple. That is counter, gauge, histogram, summary. Now the type and help attributes here help us provide user-friendly hints for each metric in the output. So that's what this help and type decorators really do. They just increase readability. You can't really view all of these metrics and understand what they are. So they're just helping you with the readability. You can see that the help here says go GC duration seconds, a summary of the pause duration of garbage collection cycles, and the metric type is summary. Here you can see the type is gauge, and you can see all of that information. Here the type is counter. Also here the type is counter, gauge again. So that's what really the type will do. So the type will just give you an insight of what type of metric it is. So help will just really describe the metric, and type will just give you the type of metric. So I hope this is clear. So I hope metrics was easy to understand. Now that we finished targets, let's move on to service discovery. And this just shows you, so currently there's just one endpoint that has been scraped, and that is our current running active instance, that is Prometheus. Now it just shows the address, the metrics path, and the scheme, the job, and just shows some labels of the target. So that's all service discovery is all about. And if you'd like to check out and know more about Prometheus, just click the help option in the panel, and this will redirect you to the Prometheus official website. Now the classic UI we already discussed, and this is all for the graphical user interface of Prometheus. I hope it was easy to understand. I hope it was easy to learn. Now let's move on to the next part of the session. Okay, so now in this part of this session, I'll be downloading the Prometheus node exporter. So for all of y'all who don't know what the node exporter is, it really is a way to measure various machine resources. Now the machine resource can be your memory, disk, or even your CPU utilization. So it's a very famous application of Prometheus. So without much ado, let's go ahead and download our node exporter. I will go to my web browser and I'm going to the official website of Prometheus. So the first link will redirect me to the official website of Prometheus. I'm going to click on the download button and I'm going to scroll down and look for node exporter. So I'm just going to copy the link location. I'm quickly going to move back to my terminal and I'm going to download node exporter. So now that the node exporter has been downloaded, now let's just check if the file is available, and it is. So I'm just going to untar this tarred file with the command tar xzf, and I'm just going to copy this. And this command will just untar my file. Okay, so I'm just going to clear the screen. Now let's just move ahead and check out what are the files that are there in our node exporter file. So we have license, node exporter, and notice. Now what I'm going to do is I'm going to use the sudo cp command. So I'm going to copy the node exporter file to my user local bin location. So with the help of the copy command, that is the cp command, I'm just going to create a copy of the node exporter file into my user local bin location. Okay. Once that is done, I'm just going to check out the files that are present in my user local bin location. You can see that there is a node exporter file that has been copied, right? So I've just copied this file into this location. That's all I've done. Moving on, we'll now create a service file. So we created a service file for a Prometheus application, right? So even for the node exporter, I'm going to create a service file using the command sudo vi. So I'm just going to name this as node exporter.service. So I have written down a piece of script the same way we did to a Prometheus service file. Here you can see the description, which says Prometheus node exporter service. You also have the type, you have execution start, which is currently present in the user local bin location. Now, once that is done, I'm just going to save this and I'm going to reload my system. Now I'm just going to start the service. You'll have to make sure of one thing, and that is the node exporter. So what you're naming the service file, you'll have to initiate the same name. So as you can see here, the service file is named as node exporter. So I'm just going to type the same thing here and I will start the service. Once I start the service, I'm just going to check its status and you can see that it's active and running. So that's great. So the node exporter is currently running on address 9100 ports. So we're just going to check it out. And it opens. So you can check out the metrics that are currently running in our node exporters. So this is the endpoint as to where our Prometheus will scrape all of its data. So now that we have node exporter up and running, let us configure the node exporter into our prometheus.yml file. So every time you'll have to configure a particular target, you will have to go to the prometheus.yml file and add the target there. Okay. So what I'm going to do is I'm going to move to my directory. Okay, once that is done, I'm just going to list out all the files. So you have the Prometheus file here. Here you can see the prometheus.yml file, right? I'm just going to clear my screen. So now I'm just going to view all the files that are present in Prometheus. As you can see that there's the YML file here. So we're going to use the command sudo vi prometheus.yml to edit our configuration file. So now you can see there is only currently one job, and that is Prometheus. We have to add another job to our file. So here I'm adding node exporter as my job name, and the target is with IP address 9100, right? So make sure the indentation is correct. So once the indentation is correct, we have applied a target. We have added a target to our configuration file, and we can just save this. Once that is done, I'm just going to clear my screen. So now I'm going to restart my Prometheus and check the status. It's active and it's running. So we can just go back to our page. So you can see here the node exporter has been added to our service discovery with address as localhost 9100. It's localhost because we are currently working on our machine. If you want to add another machine's port address, you can do that too in Prometheus by mentioning their address. And now you can just go back and you can check out the configuration file has its changes.
So it has another target that's named node exporter, and also its port number is 9100. So if I move back to my classic UI2, I can check out the metrics that are here. If you notice, there are a lot more metrics than before, right? You also have the node metrics. If I want to check out the node CPU seconds in total, I can execute it, right? So now that I've executed it, you can check out the CPU's total number of seconds it is hosting the node exporter for. You can also check out the username info of the node. You can see that the instance name is given here, the machine that we're currently working on, the node name is Edureka, the system name is Linux, the version is given here, and also, so the entire node's username info is given if we execute this query. So this is great, right? Like, now your node exporter has been successfully configured into Prometheus. Let's move on to the next part of the session. Before moving on to the next part of the session and configuring Alert Manager, let's understand querying a little bit more in detail. So Prometheus, as we all know, fundamentally stores all of its data as time series, right? Now, each time series is identified by a metric name. We've also discussed this before, and as well as a set of key value pairs that Prometheus calls labels. Okay. Now, the metric name indicates the overall aspect of a system that has been measured. Let me just execute this query, Prometheus HTTP request, duration seconds total. Okay. Now you can see that labels serve to differentiate subdimensions of a metric, such as, the handler, the code, the instance, the job that it's currently running on. Finally, a sequence of samples forms the actual data for a series. Okay. Each sample consists of a timestamp and a value, where timestamps have millisecond precision, and here values are always 64-bit floating point values. The best part of Prometheus queries is that you can add regular expressions, you can specify a time limit, a certain time limit. You can also use different functions. We'll see all of this. So now I could add a certain filter to my query. Now, if I want to just execute the queries with label code 400, I'm just going to add that filter here and execute the query. And this will automatically display the HTTP request in total with code 400. And you can really, add whatever you'd like to in your filters. So that is one way to work with queries. And also, as I've already mentioned, you can also add regular expressions, right? So you can use not equal to, is equal to, and many other things. So for example, if you want to list all the series, no matter which metric name or job, where the handler name starts with API, okay? So you can just simply run this query. What we've done in this regular expression is, so this is obviously a regular expression, right? So in this regular expression, it needs to end with a full stop and a star. Okay, since regular expressions always match a full string in Prometheus. Now, the resulting time series is usually a mix of series with different metric names. Now you know that how to select your time series by the metric names as well as a combination of their label names. So in the next part, we will learn how to calculate rates or deltas of a metric over time. Now, one of the most prominent frequent functions you will use in Prometheus is the rate function. Now, instead of calculating event rates directly in the instrumented service in Prometheus, it is a very common thing or a common way to track events using raw counters. Okay. And to let Prometheus server calculate rates ad hoc during query time. This has a number of advantages, such as not losing rate spikes between scrapes, as well as being able to choose dynamic averaging windows at query time. Counters start at 0 when a monitored service starts and get continuously incremented over the service process's lifetime. Occasionally, when a monitored process restarts, its counters reset to 0 and begin climbing again from there. Graphicking raw counters is usually not very useful, as you will only see an over increasing line with occasional resets. Now we will just use another query for this example. Now I'll just explain you how the rate function really works. And for this, I'm just going to use the query Prometheus HTTP request duration seconds count. Okay. And I'm just going to specify the job as Prometheus.
And you can also view the graphs. It looks something like this. Okay, now to make counters useful, we can use the rate function to calculate their per second rate of increase. This is really why we use rate function. We need to tell rate function over which time window to average the rate by providing a range selector after the series matcher. Okay. Now, for example, to compute the per second increase of the above counter metric as averaged over the last 5 minutes, we can just add the rate function and just specify the time limit as 5 minutes. I'm just going to close the braces and execute the function. Okay. You can check out the graph now. You can see now the result is much more useful, right? Rate function is very smart and automatically adjusts for counter resets by assuming that any decrease in a counter value is a reset. The variant of rate function is irate function. While rate function averages the rate over all samples in the given time window, that is 5 minutes in this case, irate function only ever looks back 2 samples into the past. Okay, it still requires you to specify a time window like 5 minutes to know how far to maximally look back in time for those 2 samples. Now, irate function will really react faster to rate changes and is thus usually recommended for use in graphs. In contrast, the rate function will provide smoother rates and is recommended for use in alerting expressions. Okay, now let's execute the irate function for this. You can see that the graph would look like this, okay, uncovering short intermittent dips in the request rates. Rate and irate functions always calculate a per second rate. So here sometimes you'll want to know the total amount by which a counter increased over a window of time, but still correct for counter resets. You can achieve this with the increase function, okay? For example, to calculate the total number of requests handled in the last hour, you can use the increase function. And I will change this to 1 hour. Now that we know how queries work, how you can use regular expressions, and how you can really use functions in your queries, let's move on to the next part of this session, that is custom roles. Okay, so time series queries can quickly become quite complicated to remember and type using the expression browser all the time, right? So what you can do is, sometimes in some situations you'd want to use some queries very frequently, right? But you don't want to really type the same query over and over again. So in this case, rather than remembering and typing this particular query every time, we can create a recording rule that will run at a chosen interval and make the data available as a time series. So how are we going to do it? So this is a pretty popular query that I'm going to execute. That is node memory 3 bytes. Okay. I'm just going to execute this query. This will just give me how much of free bytes is available in the node exporter. You can see the free number of bytes here. But what if I want to execute this in terms of, percentage? So here you can see the number of memory that the job node exporter is using, and it's just 4. So I'm just multiplying by 100 to check in percentage form. So you can see that it is only using 4 bytes of memory. Now, if I want to see how much of memory is remaining, I'm just going to minus the entire query with 100. So you can see that 95% of bytes is left over. Now, what if I want to execute this query very often, right? So it'd be very time consuming for me to type the whole thing out and then execute it, right? So, but there's an easier way to make this a query, right? So it'll just drop down in your drop down list, and then you can just search for it and execute it, right? So how do we do that? So what we're going to do is we're quickly going to shift back to our terminal. I'm just going to clear my screen. Okay. And I'm just going to move into the user local bin Prometheus directory. And now here we have to create a new file called Prometheus rule. So that's what I'm going to do.
And since it's a YML file, I'm just going to add the YML extension. Here, I'm just going to add the name as custom rules. And I'm just going to specify my rule here. So I just type the whole thing out. I have named this custom rules and I've recorded this query as node memory free in %, and the expression we've already executed is the same one. I'm just going to go ahead and save this. I'm just going to clear the screen. So Prometheus usually comes with a tool called Prom tool, and this Prom tool can be used to really check your rules files, and you can do really a lot of things with Prom tool. For now, we're just going to use this command which I typed out, and we're going to execute this command to check if our file is running okay. And you can see that it checks the Prometheus rules file and it says it's success. Now let's go ahead and add the Prometheus rules.yml reference to the Prometheus YML rule file section. I'm just going to clear the screen. Now I'm just going to enter the Prometheus.yml file. So here I'm just going to enter the Prometheus_rules.yml file. So now I'm just going to save this file. Now once that is done, I'm just going to restart the system. And I'm just going to check the status too. Okay, great, it's up and running. So we're just going to switch back to Prometheus. And I remember naming it free bytes. I'm just going to switch to the classic UI so I can look for it. And it was named node memory free in %, right? This is exactly what we named our query. And I'm just going to execute this. And you can see that it's 95%. So this is how easy it is to make your own queries and execute them. Okay, so now that we've created our, custom rule, so let's just go check out our custom rule. And you can see that it's here. And the state says, okay, so that's great. Now let's go ahead and create our first alert rule. Okay, the same way that we created our custom rule, we're going to be creating our alert rules. This is exactly why I explained you custom rules in the beginning. So I'm just going to switch back to my terminal. I'm going to clear the file. I'm just going to go to the Prometheus_rules.yml file. And once that is done, so I'm just going to type in my alert in this Prometheus_rules.yml file. And once I'm done typing, so I'll just explain you the alert after that. So I've created a rule named alert rules, and this alert will allow you to recognize when your instance is down. So we have currently the Prometheus instance that is running, and we also have the node exporter that's running. So if any of these instances go down for up to 1 minute, and then the alert will be up. Okay, so the severity is pretty critical, and we have given annotations too where we have mentioned the instance. So this just gives a summary of what instance is going down and a description too of the job type. And also we have mentioned the job type and that it has been down for more than 1 minute. Okay, so once this is done, we're just going to save this. I'm going to clear my screen. So the same way that we executed the prom tool command, we're just going to execute that. So we're just going to execute this command. And it says 2 rules found. That's great. Now I'm just going to restart my Prometheus and I'm going to check the status. Okay, it's up and running. Let's switch back to our Prometheus and reload it. Now you can see that there is now an alert rule, okay, which has the alert instance down and the expression is up is equal to 0. So this expression that says up is equal to 0 is pretty interesting because now if I go to my Prometheus and just execute up, it'll just tell me what are the jobs that are currently up and running. Now the value is currently 0. So if the expression turns 0, so then the alert will be activated. So here, this is what the expression really means. So here, if the up is equal to 0 for more than a minute, then the alert will be immediately activated. As I've already mentioned before, the 3 stages, that is the inactive stage, pending stage, and then the firing stage. If none of the alerts are up, then it's just going to be an inactive state. And if, for instance, one of the jobs go down, okay, then it will immediately move to the pending state. So once it immediately moves to the pending stage, then it will wait for a minute, because we have specified the condition that it should be in the pending state for a minute. And if it goes beyond a minute, then it should go to the firing stage. Okay. So once it reaches the firing stage, all of the managers that are involved in getting the notification about this alert, then they will be informed about it immediately. So I really hope you understood how to create your own rules, how to configure them into your Prometheus rules.yml file, and then just really, understand how they really work. Now let's move on and install and configure our alert manager. We'll have to just simply go to the Prometheus official website, click on download, and then you'll get an option called alert manager. I'm just going to click on that. And then I'm just going to copy the link location of Linux, because I've been clearly using Linux machines. So I'm just going to copy that link location, clear my screen, and so I'm just going to download Alert Manager. So once I copy the link location, what I'm going to do first is I'm just going to move back directories. So now I'm just back to my root. I'm just going to move into my Prometheus directory. So I'm just going to download my Alert Manager here. Okay, as you can see that the download is complete. I'm just going to list out the files. And you can see that there's an alert manager, the tar alert manager file. I'm just going to untar this using the command and you can see that using the command sudo tar -xvf, and then I'm just going to paste the link. And you can see that the files have been untarred. I'm going to clear my screen and I'm just going to list out the files. Yeah, so the alert manager file has been untarred. I'm just going to enter into this directory and check out the files that are currently in this. You can see that there's an alert manager executable file. You have alert manager.yml, the configuration file. You have an AMP tool. So now what we're going to do is we're going to be running alert manager as a service. The same way we ran Prometheus and Node Exporter as a service, we're going to also run alert manager as a service. So what I'm going to do first is I'm just going to copy my files into the user local bin. So now I'm just going to create the alert manager service file. If you remember, we also created a Prometheus service file and also Node Exporter service file. So we're just going to do the same. We're going to create an alert manager service file. So once you create your alert manager service file, this is what you'll have to type out. I've typed out the script. So you have a description, you also have the type of the service, and you're just going to mention the location of the configuration file and where the execution will begin from. Okay, once this is done, I'm just going to save this file. I'm going to clear the screen. So I'm just going to shift locations to the user local bin alert manager directory. So I'm just going to list out the files, and you can see there's the alert manager.yml file. So here is where we'll have to make a few changes. That is the alert manager configuration file. So I'm just going to make some changes there. So this is the default file. I'm just going to make some changes here, and I'm just going to explain what the changes are about. As you can see that you have receivers where, you have to configure your email ID, that is your email ID from where you're sending the message, and the receiver who's going to receive the message, right? So you're just going to add a to email ID, you're going to add a from email ID, and you're also going to add a username, you're going to add identity, that is the email ID. and then you're also going to add the Gmail password. Now that all of my email IDs are in Gmail, so I'm just going to mention the public Gmail host server. So I'm just going to add in all my credentials and cut to the next part of the session. And as we have already seen before, there's a tool that is called AMP tool in the Alert Manager. So the AMP tool is just an executable that allows you to view or to modify the current state of the Alert Manager. So I'm going to execute this command user local bin alert manager AMP tool and check the configuration file and then just give the location of my service file. Okay, and once that is done, it's going to check. So I'll just check if it's successfully configured. Once that is done, you can just see that there's one receiver on this end. Okay, I'm just going to clear my screen. And I'm going to start my alert manager. So once I've made changes to my service file, so now I'm just going to execute my command user local bin alert manager AMP tool. Now for all of y'all who don't know what AMP tool is an executable that allows you to view or to modify the current state of the alert manager. Okay, so once this is done, this is successful. So you can just check the config file with the help of AMP tool, and once that is successful, you can just see that there's one receiver. So what I'm going to do is I'm just going to clear my screen and I'm going to start my alert manager service. Now that the alert manager is up and running, you can see that it's currently running on port number 9093. So I'm just going to check out the port where the alert manager is up and running. As you can see that there is 4 different options that are given: alerts, silences, status, help. And you can just filter your alerts, group your alerts, and you can also see the status of your alerts. And you can also see the active, pending, and expired alerts. You can get help from this page too. So you can just see your alert manager in general. And now now with the alert manager active, let's move on to the demo part. Okay, so now that we have set up our alert manager, so we'll quickly shift back to our terminal and I'll clear my screen. So now we have to configure alert manager into Prometheus. I'm just going to move out from this directory and I'm just going to enter the Prometheus directory. I'm just going to list out the files that are present here. So I'm just going to edit my prometheus.yml file. And here, as you can see, I'm going to specify my alert manager. So I'm just going to specify my alert manager to port number 9093. And once I'm done with that, I'm just going to save this file. And now I'm going to restart Prometheus. Okay, it's up and running. So I'm just going to check if my endpoint has been successfully scraped in my runtime and build information. And if I scroll down, you can see that, so the alert manager has an endpoint, right? And this is it. So that's great. We have Prometheus, we have alert manager up and running. Now let's just go check the status of all our targets. We have node exporter, which is up. We have Prometheus, which is up. Okay, now let's go to our alert stage. We have one alert rule that we've currently written and it's inactive. Now let's get into the demo part and let's just stop one of the instances. I think I'm going to stop my node exporter instance, and once that starts, so let's just see how the alerts go by when one of the instance is shut down. Okay. So I'm just opening a new terminal, and what I'm going to do here is I'm just going to okay, now what I did is I just entered my Prometheus directory. I just listed down the files, and we have the node exporter file. I just changed the directory to the node exporter and listed down the files.
And currently the node exporter is up and running, obviously. But now what I'm going to do here is I'm just going to stop this service. Okay, before that, I'll just clear my screen and I'm just going to stop the service. And I'm just going to check the status. So it's inactive. And once that is done, I'm just going to quickly shift to my status of the target. So you can see that one of the target is down. And I'll just execute the up query. And you can see that the node exporter has the value 0. That is, it's down. Okay. I'm just going to check the alerts. You can see that the alerts is in the pending state, right? There's 0 in inactive and there's just 1 in pending. So it's just going to be in the pending state for a minute. If you remember, we had specified that for a minute, it's going to wait if the instance is going to be down. So once it crosses the 1 minute threshold, it's going to go to the firing stage. Here, it's going to alert the manager. That is me currently. I will receive the mail saying that one of the instance is down and it's a critical alert that you will have to address immediately. Okay. So that's how it really works. Now let's reload the page. And you can see that after a minute, it's entered the firing state. Okay. And there are none in pending state. So it was in pending state for a minute and then it moved to the firing state. So in the previous session, we learned about how to create our own alerts in Prometheus and how to be notified about these alerts so that we can take discrete actions whenever necessary. So in the next part of the session, I'm just going to integrate Prometheus with one of the most famous visualization tools in DevOps, that is Grafana. So before I explain you about Grafana, I'm just going to briefly explain you about Node Exporter and how we're going to be displaying its metrics in Grafana. So Node Exporter is simply an exporter that collects technical information from Linux nodes, right? Such as CPU, disk, memory statistics. I'm sure you must be aware of this by now. So the metrics that the node exporter exposes of the Linux machine that we're currently working on, that is Ubuntu, all of these metrics are going to be visually represented in Grafana. We know that Prometheus doesn't have like a great UI, right? All of the information is very textual and it's not very like visually appealing. So with the help of Grafana, I just really want to, expose all of these metrics in a graphical representation like gorgeous or, bar graphs, anything. It could be anything. So before we download Grafana onto our Linux machine, I am quickly going to be making some changes in the YML file. Before that, I'm just going to check if my Prometheus is up and running. It is. And I'm also going to check if my node exporter is up and running. It is. So that's great. I'm just going to clear my screen. Okay, so now that is done. So I'm just going to list down the files that are currently in the Prometheus directory. And I'm just going to shift to my Prometheus file. So I'm just going to move into this directory. I'm going to list the files. Okay, great. So we're just going to make some changes in the prometheus.yml file. I'm just going to. Okay. Now you can see that you have our alert manager configuration, our rule files, scrape configs, a job name. But here in the static config, so I'm just going to add the node exporter as a target too. I'm just going to add the IP address of, currently it's running on localhost 9100. Okay, great. Just going to save this. And I'm going to restart Prometheus. Okay, it's up and running. I'm just going to clear the screen. Okay, great. Just going to go down. So now I'm just going to go back to my Prometheus directory. And now let's go ahead and download Grafana. I will click on my web browser and I'll just go to the official website of Grafana. So this is the official website of Grafana. I'm just going to click on the download button. So on this page, you can just click download. And then if you scroll down, you can see Linux. So these are some of the commands that you can use to download Grafana on your Linux machine.
So I've already made a list of all of these. So I'm just going to use them to download Grafana. And okay, now that Grafana has been installed, I'm just going to clear my screen and I'm just going to check if it's up and running. So I'm just going to use this command to start the Grafana server, and then I will check the status of it. And it's up and running. Currently, it's running on port 3000. I'm just going to quickly shift to my web browser and check. As you can see that Grafana is up and running. That's great. If you've newly installed Grafana, the email address and the password by default is admin. Okay, and you can obviously create your own password. So once you're prompted with your credentials admin, then you can just create your own password and submit it. But I'm just going to skip this for now. And this is how the Grafana user interface really looks like. Okay, you can see that there's a search button, there's some icons on the left hand side, and there are also panels that you can play around with. So you can create your dashboard that will allow you to create beautiful visualizations for your data source, right? So once that is done, I'm just going to add my first data source. Just going to click this option in the basic panel. And here, as we are going to be working with Prometheus, we want our data source to be Prometheus. I'm just going to select this and it says data source added. So you can name your data source anything you'd like, but I'm just going to let it be Prometheus for now. And our URL of Prometheus is localhost 90, right? Once that is done, I'm just going to check if everything looks fine. Yes, it does. So for adding a data source, all you have to do is name it and then add a URL. That's how easy it is. I'm just going to save and test this. And this is great. It's working, right? So once I've saved and tested it, so I'm just going to click the Grafana icon that's present on the left top corner, and this will redirect me to my homepage of Grafana. Okay, now that we are done with this, I'm just going to click the plus icon and click on the option import. So what we're going to do is we are going to import the dashboard from grafana.com. So if I search for Grafana Node Exporter dashboard and click on the first link that's available, it will redirect me to a page which has the name Node Exporter Full, right? So what it really does is it has an ID. The Node Exporter has an ID. So I'm just going to copy this ID to the clipboard and I'm quickly going to import this ID here, okay? And I'm going to load it. Because we're using the Node Exporter dashboard in Grafana, I'm just going to copy that ID and I'm going to go down. If you want to change the name, you can do that. And I'm going to select Prometheus as my data source. And I'm going to import this. Once that is done, you can see a beautiful representation of your CPU, your system load, your RAM used, and the root FS, the swap used. All of the information is beautifully being represented in gauges, right? These are gauges, okay? And these are the graphs currently. You can see that it's just been used here. You can see busy system, busy user, and all of how long it's been idle for. All of the information about the CPU. This is basic CPU information. You have storage disk. You have 8 panels here. You can see that here. So there's several different panels that have already been created by Grafana, and all you have to do is import it and add your data source. That is your Prometheus, right? And this is way better than viewing it on Prometheus because Prometheus has everything in text and in terms of metrics. So it is very boring to view it like that. I'd obviously prefer Grafana to just view all of this.
why do we need continuous monitoring? There are 4 major reasons as to why we need to practice continuous monitoring. The first and obvious reason is it allows us to have better network visibility and transparency. Continuous monitoring offers DevOps teams clarity on the state of the IT infrastructure by automatically collecting and analyzing data to reflect possible outages and important trends. It also facilitates rapid responses. A primary aspect of continuous monitoring is implementing an alert system that immediately notifies the right people the minute an IT incident emerges. So, this basically enables timely response to security threats or functional stopgaps, minimizing damage and eventually allowing faster restoration of the system to optimal operational levels. The third reason is it minimizes system downtime. Now, consistent system monitoring and quick necessary alerts help maintain system uptime by raising the alarm when there is a service outage or any application performance issues. The fourth reason is it helps in assisting with healthy business performance. Reduction in system downtime also obviously minimizes negative impact on customer experience, thus safeguarding the organization against losses in revenue or credibility. Also, continuous monitoring tools can be used to track user reactions to software updates, which is useful for several teams like the development team, quality assurance team, sales, marketing, etc. Now that we know why we need continuous monitoring, let's understand what is continuous monitoring. Continuous monitoring, also sometimes referred to as continuous control monitoring, is an automated process by which DevOps personnel or anyone can observe and detect compliance issues and security threats during each phase of the DevOps pipeline. Outside DevOps, the process may be expanded to do the same for any segment of the IT infrastructure in question. It basically helps teams or organizations monitor, detect, study key relevant metrics, and find ways to resolve said issues in real time. As we have already seen in the previous slide, continuous monitoring comes in the end of the DevOps pipeline. Now, once the software is released into production, continuous monitoring will notify developers and quality assurance teams in the event of specific issues arising in the production environment. So, what does continuous monitoring really help in? It basically assists the IT organizations, DevOps teams in particular, with procuring real time data from public and hybrid environments. This is especially helpful with implementing and fortifying various security measures, incident response, threat assessment, computers and database forensics, and root cause analysis. It also helps provide general feedback on the overall health of the IT setup, including offsite networks and deployed software. Moving on, let us check out the continuous monitoring tools in DevOps. Now, there are several DevOps tools for the monitoring ecosystem that help both development and operation teams work together effectively. Now, the first one is the monitoring tools. It should come as to no surprise that we're starting a discussion of DevOps tools with a focus on the set we know best, that is monitoring tools. A good monitoring platform lets you monitor infrastructure and application performance, whether on-prem, in the cloud, or across containerized environments, so you have complete visibility into every system all the time. Now, some of the tools are Sensui, Nagios, Prometheus. Now, Sensui is a flexible and scalable telemetry and service health checking solution for monitoring servers, containers, services, applications, functions, and connected device. Prometheus, on the other hand, relies on the pull method to collect information with a built-in database. Nagios is the legacy monitoring tool that introduced monitoring practices to a generation of operators. The next one on the list, we have DevOps configuration management tools. Now, configuration management tools allow you to automate the provisioning and deployment of systems, enforce desired configurations, and remediate configuration drift. By modeling your infrastructure as code, you can apply software delivery practices like version control, automated testing, and continuous delivery to infrastructure and applications. Some of the tools are Ansible, Chef, Puppet. Ansible is written in Python, which is agentless and utilizes an imperative approach. Chef, on the other hand, is written in Ruby, which also relies on an imperative configuration management approach. Puppet, on the other hand, relies on a declarative configuration management approach, using a domain-specific language and an agent master architecture. Moving on, we have DevOps alerting tools. This provides both actionable and informational system alerts and can be customized to fit the complexities of your system. Now, for example, your alerting system needs to be sensitive enough to cover an outage, but not so sensitive that you're catching frequent and unnecessary problems that users aren't really going to see. There are some alerting tools like PagerDuty, ServiceNow, Slack. PagerDuty is an on-call management platform with add-ons for analytics, event intelligence, and automated incident response. ServiceNow, on the other hand, utilizes automated workflows for ITSM as well as customer service and business processes. Slack, on the other hand, lets you consolidate alerts into the same platform you use for group chats and collaboration. Next on the list, we have metric storage. Once you've automated configuration management, alerting, and monitoring, you will have a whole lot of data at your disposal to learn from. The challenge is, how do you securely store and analyze it? You obviously need a storage system that lets you aggregate and learn from system capacity, user behavior, service levels, security risks, and much more. This is exactly where metric storage comes into the picture. The different types of tools are InfluxDB, Splunk, AWS. InfluxDB is simply a time series database that's suited for long-term data storage. Splunk, on the other hand, uses a search engine database model to store and query data. AWS, on the other hand, supports a wide range of storage purposes, including relational and non-relational databases, a data warehouse for analytics, a time series database, a ledger database to store transactions, and much more. In this session, along with Grafana, we will also learn how to configure InfluxDB to get real-time data, so stay tuned for that. Moving on to the last type of continuous monitoring tools in DevOps, we have visualization tools. Now, a visualization tool might be considered essence of your DevOps tool chain for monitoring. You get to basically combine all of your data here, sort and finally visualize it, that is, display it on customizable dashboards. Now, what really visualization tools do is they provide context and meaning that allow you to track changes and improvements over time. And they also give management a real-time view that helps guide strategic decisions. Customization options make it easy for team members to design and share their own dashboards. Grafana can be used on top of a variety of different data stores, including Graphite, InfluxDB, and Elasticsearch. Now that we know that Grafana is a visualization DevOps tool, let's move on to the next part of the session, Introduction to Grafana. Firstly, let us understand what is Grafana. Grafana is a multi-platform open source analytics and interactive visualization web application. It basically provides charts, graphs, and alerts for the web when connected to supported data sources. Grafana is expandable through a plugin system. It allows you to query, visualize, alert on, and understand your metrics no matter where they are stored. Create, explore, and share dashboards with your team and foster a data-driven culture. Also, Grafana has become the world's most popular technology, which is used to compose observability dashboards with everything from Prometheus and Graphite metrics to logs and application data to power plants and beehives. With all of this said, let's move on and check out some of the features of Grafana. The first one is to visualize. From heat maps to histograms, graphs to geomaps, Grafana has a plethora of visualization options to help you understand your data beautifully. The second feature is alert. And Grafana seamlessly define alerts where it makes sense while you're in the data. Define thresholds visually and get notified via Slack, PagerDuty, and much more. You can also unify in Grafana. Bring your data together to get better context. This is because Grafana supports dozens of databases natively, and the best part is that you can mix them together in the same dashboard. The next important feature is that it is open source. Grafana gives you various options. It's completely open source and backed by a vibrant community. Use Grafana Cloud or easily install it on any platform. The next important feature is that Grafana can extend. You can discover hundreds of dashboards and plugins in the official library of Grafana. Because of the passion and momentum of their community, new ones are added almost every week. The last feature of Grafana is collaboration. You can bring everyone together and share data and dashboards across teams. It basically empowers users and helps foster a data-driven culture. With all of this said, let's dive right into the demo and install Grafana into our local machine. Now I will be working on my Linux virtual machine, that is Ubuntu. And if you are working on it too, then you can follow the same procedures to download Grafana onto your local machine. Now, to do that, we will firstly go to the official website of Grafana. So here you can see how you can install Grafana on Ubuntu. So there are some set of commands that you'll need to incorporate to download Grafana onto your system, and you'll have to just follow that. Now I'm going to open my terminal. So once we install Grafana onto a local machine, I'm going to explain you the entire graphical user interface of Grafana and how it really looks, how we can make dashboards, how we can make new panels in your dashboards, etc. All of that we'll be learning in this part of the session. Moving on now, let's go ahead and install Grafana into our system. So I have a set of commands already in my notepad, so I can just copy paste it and I can make the entire process more easier. So I'm going to copy the first command in the notepad, and this will allow me to download the packages for Grafana. So now that's done, I'm going to download Grafana and all of its packages, and then I'm going to start and enable Grafana server. Now the Grafana server has started, you can see here, and its status is active and running, so that's great. So in the next step, I want to know on which port is my Grafana instance running on. So for that, I'm just going to type in the command sudo ls of -i -p. So this command will give me a list of instances that is currently running on my VM. And as you can see, Grafana instance is running on port 3000. So now I'm going to open my local browser and I'm going to type localhost. And since the Grafana server is running on port 3000, I'm going to type that. And this will redirect me to the login page of Grafana. And as you can see, the Grafana page will prompt you to enter the username and password. By default, the username and password of your port 3000 is admin. So the username is admin, the password is admin, and I'm going to log in. Now, if you want a new password and you don't want it to be admin, you can just type in your new password and confirm it and then submit it. For now, I'm just going to skip that. Now you can see the home page of Grafana, and it's very interesting because all of these that you can see, the blue big boxes that you can see, are all panels. You can really play around with these panels. You can view them, you can edit them, you can share them, you can duplicate these panels, you can remove these panels. You can also move around these panels. So this is really interesting. Even the Welcome to Grafana panel can be moved around, can be edited, it can be shared. You can remove it, you can make changes. You can really play around with all of these panels in Grafana. And if you scroll down, you can see a blog which will give you the latest updates about Grafana and its changes that are occurring every day. Also, there are a list of dashboards on the left-hand side. This also is a panel, and you can just view, edit, share them, and do whatever you want with it. Currently, you can see there's only one dashboard that I've worked on, and that's the world map dashboard. So this is the homepage of Grafana. And if you want to return back to the homepage of Grafana at any point of time when you're working on this application, you can simply click on the logo on the left-hand corner, and this will just redirect you to this main homepage. Now, if you can see on the right-hand side, there are two symbols. The first one which says dashboard settings, and the next one which says cycle view mode. Now, the dashboard settings is pretty interesting because if you click on that, because you can access to the general configurations of the application. You can name your main Grafana as whatever you'd want to. You can also add a description to the home dashboard. You can add tags. You can also place it in a general folder, which is pretty interesting. You can edit it. You can auto refresh it based on time, etc. You also have annotations, variables, links, JSON model. All of these are not really necessary. Because this is a beginner tutorial, I'm not going to discuss any of these in details, but this is what the home settings allow you to do, the dashboard settings. Now, the cycle view mode is pretty interesting. Now, if you want the left-hand panel, you can see a left-hand panel with certain icons that are present. If you want to not view this, you can just click on the cycle view mode and that'll disappear. And even if you want the home tab to disappear, you can just click on the cycle view mode and it will just hide everything. And if you want to get back the panels, you can just click the escape button on your keyboard and everything will return back to normal. So I hope this is clear. I hope this homepage was really easy to understand. Now let's move on and check out these icons that are present on the left hand side. So if you want to search any of the dashboards that you've created, you can obviously click on the search button and then just search it by name. So you can sort them based on alphabetical order. As I've already mentioned, there's only one dashboard currently that I've worked on that is named World Map. Let's move on to the next icon, the plus icon, which will give me 4 different options that says create dashboard folder import. Now, if I want to create a new dashboard, I can click on this dashboard option and it will redirect me to a page where it says new dashboard and you can add a new panel. Now, the panels are pretty interesting because you can really play around with these panels. You can increase its size, you can decrease its size, you can move around with these panels by just hovering your cursor over the top part of the panel, and then you can really move around and play around. You can also add panels to this by clicking on that, and this will redirect me to another page where I can give my panel title, I can add a description to my panel, I can choose what kind of visualization I want to represent my data in. If I want to represent it in a graph, I can click the graph. If I want to express it in a gauge form, I can do that too by clicking on the gauge option. It's really interesting. You can really pick your options out. There are various options. You can also view the plugin list options. There are several thousands of plugins that are available on Grafana, which you can download on your VM, and you can view these panels here. So that's interesting. Moving on, we also have queries. You can select your database from this option. Currently, the default data source is selected. You can also write your queries as you'd like to display them, and that will be expressed in the visualization form that you have selected. We can remove these panels by clicking on the remove button. If you want to add a new panel, you can just click on this add panel option. You can add as how many ever as you'll need. So there's no limit to this. So you can add how many ever panels you'd want to using the add panel option. You can also save this dashboard. You can name it as whatever you'd want to, and you can choose a folder. So we're going to learn about that in the next part. So you can create different folders and you can save different dashboards to each of these folders. That's what the folder option will allow you to do. And you can also check out the dashboard settings. We've already discussed this. And you can also, again, view this in a cycle view mode. And there's a time range that you can pick using this option, which will allow you to display data in terms of time. And finally, you can zoom out and you can also refresh the dashboard. If you've made any changes, you can save it and refresh your dashboard. And the incorporated changes will display immediately. I hope this is clear. The new dashboard option is a pretty important option, and this is what you'll really be working on in most of this application. As I've already mentioned previously, you can create as many folders as you'd like to. So I can name my folder anything I'd want to and then just create one. And whenever I make a new dashboard, I can save those dashboards that I'd want to save in that particular folder. So this will allow me to really manage my folders. Also, there's an option called playlist where I can create playlists to cycle dashboards on TVs without user control. And the last options will allow me to view my snapshots. So with this, I hope the folder option is clear. So this option will allow me to import dashboard from the file or, from the official website of Grafana. The next option is the explore option. So here you can really just explore the entire database and you can just add new queries. You can run queries. So this option will allow me to write queries for my data, and the options or the results of these queries will be displayed here. So the explore option is a little different and it's pretty interesting. Moving on, we have alerting. Alerting is another really important option in Grafana. So what really Grafana alerting allows you to do is it allows you to attach rules to your dashboard panels. So when you save the dashboard, Grafana extracts the alert rules into a separate alert rule storage and schedules them for evaluation. You can view all of these alerts or you can search for alerts in this option. So in the alert tab, you can also specify alert rule notifications along with a detailed message about the alert rule. This can be done via the channels. So you can create rules and you can just search for them. Alerting is a really important option here. Moving on, we have configuration. Now, this configuration part is extremely important because this will allow you to add a data source into your Grafana, right? So you can click on the option add data source, and this will redirect you to a page where you can see a series of different databases. You can see time series databases, you can see logging and document databases, you can see distributed tracing, you can see SQL, cloud, etc. So you can just select any of them and just create one. You can see that in time series databases, you have Prometheus, you have Graphite, you have InfluxDB, and in SQL, you have MySQL, PostgreSQL, Microsoft SQL Server. In cloud, you have CloudWatch, Azure, Grafana Cloud, and you have many other options that you can really select. So this is great. So you can just add your data source using the data sources option in configuration. Also, you can control and view the different users that are working in your Grafana by clicking on the users option. And you can also search the user by their name, email, login, etc. You can create teams. So you have a particular project and you want to work with a particular team. You can just create any number of teams that you'd like. Grafana provides n number of plugins that you can download from the internet, and you can incorporate these in your dashboards or in your panels. So these are really interesting. You can search them by name or type, and you can also download more plugins on grafana.com by clicking on this option. Moving on, we have preferences. You can update your organization profile. You can also switch on to different themes. Here, if I click on the light theme and then save it, it will change my Grafana into a light theme. And because I prefer the dark mode, I'm just going to switch back to that. Now, the last operation in the configuration is the API keys. You can add a new API key. That's all this option really allows you to do. Finally, you have the option server admin. Here you can view the users, you can view your organizations. So this option really just allows you to check out your system settings that are configured in Grafana. Also, you can just check out the statistics of the users, admins, viewers, the active sessions, your total number of playlists, your total number of snapshots, how many dashboard tags you have, how many alerts you've got, and how many users have been active since a particular amount of time. That is here 30 days. All of the statistical activities that are occurring in Grafana can be viewed in this option. And finally, you can also upgrade your Grafana to Grafana Enterprise. So this is what the entire graphical user interface is about. There are other two options that I'd like to talk about. Is this icon that you can see on the left corner. This will allow me to sign out. This will allow me to change my password and also change my preferences. Now, if you'd like to edit your profile, make some, really nominal changes, or you'd like to change some preferences, you can click on this option and just do that. You can also change your password here if you'd like to. And if you click on this question mark icon, you can see the version of Grafana. Currently, we're working on version 7.3.7. And these are all the community support, keyboard shortcuts. All of this is given in the help option. So I'm just going to click on my Grafana logo and move back to my Grafana homepage with my home dashboard. So I hope this part of the demo really gave you an overview of how Grafana looks like, how Grafana works, or how you can get started really with Grafana. And also, I hope it helped you install Grafana into your local machine, because that is really important. Once you install it and once you configure it, you can just get started with it. Now, before we get into the demonstration, let us just go check out what we're going to create. So firstly, we'll be creating a world map which will show us the confirmed cases of COVID-19 over the past 1 year. So all the panels that we've really created here is the data of the past 1 year itself. As you can see on the left bottom corner of the world map panel, there is a white tiny box which is called as a legend. And as you can see, cases with less than 100 cases is represented in green color, and 100 to 10,000 cases is represented in orange color, and cases above 10,000 is represented in red color. So only the confirmed cases has been represented on this world map. Now, if I scroll down, you can see a bar graph which represents the confirmed cases, death cases, and the recovered cases of India. So the green one represents confirmed cases, the blue line represents the recovered cases, and the yellow one represents the death cases. This is again representing the cases over the past 1 year in India. So if I scroll down, I've created 3 more panels of the confirmed cases in India, death cases in India, and recovery cases in India. And this is the average number over the past 1 year. This is not the total or the sum of all the cases. And I've represented these panels in the form of gauges. Now, moving on, I have also made 4 different panels representing each of the state cases. Okay, so here we have Maharashtra, Karnataka, Delhi, and Kolkata. And this is the graph of their recovered cases, death cases, and confirmed cases. So this is a panel which represents the state Maharashtra, and the recovered, confirmed, and death cases are represented in the form of a graph. So this is what we're going to create. I hope you guys like it. Without much ado, let's get started. So before we begin, we have to install a data source into our local machine, right? So for this demonstration, I'm going to pick InfluxDB. InfluxDB is basically an open source time series database, which is optimized for fast, high availability storage and retrieval of time series data in terms of fields. You can use InfluxDB for operations monitoring, application metrics, Internet of Things sensor data, and also real-time analytics. That's what we are going to do, right? So to install InfluxDB, we can go to their official website and check out the commands to install InfluxDB on Ubuntu. So these are some of the commands that is given in the official website. I have just made a list of it in my notepad so that it'll be easy for me to install it. You can also follow the same procedure, else you can just go to their official website and get the commands to install in your operating system. So I'm going to switch back to my terminal. So these are some of the commands that will allow me to install InfluxDB into my Ubuntu. So I'm just going to copy this and I'm going to paste this. And once that is done, you can copy the remaining commands that will allow me to install InfluxDB and start it on my server. Now the last command, I'm going to copy paste the last command, and this will start my InfluxDB. Now to check on which port my InfluxDB is currently running on, I am just going to type out the list of current running instances. My bad, it's sudo ls of -i-p. And this will give me the current running instances. As you can see that InfluxDB is running on server 8086. So that's great. We have InfluxDB running. We also have Grafana server running on port 3000. Now that we have both our Grafana server and InfluxDB up and running, we can move on and create our database and activate it. I'm just going to clear the screen. So now I'm just going to type influx and I'm going to enter my shell of influx. Here I want to check out the databases that are currently present on my influx database. So it will show me 2 databases, that is internal database and COVID. So internal database is a default InfluxDB database, and COVID is a database that I have created manually in the past before. Now, if you want to create your own database like the one which I just created, COVID, you can just type create database COVID-19 and click enter. This will automatically create the database COVID. Now, if I click on show databases, it will show me that there is a new database COVID-19. Now I can use the database COVID-19 with the command use COVID-19. And if I click on show measurements, it has none right now. So it's not going to show any measurements. Now we'll switch to Grafana and we will activate our COVID-19 database into InfluxDB. So now I will switch to my homepage of Grafana and click on add your first data source. And this will redirect me to my database page, which will give me a list of all the databases that's available. Since we'll be working on InfluxDB, I'm just going to select this. And this will redirect me to a page where I can name my InfluxDB database as whatever I'd like to name it. And it will also prompt me to enter a URL. So as we already know, the InfluxDB is currently active on port number 8086. I'm going to write that. And if I scroll down, it will also show InfluxDB details. And here I can select my database. So I'm just going to type COVID-19. Okay, so that's clear. There's name InfluxDB1. We will also add in the URL with port number 8086. And we will also give in the details of the database that we're currently working on, that is COVID-19. And we will just click on save and test data. So it says data source updated, data source is working. This is great. Now I'm simply going to go ahead and create my first dashboard. I'm going to create my first panel, and the first panel that we're creating is the world map data. So by default, you won't have the world map visualization. You will have to go to the Grafana plugins website and you will have to download the world map panel by yourself. So you will have to go to Grafana plugins and click on panel option here. And you can see that the first panel that will turn up is the world map panel. I'm going to click on the world map panel and going to click on the installation. And you can see that there is a command which will allow me to install the world map panel. So I'm just going to copy this. I'm going to quit from this and going to type in sudo, and I'm going to paste the command that I just copied. And this will immediately install the Grafana world map panel into my Grafana application. After the Grafana world map panel has been installed successfully, I will have to restart my Grafana. For this, I will click on sudo service Grafana server restart. And this will automatically restart my Grafana server. Now, if I switch back to my dashboard and reload this page, and if I just click the world map, you can see that the panel has been added. So I'm just going to click on that panel. Now, what we're going to do is we are going to get our data set. For this, I'm just going to download my data set from trackcorona.live.api. So the reason as to why I'm using this data set is because the world map plugin has a format that needs to be followed. So there is latitude, longitude, there's the name of the country, and also there is a metric. The metric is another parameter that needs to be followed, which will allow you to give you a certain radius for the particular country that you are representing on the world map. So all of this format is clearly satisfied on this trackcorona.api database. And all of this format is satisfied in this country level data on trackcorona.live API. So I'm just going to download this link location and directly download it on my terminal. And I will just do this by typing in the command sudo wget. Now that I copied the location of the dataset, I'm just going to download it directly on my virtual machine with the command sudo wget, and I'm going to paste the link location, and this will automatically download the dataset into my local machine. Now you can see that the countries.csv has been successfully downloaded and saved, and I can view this countries.csv.1 when I list it down. I'm going to clear my screen. So once I clear my screen, now I will go and I will start coding. I will create my first Python file. I will name this worldmap.py and I will start editing my file. First, I will have to import pandas as PD. I will also require a client for my InfluxDB database. So I'm just going to type from. So as you can see that I've already typed out the entire code, so I can now explain it to you. And as I've already mentioned, firstly, you'll need to create a client and you will have to incorporate two parameters for this client, that is the host and the port number. So that's what the code does in this line. Then you'll have to connect the client to the database, and since our database name is COVID-19, I'm going to pass that. And then you'll have to read the CSV file. So whatever the name is of your CSV file, just add that here. Then I'm going to drop the null values and then print it. And in this for loop, I'm just going to iterate over this df. And for every row inside this df, I will add a value inside my influx server. Now, influx server is a NoSQL database. So you need to send in the JSON format database. So this JSON body has basically three fields, three really important fields. The first one is measurement, the second one is tags, and the third one is fields. So measurement is the table or the name in which the data is stored. And for now, we're just going to name the measurement as COVID map. The tags are the property which is repeated. Now, what I'm going to do is to explain this, I'm just going to download this CSV file. Now, once I download the CSV file, I can see the location. There's a location that is the country name, and there's also code for that country, for that particular country. You also have the latitude, longitude data. You have confirmed, dead, recovered, updated, etc. So the second field, that is the tag field, is a property which is repeated several times. For example, the country names. The country names have obviously repeated several times because based on the case and the confirmation or the death, there's a country name, right? So obviously here in this database, the country has been repeated several times. So if there are cases from the United States, there are many cases of United States. So that particular country has been repeated several times. Tags is basically property which has been repeated. Now I'm going to keep the tag as the country, and because it's in row 0, the country name, I'm just going to mention that row 0. So the next one is fields, and this is anything except the tags. So anything which is not a tag is basically a field. So there are 4 different parameters here, that's name, latitude, longitude, and metric. I've already mentioned this earlier in the session. So the name is again in row 0, the name of the country. The latitude and longitude is given in row 2 and row 3. So 0, 1, 2, 3, right? So row 2 and 3. I've specified that row 2 here. And then the metric is given in row 4. So the metric here can be either confirmed, dead, or recovered. So you can either represent the dead cases in your world map, or you can also represent the recovered cases in the world map. But right now I'm just going to represent the confirmed cases on the world map. So I'm just going to pick that as my metric, and that's on row 4. So I've just mentioned that. Then I will finally pass on the JSON body to my client, and then I'm just going to print done. Now I hope this piece of code is clear. I'm just going to save it. Once that is done, I can just run this file. So it's python3 worldmap.py. Okay, great. So it's clear. And I'm going to install pandas and influxdb. So I'm just going to click pip3 install pandas influxdb, and this will automatically install pandas and influxdb for me. Because I already have both of these installed, it says requirement already satisfied. If you don't, it will download for you. Now moving on, I will clear the screen and execute my world map Python file. So it has 230 columns and 8 rows. Now I will enter my influx shell and I will check out my databases. I'm just going to use my database COVID-19. And after that, I'm just going to check out my measurements. So we just created one measurement in the world map Python file, and that is COVID map. So that's given here. Now moving on, we will check out the data information in our COVID map measurement. As you can see, there's time, there's name of the country, there's latitude, there's longitude. That's great. Okay, now we'll switch back to our dashboard and create our world map panel. So I'm just going to create a dashboard, add a new panel, and then here I'm going to click on visualization as world map. The panel is right here. So first what I'm going to do is I'm going to select my InfluxDB1. Then I'm going to select my measurement as COVID map, and I'm going to add the fields. There are 3 fields. I'm going to remove this field. The next field that I'm going to add is longitude, and I'm going to add another field that is metric. Then I will add name. I'm going to remove this too and format it as a table. Once that's done, I am going to check out my map data options. Now in the map data options, I'm going to click the location data and select table. And in the field mapping option, the table query format should always be in terms of coordinates. And as soon as I click that, you can see that there are circles that appear in the world map. Now the location name field is name. Now once I specify the location name field as name and refresh my dashboard, so when I hover my cursor on a certain area, then it will show me the name of the country. So you can see that the green ones have 10 plus cases. So the legend that is present in it will give me an idea of what each color represents. So the green currently represents more than 10 cases, and orange will represent cases that are between 0 to 10, and red will represent cases that are less than 10. So we'll just change this threshold. You can change the threshold options here. So I'm just going to keep the threshold as 100 and 10,000, and I'm just going to save this. So the cases that are less than 100 should be in green color. So I'm just going to apply that. So the cases that are more than 10,000, I'm just going to represent that in red color. So I'm going to click on the red color. I'm going to apply. And now you can see that the countries with more than 10,000 cases are going to be in red color, but the countries between 100 to 10,000 cases are going to be represented in orange color, and the countries with less than 100 cases are going to be represented in green color. So this looks pretty good, right? Now we'll just go to the setting and then just change the name of this to world map. Okay. I want to have a transparent background, so I'm just going to use this option to switch to that. And I think everything looks good. I think our map is ready. I'm just going to save this, and I'm just going to save it in the general folder. Once that is done, I will elongate my map so you get a clear picture of how it looks. This looks good, right? Now let's quickly move on to the next part of this demo. Now for the next part of this demo, we're going to go to Kaggle, and I will look for COVID-19 datasets. So in the search keyword, I'm just going to search for novel coronavirus 2019 dataset, and I'm going to click the first dataset. And if I scroll down, this dataset has a serial number, observation date, the state, the country. This is perfect for me for the next part of the session. So I'm just going to download that. And then once I finish downloading it, you can see that you have an observation date, you have the state, country, the last update, confirmed deaths, and recovery. So here in this particular data set, you can see there's a serial number, there's an observation date, you have the state, you have the country, you have the last update, confirmed case, the deaths, and recovery based on that particular date. Now this is great for me. So I'm just going to paste this data directly into my file. As you can see, the COVID-19 data set is already here. I'm just going to place this in that directory, the Edureka directory. I'm just going to click clear. And now I'm just going to check my ls. You have the COVID-19 data set here. So now I'm just going to create a file that's named graph to write my Python code, and I will edit it. So I'll just type in my Python code and then explain it to you in the end, so it won't take up much time. Now, as you can see that I've already created a client to my InfluxDB, and then I add in the database COVID-19, and I'll have to pass a variable to read the CSV file, that is COVID-19 data.csv, and then I'll drop the null values. After that, I will iterate through the JSON body, which has 3 fields that we've already talked about. The first one is the measurement field, and I'm going to name this as COVID metric. I also have the tags here. So here I'm going to specify the country and state. We have the country in row 3, so 0, 1, 2, and 3. And we have the state in the row 2. So I'm just going to specify row 3 here and row 2 here. So I hope that is clear. In the fields, we have confirmed, which is in the 5th row, deaths in the 6th row, and recovered in the 7th row. So 5th, 6th, and 7th. This key is a pretty interesting key, the time key. So here, as you can see, the time column is outside the fields. You can add a key which is called as time here, and you can use observation date that is present in the row 1 column. You can see that the observation date is given in the row 1 column, but because it's in the form of string data, we will have to convert it to the timestamp format.
And this is possible only with the help of the datetime Python library. So we can just convert this into UTC timestamp in this line of code. So what it really does is it takes out the time component from the string, and then you can format it in this particular format. That is the month, date, and year. So this is the format that we're going to present it in. So it's %m /%d /%y. So that's month, date, and year. I hope this is clear. Now we'll just quit and execute this code, draft.py. And as you can see here, there are 15,000 rows and 8 columns. Now this is done. It will send a message, OK. I'm going to clear the screen. In some cases, you will have to restart your Grafana server so that the data is incorporated into your application. Else you could just check your databases. So here I'm going to check the measurements, and you can see that COVID metric is present. So select star from COVID metric. I'm going to just limit it to 20 now. And this will show me the time, confirmed cases, the country, the deaths recovered, and the state. Okay. Now that this is clear, we can get back to our dashboard and create a new panel. I'm just going to name this panel COVID-19 India. Okay. Now what I'm going to do is I'm going to select. Now I'm just going to select my InfluxDB1 database, and I'm going to select metric. I'm going to specify the country, and I'm just going to specify India here. And in field, I'm just going to add confirmed deaths, and I'm going to add another field, recovered. Okay. And if you want to show the legend, you can do it, or you can just choose not to. I'm just going to show the legend here. And that's it. You can just save it and apply it. You can see the bar graph. And the other important thing here is you'll have to specify the time. Sometimes it'll just be for today, or, as default, it'll just be for, because this data is from the last year, you'll have to specify the data for the last 1 year, and the graph will eventually display. So I'm just going to apply this. I'm just going to shift my world map above it. I'm just going to stretch this out. Okay, so this looks fine. Now I'm just going to make gorgeous. So I'll just add a new panel, and I will select InfluxDB1 measurement as metric, where country is equal to India. Okay. And the field value here right now will just be confirmed. Now I'm just going to name this confirmed cases in India. Okay. And I don't want to display the panel with a background. So I'm just going to let it be displayed with the background. And now I'm just going to select my gauge. Okay, great. Now, because this is confirmed cases, I want this to be in yellow color. I don't want it to be in any other color. So I'm just going to change the threshold color to yellow, and I'm going to apply. Okay, great. I'm going to add another panel. So this time it's going to be for the deaths, and I'm going to just select gauge. Going to rename my panel title to death cases in India. And as you can already see, the time ranges for the last 1 year. So that's great. This is already in red. I want the death cases to be represented in red. So I'm just going to apply. I'm going to just shift this here and resize it. Okay, great. And the last one is the recovered cases, right? So I'm just going to work on that too. I'm going to select measurement as COVID metric, where country is equal to India, and the field value is recovered. Okay, this is great. I'm going to change the threshold to green. Okay, great. And everything looks fine. Just we will change the. Okay, I'm going to apply. I'm just going to reposition this again. So this looks okay. If you want to move all of these down, you can just pull the world map up and then just pull the COVID-19 cases up too. Now you can see the confirmed cases, death cases, and recovered cases. This is all the mean value.
Now, using the new panel, I'm going to represent 4 states. I'm just going to select measurement as COVID metric, where state is equal to Maharashtra and field value is equal to confirmed. And I'm just going to add more field values, deaths, and then recovered. Okay, great. This looks fine. And I'm just going to name this Maharashtra. Okay, going to represent this in graph. I'm okay with that. I want to display this without a background, so I'm just going to shift this down as much as I can. Okay, this looks okay. I'm just going to make this for 3 more states. COVID metric, where state is equal to Karnataka, field value confirmed, deaths, and finally recovery. Okay, and this is Karnataka, so I'm going to name that, and I want to display this without a background. Looks neat and clean. There's one thing you could do is you could add alias, because you'd want the graph to be represented properly. So this will just add alias. Just going to add deaths here, and finally we will add recovered. Okay, this looks great. Also, I'm going to add alias in the Maharashtra state. So confirmed, deaths, and finally recovered. Okay, and we will apply this. Okay, looks good. So we have 2 more states to work on. We will work on West Bengal. Confirmed. Going to add alias. And then I'm going to add another field, which will give me deaths. And this will also give deaths. I'm going to add another field, recovered, and this I can just write recovered. Okay. And I'm going to just add West Bengal here, display without a background, and apply. Finally, this is our last panel that we're going to work on. And I will add for Delhi. Confirmed. I'm going to add alias. Confirmed. I'm going to add 2 more fields. And I'm sure you must be very much familiar with how this works now. Okay. I'm going to display this without a background. And I'm going to name this panel Delhi. That's it, guys. This is how easy the tutorial is. This is how easy it is to use Grafana. You have your world map, you have COVID-19 analysis of India, you have the confirmed cases, you also have the confirmed death and recovery cases, which is represented in terms of cages. And also you can represent all the state analysis of COVID-19 in terms of a graph. Now, if you want to change the name of your dashboard, you can simply go to dashboard settings and then just change it to whatever you want. So I'm just going to say COVID-19 analysis India. Okay. And I'm just going to save dashboard. Okay, great. And this is all. Now, in the next part, we're just going to learn a little bit about variables. So we're moving on to the last part of this session, and we're going to learn about Grafana variables. If you're not new to programming or coding, you must be very much aware that variables are just placeholder for a value, right? So you can use variables in metric queries and also in panel titles. So what variables in Grafana do is they give you the ability to create more interactive and dynamic dashboards. Let us go ahead and check out how this happens. Now I'm back to my terminal. I'm just going to type in Flux. Now, instead of hard coding things like server, application, and sensor names in your metric queries, you can use variables in place of them. Now, before we move ahead, I'm just going to use my COVID-19 database, and I'm going to write a query, show tag values with key is equal to country, and this will display me a list of all the countries that are present in my COVID-19 database. And this is what exactly variables do. So this is exactly what Grafana allows you to do. If you have multiple identical data sources or servers, right, you can make one dashboard and use variables to change what you are viewing. So what this really does is it simplifies your entire data. Now I'm just going to click on the logo and I am going to, if you remember, I have already mentioned this before, that if you click on the dashboard settings, you will get the option of variables on the left hand side. So I'm just going to click on the variables and then I'm going to add a new variable. I can name this variable whatever I'd like to. I can just name it as COVID countries. So all the rules that we had learned, syntax rules that apply to variables, also applies here in Grafana. So the type is query. You can also use constants, data sources, systems, anything that you'd like. I'm just going to type out the query, right? So I'm just going to use that. And my data source is InfluxDB1. And I'm just going to, type the same query. Now, if I scroll down, it will show me a preview of all the values, right? So all of these values are shown here. You can just add this variable and just display it in a dashboard. That's how simple it is. So if you have any particular values that you'd like to display, so this is what values really does. It allows you to, simplify your data and then visualize it and represent it in Grafana dashboards. You can do this with IoT sensors. You can do it with, if you want to analyze your system's performance, all of that can be simplified with variables. So I'm just going to save this and I can use these variables later on in the session. I hope Grafana variables was easy to understand. With this, we come to the end of today's session. I hope you had a great time understanding about Grafana. I hope this Grafana tutorial gave you a brief overview of how it works, how you can really get started with Grafana in general. And this is just like a simple tutorial. You can create as many projects and demos you'd like to. It's really easy. It's very interesting.
What do you think is the history behind it? What do you think are the major reasons that affected the growth of Selenium? Let's have a look, guys. So, this Selenium was originally developed by Jason Huggins in the year 2004 as an internal tool while he was working at ThoughtWorks. So, Huggins later joined the programmers or the testers at ThoughtWorks and tried to develop Selenium RC. So this tool was developed in the year 2004 by two developers, namely Jason Huggins and Paul Hammond. So it was open sourced in the same year, guys. So Selenium RC was the first one to be found among the WebDriver, Grid, and Selenium IDE. In 2005, Dan Fabulich and Nelson Sproul made an offer to accept the series of patches that would transform Selenium RC into what it is known for today. So in these days, we call it a Selenium WebDriver, right? So Dan Fabulich and Nelson Sproul are the major reason for giving us the idea about how RC works. Now, correspondingly, in the year 2007, Huggins joined Google and also he helped in developing the stabilization process of RC. And at the same time, Simon Stewart at ThoughtWorks developed a superior browser automation tool called the WebDriver. Okay, so this is the tool which we currently use. And also, the current version of Selenium that we're using is 3. But recently in 2009, September or October, I think they had a meeting or a conference related to the version release. And they actually kind of spoke about the new version that is Selenium 4. I don't think it is releasing anytime soon, but yeah, they gave us a hint of that. So yeah, we'll be looking forward to work on Selenium 4 as well. So the current version in the market is Selenium 3. Also in the year 2009, there was a conference, that is a test automation conference, where people tried to merge two products, that is Selenium RC and Selenium WebDriver, to call it as a new project called Selenium 2.0. So this is the second version which was used between 2005 to 2010, I believe. Don't remember the exact time span, but yeah, Selenium 2 was released by then. And in 2008, Selenium Grid was developed by Pat Lightbody. So this was about the history behind the growth of Selenium. As you can see that the growth began in 2004 itself, but to be officially released and to be officially available to people by the name Selenium WebDriver, it took close to 5 to 6 years, right? So this is exactly how Selenium came into the mainframe. Now moving ahead, let's take a look at what exactly is Selenium. Like I mentioned, Selenium is an open source tool which is used for automating the tests that are carried out on the web browsers. Also, it can be reframed in this way. It is an open source portable framework for automating applications, that is mainly web-based applications, and it can be tested across different browsers, namely Chrome, Firefox, Safari, and just not the traditional ones. The tests can also be carried out in different OS platforms, that is Windows, Mac, and Linux. And the Selenium test scripts can be integrated with the tools such as TestNG, JUnit, and so on for managing test cases and generating reports. It can also be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So why exactly software testing or automation testing is required? Today's world of technology is completely dominated by machines, and their behavior is controlled by the software empowering it. Will the machines behave exactly as we want them to? The answer to this is what we call software testing or automation testing. At the end of the day, it is the application's success rate which is going to control your business growth. The same thing can be said even for web applications, because most of our businesses today are completely dominated on the internet, or it completely belongs to the internet. So, this is exactly what is Selenium. Now, moving on, let's take a look at why exactly Selenium is required. Why not any other tool? So, some major uses, I would say, or benefits of using Selenium is it is easy to automate testing across web applications. Suppose you're working on or testing any of the software application, that is web-based application, I say, and you find a bug and you don't know how to resolve it until and unless you've come across Selenium. So Selenium is one such tool which acts like a key to our success rate. So automating testing across web applications is like a really tedious task which can be fulfilled by using Selenium. And also it has a wide variety of language support. If you're comfortable using C, C++, or C Sharp, these are considered as the basic languages, right? Okay, not C Sharp, but still C, C++, Java, Python, right? So these four languages are like the basic languages which can be supported by any of the software. So apart from these four standard languages, Selenium also proudly supports Ruby, C Sharp, Spark, Perl, and many more. All right. Now, talking about implementing the test cases, like I mentioned, automating the testing cases across different web applications or browser is not an easy task. But by using Selenium, you can implement those test cases very easily. And also, you can perform or write the test scripts on different platforms like Mac, Windows, Linux, and so on. Also, one major reason why you should go for Selenium is it is easy to understand and is open source. Open source as in you don't have to pay for this version, it is not a paid version. Easy to understand as in it is explained in simple terms where any normal human being can understand. Now, this was about why we need Selenium. Now, moving on, let's understand what are the major features of Selenium. So I think you guys have understood what exactly Selenium is and how it supports testing across different platforms, right? So these are also considered as features, but apart from that, we'll talk about some notable information related to Selenium. So Selenium can be considered as a leading cloud-based testing platform which helps testers to record their actions and export them as a reusable script and easy to use interface. And like you already know that it supports operating systems, browsers, and different programming languages, right? Also, apart from this, it also supports parallel test execution, which reduces time and increases the efficiency of the test cases. Also, Selenium requires fewer resources as compared to other automation testing tools. You don't have to have a different plugin for each and every test cases that you are working on, right? Apart from this, we also have something called the Selenium commands, which are categorized in terms of different classes, which makes it easier to understand and implement. Also, Selenium WebDriver does not require the server installation as the test scripts interact directly with the browser. Also, so these were some notable features of Selenium. Now, moving on, let's understand the components. So we have namely four components, guys. We have something called Selenium IDE, Selenium RC, Selenium WebDriver, and Selenium Grid. Now let's understand them in detail. So talking about Selenium IDE or Integrated Development Environment is primarily a record run tool that a test case developer uses to develop Selenium test cases. Selenium IDE is a simple record and playback kind of tool which comes as an add-on for Firefox only. But now I think it is also used for a Chrome driver as well. It is used for prototype testing, and the test cases written in IDE can be exported in many programming languages like Ruby, Java, C Sharp, Python, and so on. Edit and debug options along with the record are also available in the IDE. Also, guys, this is an excellent tool for beginners to understand the syntax of Selenium WebDriver. It is also considered as the simplest framework in the Selenium suite and is the easiest to learn, guys. It is, like I mentioned, a Firefox plugin, and you can easily install it on your system. This is exactly why a Selenium IDE was used. Now, talking about Selenium RC, Selenium RC or Selenium Remote Control was the first tool of the Selenium suite. Earlier, it was known as the JavaScript executor, and RC was a tool which made Selenium famous in the market. All the credits to Selenium being a masterpiece or Selenium being very famous around the globe is because of Selenium RC. It was the first tool that provided the support for multiple programming languages. Also, this supported almost all major vendors of browsers like Firefox, Chrome, Internet Explorer, and so on. So the first version was called Selenium 1, followed by which we have Selenium 2, 3, and now I think we're expecting 4 as well in the market. Also, using RC, you can perform cross-browser testing. Alright, so this was about Selenium RC. Now moving ahead, let's understand what exactly is Selenium WebDriver. Okay, so talking about Selenium WebDrivers, Selenium WebDriver was the first cross-platform testing framework that could control the browser from the OS level. In contrast to IDE, Selenium WebDriver provides a programming interface to create and execute test cases. So these test cases can be written in such a way that the web elements on the web page can be identified and then perform actions on those elements. Also, Selenium WebDriver is an upgrade to RC because it is much faster, and it is faster because it makes direct calls to the browser and it does not need a server between the client and the server. RC, on the other hand, needs a RC server to interact with the web browser. So each browser has its own driver on which the application runs. So different kinds of web drivers are Firefox driver, which is popularly called as Gecko driver, Chrome driver, Internet Explorer driver, HTML unit driver, Safari driver, and so on. Also, this supports programming languages like Java, C Sharp, PHP, Perl, Ruby, .NET, and so on. Also, it supports testing across different platforms like Firefox, Chrome, and so on. Also, cross-browsing was introduced in this version. Also, guys, Selenium RC and Selenium WebDriver together was combined to make it called as Selenium 2. So like I mentioned this, I just wanted to remind you guys of it again. Now talking about Selenium Grid. So what exactly is Selenium Grid? Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA, which is a part of the version 1 of Selenium. And also it was used in the combination with RC to run test cases on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on different machines. Parallel execution can be achieved easily with the help of hub node architecture, and one machine will assume the role of hub and whereas the others will be the nodes. Okay, so this is still in use, guys. Grid is used by most of the companies as well, and it works both with Selenium WebDriver and RC. However, maintaining a grid with all required browsers and operating system is a tedious task. For this, there are multiple online platforms that provide an online Selenium Grid access to run your Selenium automation script. So this is about the suite of tools or Selenium components.
So here we will be installing the latest version of Java. So here you must keep in mind that the Java version must be 8 or above. After that, we will be installing the Java from the official website, that is Oracle. Once after the installation, we will also configure Java by setting the path in the system. After that, we will check whether the Java is installed successfully or not. Now let's do the demo. So install Java, we must go to a official website of Oracle. So here, as you can see, we have Java downloads Oracle. So just click on that. And you can see here Java 18 and Java 17 are available now. So we have to download the software according to our operating system. So I am using Windows. So let me go to Windows here. So I'll install here the 64 installer. So let me click on this. One of our folk has asked me a question. Let's see. Okay, Kirti have asked me that whether we can install other sizes too. Yes, according to your system's compatibility, you can install whichever the feasible size is. So you can install 84 installer too. I hope you understood, Kirti. Once it gets downloads, just click on the executable file and it asks you for the setup procedure. Now here it is asking for the installation process. So let's click on next. And this is the path where the Java JDK is installed. So until and unless if you have a good reason to change it, then you can change it, or else I'll suggest you to keep as a default folder. So let's click on next. As you can see here, the Java is successfully installed. Let's close this window. Now let us configure this Java. Now let's go to the File Explorer. Let us find where the Java is installed. So go to C folder, Program Files, and you can see here the Java folder. So double click on that. You can see the version 18.0.2 have been installed. So that is the latest and stable version that is available today. Now double click on this too. So you will find the bin folder here. So this is the main folder. So double click on this too. You can see many files has been installed here. So let us copy the path from this folder. So copy this path. Now go to settings. Find for environment variables. So you can see here edit the system environment variables. Okay, let's click on this. As you can see here, we have the environment variables. So click on that. You have the system variables. So you have to change the path over here. So it will be edited in the whole system. Now you can see the path over here. So just click on that and add a new and paste the copied path over here. Now just click on OK. OK. Now let's check whether Java is installed properly or not. So let's go to command prompt. Now let's type Java space hyphen version to check which version has been installed. Yeah, you can see here 18.0.2 has been installed. Now let's check for Java C. So you can see here the Java has been installed successfully. We have all the Java packages here. So now we have successfully installed Java. Now let's install the second prerequisite, that is Eclipse editor. Here, as you can see, first we have to install or download the Eclipse from the official website. After that, we will get a zip file that has been installed. After that, we have to extract from the zipper file. Then we will be running the application. Now let's see the demo. Now for Eclipse download, we have to go to our official website, that is www.eclipse.org. Now let's click on this link. You can see the Eclipse IDE 2022. So I'll download this. This is the last button download. This might take you a few minutes. So once this executable file is downloaded, just click on this. Okay, now you can see here the Eclipse installer has been installed, and this will give you some of the options to click on. So if you want to work on the Java codes or you want to become a Java developer and work on some codes, then you can click on this. Or you have many other options. You can use C, C++, or it will be feasible for PHP too. So in this session, I will be using the Java developers. So I'll click on this to install. I'll click on install. So let's wait till it gets installed. So in between installation, it might also ask you for the agreement. So you can also agree the policies. And make sure you have checked all these buttons also. So it is very important. So to create a shortcut in your desktop, so if you want to create a shortcut in your desktop, then you can click on this or you can uncheck this. Okay, as you can see, the installation completed successfully. Let's launch this. Now it is asking you for the workspace. Now if you want to keep the default, then you can keep it until and unless you have a good reason to change it. So in my case, I will keep it as it is. I'll launch it. So as you can see here, the editor has been opened. So if you want to create a new Java project, you can click on a create new Java project and you can fill the name, the project name, and you can create some packages, classes, etc. And that will be shown in this session too. So don't worry, stay tuned. So now we have successfully installed both of the prerequisite, that is Java and Eclipse. Now the main concept is Selenium WebDriver. Come, let's see how to install that. The first and the main thing you have to see is the latest stable version. So at this point of time, we have the stable version has 4.3.0. So you can see the latest version whenever you install. And the next thing you have to see is the browser driver. If you are working on Selenium, you have to have a browser drivers to execute some of the code or the Selenium scripts, so that you need some of the browser drivers. And finally, we will also see the configuration of the Selenium on our Eclipse. So let's see the demo. So go to browser and type selenium.org and you will get a Selenium's official website. So click on the Selenium and you can see the home page of Selenium and click on downloads. You can see here the latest stable version is 4.3.0. So just click on this. So this is a jar file that will be downloaded. The next thing that we have to download is the Java client. And if you scroll down, you will get the Java client over here. That is also the version 4.3.0. Just click on that too. Now, after downloading these both, now go to File Explorer, go to Downloads, and I am creating a folder in C drive called as Selenium WebDriver. And now I will move this both jar file as well as the Java client over here. Now, as you can see here, the Java client is a zipped file. So let's unzip this and extract all the files over here. As you can see, we have downloaded the Selenium server jar file as well as the Java client too. Now, Java client is a zipper file, so now I have extracted also. Now, what will I do is I'll go to C folder. Now, I have created a Selenium WebDriver folder inside the C folder. Now, I will copy both of the files over here. So, let's copy this and I will go to C folder. Now you can see here I have created a Selenium WebDriver folder. So I'll paste it over here. Now copy the jar file too. Okay. Now once we have installed both the files over here, now let's go and install the browser driver too. As I'm using Chrome here as a browser, so I will install a Chrome driver. So let's write Chrome driver. So click on the first link here. To check which version are you using, just go to this menu, click on Help and Google Chrome. And you can see the version over here, that is 103.0.5060. We have to install the same Chrome driver version. So that is the reason we checked now. Now let's go to the official website and let's click on this version. And the latest stable version over here is this. So let's click on this version or click on the version which you need. Mine is Windows, and if your operating system is under Linux or Mac, then you can install according to it. So I'll install the Win. As I said you, the Chrome driver is a zip file. So let's extract this over here and copy the extracted file and go to the folder where our Selenium files are located. So let's create a folder over here called Chrome driver. Now paste this Chrome files inside this folder. Okay, now all set. Now this is how we install the Selenium WebDriver. Now let's see the demo with a small example. So now let us go to our Eclipse and start coding with the small example. Okay, now let's start a new Java project. So click on Create New Java Project. So let's write a project name as Selenium Demo 1. So here just make sure the Java SE is minimum of 1.8. So let's finish. So we have created a Java project name. Now let's create a package over here. Right click on this, click on new, and you can see here the package over here, right? So click on that. Let's write package name as Edureka. You can write whichever name you wish to. Now as we created the package here, let's create a class over here. So I'll click on new here, class. So I will give the class name as Selenium script. And don't forget to click this public static void main because it is very important. Yeah. And you can see here the package name is Edureka and the class name is Selenium script and the public static void main. And now let's start writing the code. Now we want the Chrome driver to be installed over here. And yeah, before that, we just include the Selenium files over here. So just right click over here and you can see the build path over here, right? Just click on this and configure build path. And you can see the library over here. Just click on that and add external jar files because we have not added the Selenium jar files till now. So let's click on this, the jar file, and open, then apply and close it. Now we have included the referenced libraries over here. Now let's start writing the code. So first we want the Selenium drivers to be included. So let's write system.setProperty. You can see here set properties. Just write set property. Inside the quotes, just write webdriver.chrome.driver. And after this, just give a comma and include the Chrome driver path over here. So for that, let's go to the File Explorer and go to the Selenium WebDriver folder. And you can see the Chrome driver folder here. Just double click on this and you can see the files over here. Just copy the path and go to the editor again and paste it over here. And please don't forget to write this Chrome driver.exe. Let's close this. Now just write WebDriver space driver, which is equals to new Chrome driver. Close this too. And as you can see, we have an error over here. Just hover on the Chrome driver and you will get a quick fixes over here. Just import the Chrome driver and do the same for the web driver too, and import the web driver. Now we expect the output to be showed as a website. So I will give www.edureka.co as a output website. Now I want to get a edureka.co as a output website, so that just write driver.get and write the website whichever you want to be executed. I will give the Edureka link over here. And next I have to print the title whichever comes over the tab. So I will just print the title over here. For that, system.out.println driver.get title. Just close this too. For automatically quitting of the browser, we just write the driver to quit, just driver.quit. And let's run this and see. Just run. Select the folder to be saved. As you can see, the Edureka page has been opened here. You can see the courses over here too. And the browser got exited automatically. And also you can see the title over here that just got printed from the tab. So this is the final output that we just got. Now I will just take out this code and just run. As you can see here, I just took out the code from that script, and the browser will stay for long time. And until and unless you close that window, the browser does not close. So that is why I took out the code over there. And you see here the website is staying for a long time. That is the reason. And you can see the title again printed over here.
Now let us have a look at what exactly is Nagios and how it works. So Nagios is basically a tool used for continuous monitoring of systems, your application, your services, and business processes, etc. in a DevOps culture, right? Now, in the event of failure, Nagios can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. So I hope you're getting my point. It can alert the technical staff of the problem, and they can begin remediation processes before outages affect their business process or end users or customers, right? With Nagios, you don't have to explain why an unseen infrastructure outage affect your organization's bottom line, right? So let us focus on the diagram that is there in front of your screen. So Nagios basically runs on a server, usually as a daemon or a service, and it periodically runs plugins residing in the same server. What they do, they basically contact hosts on servers or on your network or on the internet. Now, one can view the status information using the web interface, and you can also receive email or SMS notification if something goes wrong, right? So basically, Nagios daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these results change. I hope you're getting my point here, right? Now, if you're wondering what are plugins, so these are nothing but compiled executables or scripts. It can be Perl script, shell script, etc. that can run from a command line to check the status of a host or a service. Now, Nagios uses the results from the plugins to determine the current status of the host and services on your network. Now, let us see various features of Nagios. Let me just take you through all these features one by one. It's pretty scalable and secure and manageable as well. It has a good log and database system. It automatically sends alerts, which we just saw. It detects network errors and server crashes. It has easy writing plugins. You can write your own plugins, right, based on your requirement, your business need. Then you can monitor your business process and IT infrastructure with a single pass, guys. Issues can be fixed automatically. If you have configured it in such a way, then definitely you can fix those issues automatically. And it also has support for implementing redundant monitoring hosts. So I hope you have understood these features. There are many more, but these are the pretty attractive features, and why Nagios is so popular is because of these features. Let us now discuss the architecture of Nagios in detail. So basically, Nagios has a server agent architecture, right? Now, usually on a network, a Nagios server is running on a host, which we just saw in the previous diagram, right? So consider this as my host. So Nagios server is running on a host, and plugins interact with local and remote hosts. So here we have plugins. So these will interact with the local resources or services, and these will also interact with the remote resources or services or hosts, right? Now these plugins will send the information to the scheduler, which will display that in the GUI, right? Now let me repeat it again. Nagios is built on a server agent architecture, right? And usually Nagios server is running on a host, and these plugins will interact with the local host or services or even the remote host or services, right? And these plugins will send the information to the scheduler, Nagios process scheduler, which will then display it on the web interface. And if something goes wrong, the concerned teams will be notified via SMS or through email, right? So I think we have covered quite a lot of theory. So let me just go ahead and open my CentOS virtual machine where I've already installed Nagios. So let me just open my CentOS virtual machine first. So this is my CentOS virtual machine, guys, and this is how the Nagios dashboard looks like. I'm running it at port 8000. You can run it wherever you want. I've explained that in the installation video how you can install it. Now, if you notice, there are a lot of options on the left hand side. You can go ahead and play around with it. You'll get a better idea. But let me just focus on few important ones. So here we have a map option here, right? If you click on that, then you can see that you have a local host and you have a remote host as well, right? So my Nagios process is monitoring both the local host and the remote host. So the remote host is currently down. That's why you see it like this. When I'll be running it, I'll be showing you how it basically looks like. Now, if I go ahead and click on host, you'll see all the hosts that I'm currently monitoring. So I'm monitoring Edureka and localhost. Edureka is basically my remote server, and localhost is currently on which my Nagios server is running, right? So obviously it is up, the other server is down. If I click on services, you can see that these are the services that I'm monitoring. For my remote host, I'm monitoring CPU, load, ping, and SSH. And for my local host, I'm monitoring current load, current users, HTTP, ping, root partition, SSH, swap usage, and total processes. You can add as many services as you want. All you have to do is change the host.cfg file, which I'm going to show you later. But for now, let us go back to our slides. We'll continue from there. So let me just give you a small recap of what all things we have discussed. So we first saw why we need continuous monitoring. We saw various reasons why industries need continuous monitoring and how it is different from the traditional monitoring systems. Then we saw what is exactly continuous monitoring and what are the various phases involved in implementing a continuous monitoring strategy. Then we saw what are the various continuous monitoring tools available in the market, and we focused on Nagios. We saw what is Nagios, how it works, what is its architecture, right? Now we're going to talk about something called as NRPE, Nagios Remote Plugin Executor, which is basically used for monitoring remote Linux or Unix machines. So it'll allow you to execute Nagios plugins on those remote machines. Now, the main reason for doing this is to allow Nagios to monitor local resources, like CPU load, memory usage, etc. on remote machines. Now, since these public resources are not usually exposed to external machines, an agent like NRP must be installed on the remote Linux or Unix machines. So even I have installed that in my CentOS box. That's why I was able to monitor the remote Linux host that I'm talking about. Now, if you notice the diagram here, so what we have is basically the check_nrp plugin residing on the local monitoring machine. This is your local monitoring machine, which we just saw, right? So this is where my Nagios server is. Now, the check_nrp plugin resides on the local monitoring machine where your Nagios server is, right? So the one which we saw is basically my local machine, or you can say where my Nagios server is, right? So this check_nrp plugin resides on that particular machine. Now this NRP daemon, which you can see in the diagram, runs on remote machines, the remote Linux or Unix machine, which in my case was Edureka, if you remember. And since I didn't start that machine, so it was down, right? So that NRP daemon will run on that particular machine. Now there is a secure socket layer SSL connection between monitoring host and the remote host. You can see it in the diagram as well, the SSL connection, right? So what it is doing, it is checking the disk space, load, HTTP, FTP, remote services on the other host, right? And these are local resources and services. So basically, this is how NRP works, guys. You have an check_nrp plugin residing in the host machine. You have NRP daemon running on the remote machine. There's an SSL connection, right? Yeah, you have SSL connection, and this NRP plugin basically helps us to monitor that remote machine. That's how it works. Let's look at one very interesting case study. This is from Bitnetics. And I found it on the Nagios website itself. So if you want to check out, go ahead and check out their website as well. They have pretty cool case studies. Apart from Bitnetics, also there are a lot of other case studies on their website. So Bitnetics provides basically outsourced IT management and consulting to non-profit or small to medium businesses, right? Now, Bitnetics got a project where they were supposed to monitor an online store for an e-commerce retailer with $1 billion annual revenue. It's huge, guys. Now, it was not only supposed to, monitor the store, but it also needed to ensure that the cart and the checkout functionality is working fine. And it was also supposed to check for website defamation and notify the necessary staff if anything went wrong, right? Seems like an easy task, but let us see what were the problems that Bitnetics faced. Now, Bitnetics hit a roadblock upon realizing that the client's data center was located in New Jersey, more than 500 miles away from their staff in New York, right? So there was a distance of 500 miles between where their staff is located and the data center. Now, let us see what are the problems they face because of this. Now, the two areas needed a unique but at the same time a comprehensive monitoring for their dev, test, and prod environment of the same platform, right? And the next challenge was monitoring would be hampered by the firewall restrictions between different application sites, functions, etc. So I think a lot of you know about this. Firewalls is basically sometimes can be a nightmare, right? Apart from that, most of the notifications that were sent to the client were ignored because mostly those were false positives, right? So the client didn't bother to even check those notifications. Now, what was the solution? So the first solution they thought is adding SSH firewall rules for network operations center, personnel, and equipment. Second is analyzing web pages to see if there's any problem or defamation occurrences. The third and the very important point was converting notification to Nagios alerts. And the problem that we saw of false positive was completely removed with this escalation logic, where converting notifications to Nagios alerts and escalations with specific time periods for different groups. Right? I hope you're getting my point here. Now, configuring event handlers to restart services before notification, which was basically a fix for 90% of the issues, and using Nagios core on multiple servers at the NOC facility. And each Nagios worker was deployed at the application level with direct access to the host. So whatever Nagios worker or agent or remote machine we have was deployed at the application level and had the direct access to the host or to the master, whatever you want to call it. And they have implemented the same architecture for production, quality assurance, staging, and development environments. Now let's see what was the result. Now, because of this, there was a dramatic reduction in notifications thanks to the event handler's new configuration. Then there was an increase in uptime from 85% annually to 98% annually, which is significant, guys, right? Then they saw a dramatic reduction in false positive because of the escalations logic that I was just talking about. Then fourth point is estimating the need to log into multiple boxes and change configuration files. Thanks to Nagios configuration maintained in a central repository and pushed automatically to appropriate servers. Fourth point is estimating the need to log into multiple boxes and change the configuration files. And that happens because the Nagios configuration maintained in a central repository or a central master and can be pushed automatically to all the slaves, to all the servers or slaves or agents, whatever you want to call it. So this was the result of using Nagios, right? Now is the time to check out a demo where what I'll be doing is I'll be monitoring a couple of services, actually more than a couple of services of a remote Linux machine through my Nagios host, which I just showed you, right? So from there, I'll be monitoring a remote Linux host called Edureka, and I'll be monitoring like 3-4 services. You can add whatever you want. And let me just show you what's the process. Once you've installed Nagios, what you need to do in order to make sure that you have remote host or a remote machine being monitored by your Nagios host. Now, in order to execute this demo, which I'm going to show you, you must have LAMP stack on your system, right? Linux, Apache, MySQL, and PHP. And I'm going to use CentOS 7 here. So let me just quickly open my CentOS virtual machine and we'll proceed from there. So guys, this is my CentOS VirtualBox where I've already installed Nagios, as I've told you earlier as well. And this is where my Nagios host is running, or you can say the Nagios server is running. And you can see the dashboard in front of your screen as well, right? So let me just quickly open the terminal first. Let me clear the screen. So let me just show you where I've installed Nagios. This is the path, right? If you notice in front of your screen, it's in user local Nagios. What I can do is I'll just clear the screen and I'll show you what all directories are inside this. So we can go inside this etc directory, and inside this, I'm going to go inside the objects directory, right? So why I'm doing this is basically if I want to add any command, for example, I want to add the check_nrp command. That's how I'm going to monitor my remote Linux host, if you remember in the diagram, right? So that's what I'm going to do. I'm going to add that particular command. I've already done that. So let me just show you how it looks. So I'll just type gedit, or you can choose whatever editor that you like. and go inside the commands.cfg file, and let me just open it. So these are the various commands that I was talking about. Now you can just have a look at all of these commands. So this is to basically notify host by email if anything goes down, anything goes wrong in the host. This is for service. Basically, it'll notify if there's any problem with the service through email. This is to check if my host machine is alive. I mean, is it up and running? Now, this command is basically to check the disk space, like the local disk, then the load, right? You can see all of these things here, swap, FTP. So I've added these commands, and you can have a look at all of these commands which I've mentioned here. And the last command you see is I've added manually, because all of these commands, once you install, you get it by default. But the nrp check_nrp, which I'm highlighting right now with my cursor, is something which I have added in order to make sure that I will monitor the remote Linux host. Now let me just go ahead and save this, right? Let me clear my screen again, and I'll go back to my Nagios directory. Let me clear my screen again. Now, basically what this will do is this will allow you to use the check_nrp command in your Nagios service definitions, right? Now, what we need to do is update the nrp configuration file. So use your favorite editor and open nrp.cfg, which you will find in this particular directory itself. So all I have to do is first I'll hit ls, and then I can just check out this etc directory. Now, if you notice, there is an nrp.cfg file, right? I've already added it, so I'll just go ahead and show you with the help of gedit, or you can use whatever editor that you prefer. Now over here, you need to find this allowed host directive and add the private IP address of your Nagios server to the comma delimited list. If you scroll down, you will find something called allowed host, right? So just add a comma and start with the IP address of the machine that you want to monitor. So currently, let me just open it once more. So I'm going to use sudo because I don't have the privileges. Now in this allowed host directory, all I have to do is comma and the IP address of the host that I want to monitor. So it is 192.168.1.21. Just go ahead, save it, come back, clear the terminal. Now save and exit. Now this configures nrp to accept requests from your Nagios server via its private IP address, right? And then just go ahead and restart nrp to put the changes into effect. Now on your Nagios server, you need to create a configuration file for each of the remote hosts that you monitor, as I was mentioning before as well. Now, where you're going to find it in etc servers directory, and let me just go ahead and open that for you. Let me go to the servers directory. Now, if you notice here, there is edureka.cfg file. This is basically the host that I'll be monitoring, right? Now, if I go ahead and show you what I have written here, is basically first what I've done is I've defined the host. It's basically a Linux server, and the name of that server is Edureka, alias whatever you want to give. This is the IP address. Maximum check attempts, the periods, I want to check it 24/7. Notification interval is what I've mentioned here, and notification period. So this is basically about all my hosts. Now in that host, what all services I want to monitor? I want to monitor generic services like ping, then I want to monitor SSH, then I'm going to monitor CPU load as well. These are the three services that I'll be monitoring, and you can find that in your etc servers directory. Over there, you have to create a proper configuration file for all of the hosts that you want to monitor. Let me clear my terminal again. Right, so I hope you have understood this, guys. And if you have any questions or doubts, go ahead and mention that in the comment section. Just to show you my remote machine as well, let me just open that. So this is my remote machine, guys. Over here, I've already installed nrp. So over here, I'm just going to show you how you can restart nrp systemctl restart nrpe.service. And here we go. It's asking for a password. I've given that. So my nrp service has started. Actually, I've restarted again. I've already started it before as well. Let me just show you how my Nagios dashboard looks like in my server. Now this is my dashboard again. If I go to my host tab, you can see that we are monitoring two hosts, Edureka and localhost. Edureka is the one which I just showed you, which is up and running, right? I can go ahead and check out this map, legacy map view as well, which basically tells me that my Edureka is a remote host. Then also I have various services that I'm monitoring. So if you remember, I was monitoring CPU load, ping, and SSH, which you can see it over here as well.
What Azure DevOps exactly is. To understand that, we need to understand what Azure is. And to understand Azure, I would be using this particular analogy. Now, if you talk about power consumption, it's fairly simple. I mean, you consume electricity and you pay for the amount or the units that you've consumed. If you've used maybe 100 units, you'd be charged for 100 units. And the important part here is you're not concerned about where the electricity has come from, who maintains it, how is it generated, how is it brought to your house, and stuff like that. I mean, even if you know about these things, it's not your concern how it is done. I mean, even if you do not have any knowledge about it, you can still survive very well. Similar as Azure or any cloud service provider that is there in the market. Let me tell you how. Now, if you talk about software development, you normally have to take care of a lot of things like building a software, building the infrastructure in first place, having servers in place, making sure that your servers, your resources are monitored and maintained. Now, the problem here is if you are doing all these things, you won't be able to focus on your business. And if you wish to focus on your business, you probably might need to hire quite a few people. Plus, servers and stuff like that is actually costly. What if I could tell you that you could actually go ahead and rent all these services like you rented the electricity and paid only for the units you used? Wouldn't that be nice? Well, this is what Azure does. It is a cloud service provider which actually lets you rent, compute, storage, database, analytics, and a number of other services. You only pay for the services you use and only for the time duration you use those services for. And that is why this analogy, which is very similar to how electricity is consumed and used. I hope the idea is clear to you what Azure is. To give you a little more specific definition, it is a popular cloud service provider which provides services I just talked about, and it is one of the best in the market. It is a Microsoft product, and we all know that Microsoft is a big fish when you talk about software market. And that is why Azure is one of the leading cloud service providers. It is second only to AWS, and it is actually catching up with AWS in a very good way. Now, AWS also has a DevOps approach, and as I've already mentioned, Azure is very much neck and neck with AWS. It also has its DevOps services, and these services that are provided by Azure are very good when you talk about comparing those with AWS DevOps services. Let's try to understand how Azure DevOps services go well with each other, and to do that, let's take a look at some of the components which Azure has to offer to you. Well, when you talk about Azure components, these are the major components which Azure has to offer to you. You have your Azure pipelines, you have your Azure boards, Azure artifacts, Azure repos, and Azure test plans. If you remember the definition of DevOps, I talked about continuous integration and continuous deployment. Let me throw in some light on what it is exactly. Now, when you talk about continuous integration and continuous deployment, what you mean to do here is you wish to continuously build softwares and continuously deploy those to the end users. Again, if there are any releases, any changes that need to be done, those should be implemented right away, and the latest version should be available to all the people that are working on that software. I mean, if I actually go ahead and build a particular software, now if there are like 15 people working on that, and if I make some changes to that software, that change should be given to everyone, right? So this is where continuous integration and deployment comes into picture. It aims at keeping everyone on the same page and ensuring that software development happens at a faster rate. And to do that, you have something called as Azure pipelines. Now, when you talk about continuous integration and deployment, you need a line, maybe a tunnel where you can actually carry out these processes, right? That tunnel, that line, that pipeline is something that is provided by Azure pipelines. I mean, you can actually go ahead and build any kind of software and use different kinds of platforms that Azure supports. And when I say Azure supports, well, Azure supports so many platforms that I believe there is hardly any software or any framework that you wish to use that you cannot using Microsoft Azure. And that is why building pipelines with Microsoft Azure becomes very easy. Now, if you talk about building pipelines in general, it is a very simple and a very easy to implement kind of a process because it is just clicks away when you talk about Microsoft Azure. And once the pipeline is ready, integrating it with different softwares becomes very, very easy. Now, again, if you are building a software, you might be having maybe hundreds of people working on that software. In that case, you need a software or something that would let you keep track of all these things, help you plan better, help you have everyone on the similar pages, and help you keep track of all these things. Now, this is where Azure boards come into picture. It readily integrates with Power BI. Now, if you people know what Power BI is, it is a data visualization and business intelligence tool, and it is one of the best in the market. It is very neck and neck with Tableau, which again is a great tool. And what Microsoft Azure boards do is they let you integrate Power BI into Azure DevOps environment, where you can actually go ahead and take a look at the data in real time and have various graphs, charts, so that your assessing or the way in which you keep track of all these things becomes a lot more easier. Next, we have Azure Artifacts, and what it does is it lets you take into consideration various packages or feeds that you generate. Now, when I say this, you can do that from both private and public resources. Apart from that, whether it's Maven, whether it's Newgen, whatever it is, everything is taken care by your Azure Artifacts. When you're talking about continuous integration and deployment, your repositories become very important. And Microsoft Azure lets you have any kind of repositories that are there. If you take a look at Azure Repos, it has almost everything that is needed to deal with repositories. If you're building a software, it needs to be tested. And with Azure Test Plans, you can do end-to-end testing, and it ensures full coverage for your tests. So these are some of the components that ensure DevOps process is carried out very well with Microsoft Azure. And that is why Azure and DevOps go very well hand in hand. Now let's move further and take a look at the demo part. So guys, in order to understand how Microsoft Azure works or how the Azure DevOps stuff works, we would be switching into Azure portal. Now Azure, as I've already mentioned, is a cloud service provider, and we are going to see how Microsoft Azure can be used to carry out DevOps operations. To do that, you can actually go ahead and visit Azure's website. Just open their website, and then you have this place called as portal where you can click in. Now guys, if you have an account, it would ask you to sign in. Just go ahead and sign into your account and you are more than good to go. For people who are completely new to Microsoft Azure, let me tell you a thing that they have something called as a free tier where you can actually go ahead and create a free account. You have to enter in your credit card details, but Microsoft Azure won't charge you for that. Once you create an account, Microsoft Azure gives you certain free credits which you can use for a particular duration of time. Now, I cannot see my credits here, but normally you can actually go ahead and take a look at the amount of credits that Microsoft Azure has to offer to you. It is somewhere around, if I'm not wrong, it is close to $200 if I'm not wrong. Yeah, that is what it is. So probably you would be able to utilize the services for free. And how do you do that? You use that credit that is made available to you. So if there is a particular service that you want to use, you can pay the bills using the credit that is made available to you, and you won't be charged for the services that you use. There are certain limits on the services that you use. Suppose if you actually go ahead and create a server and you let it open for a long time, create a database on top of it, you might be charged heavily for that. But I would suggest that you actually go ahead and take a look at certain documentation that Microsoft Azure has to offer to you. And as long as you stay in the specified limits, you won't be charged anything. So I would suggest that you actually go ahead and put in your credit card, debit card details and get an account created. Once you create an account, this is what the Microsoft Azure portal or the interface looks like. So we have our account, which is up and running. Now we are going to go ahead and carry out DevOps practices, right? So how do we do that? We switch into DevOps. You can just come to the search console and type DevOps here, Azure DevOps, or you can just go ahead and type Azure DevOps somewhere here. The reason I'm doing this is I want to show you how the interface looks like. So this is what it would look like when you start. And if you click on start free, you would be redirected to this page. Now again, guys, first you need to create an organization. Think of organization as an environment. I mean, if your company is actually planning to build a software, they would be having a structure to do that, right? So if your company is planning to actually go ahead and build a particular software, they would be having a template, a structure to do that, right? So when I say an organization, I'm talking about a structure. How do you create an organization? It is very simple. Here's an option here. If you click on new organization, it would ask you for the name of the organization. You enter the name and your organization gets created. Now that we have an organization, our next step should be to go ahead and create a project. How do we do that? Again, click on project. There would be an option here once you create an organization saying that you want to create a project. You should say yes on it. Again, that is how the interface looks for somebody who has started fresh. If not, this is what it would look like. So I can just go ahead and enter the project name. Let's say demo project for today. I'm bad at naming conventions, so forgive me for that. Description, sample project would do. Again, guys, the complexity of project is not important here. I'm just trying to explain certain stuff to you. So please pardon this simpleness of this particular project. Again, guys, once you do enter in the details, it gives you an option. Do you want it public or private? When you say public, anyone on the internet can have access to it. More of an open source kind of stuff. If not, you can stick to your private thing and you can give access to the people you want to take a look at your project. Having said that, if you select private, you can just say create project and your project gets created. Okay guys, so the project is created. It took a longer while than normal. If your internet is not working that well, at times it takes this time. So once the project is ready, guys, you are actually free to go ahead and do the stuff. Now, these are the components that we talked about. At the bottom, you can see these components. You have your boards, repos, pipelines, test plans, artifacts, and you can actually go ahead and create all of those. Let's start by creating a pipeline first, guys. So all you have to do is say new pipeline. Now again, guys, how do you actually go ahead and create a pipeline? What do you do for that? Do you go ahead and use an existing piece of code that you have? Do you have repositories that you want to do? Or do you want to type in your own code? You can do anything you want. You can use Azure repos, which are made available to you for free. GitHub, we all know, is a popular place to have your repositories kept. And if you wish to do that, you can import repositories from your GitHub as well. To do that, you have to actually just go ahead and click on this icon. That is what I'm going to do in this session. I'm going to use a GitHub repository. So you have to click on this thing and you have to authorize your GitHub repository or your GitHub account rather. Now my account is already authorized with Azure, so I don't think it should ask me for reauthorization. You can actually go ahead and authorize your GitHub account. Once you do that, you're free to actually go ahead and import repositories from your GitHub. Now, if I go to GitHub, this is my demo account. So I have one repository that I have it here. My repositories. You can see this is a Python repository, guys. As I've already mentioned, you can use any platform you want when you talk about Azure. Python is something that is simple and I wish to stick to that. Now, this repository is something that is made available to you by Microsoft Azure as well. Do not worry, I would be sharing in this link. If not, you can visit Microsoft Azure Docs for Azure DevOps and you would get this link as well. So once you have this link, you have to fork this thing into your GitHub. For people who do not know what GitHub is, well, think of it as a storage place where you can actually go ahead and store your repositories. Now, repositories is nothing but it is a piece of code or a software which you can actually go ahead and store it here, which you can give access to others as well. Something that is called as open source, where others can actually go ahead and take in your piece of code, maybe modify it and give it to you, or modify it and use it for their own purpose. So this is what GitHub does. It is a place where you can put in your codes, you can have a master branch for it, and you can give access to certain people who can make changes to that code. Now, how do people make changes to it? They have this option which is called as forking your GitHub repository. When I say forking it, that means I'm actually creating a copy or a branch of this particular repository and I'm using it for my own sake. Once I make changes to it, I can submit those changes to the main repository or to the master branch of it. So this is what GitHub is. And the process which we saw here, it would ask you to authorize your GitHub account. And if you've already forked that particular repository, it would be available here in the suggestion. As you can see, it has been forked here. So I have this repository here, which I've selected. So it opens my YML file, which is there, which I can actually go ahead and edit. What does this thing do? It considers Python Django framework. It tests a Django product or project rather on multiple versions of Python. And it has steps that lets you analyze code, save, build artifacts, deploy them, and more. So this is what this piece of code does for you guys. And won't be getting into the details of what this code does, but again, it's a sample repository. You can actually go ahead and study it a little more. Once you do that, all you have to do is just run this piece of code. As simple as that, guys. You have to run it. What this code does is it creates a pipeline for you. And when I say it creates a pipeline, it lets you probably actually go ahead and make codes, make changes to the codes, and submit those to the master branch. We would be doing that. Do not worry about that. As you can see, Microsoft Azure gives you continuous feedback and update as to what is happening, where it is happening, and how it is happening. This might take maybe half a minute or so because quite a few things that are happening. As you can see, it's telling you what has happened, right? I mean, the processes, you can see the tasks happening. It is performing tests and stuff like that. See, these are the number of processes that have taken place. You've prepared a job. It has initialized an agent to take care of it, initialized the job, got resources for it, used Python version, exported the project path, then it installed certain prerequisites, it ran tests, it published the test results, and then this is what happened. Post job get sources. If you wish to have more details, you can click on this icon and it would give you the details about what has happened here. So you can do that as well. Or you can just probably come back to pipelines and see that there's a pipeline that has been created. Now guys, if I actually go ahead and commit changes to this piece of code, that is my YML file or the files that I have in this repository, those would be reflected here. You can see the status here. We are going to do that, but let me show you some other things as well. If I click on analytics, it should give me analytics of what has happened here, whether there were any failures, whether the code ran properly and stuff like that. Test failures is not available because we do not have a plugin here. When I say plugin, okay, it did not find any test results is what it is saying. So let's just go ahead and do certain things and probably this would be more clear to you guys. Do not worry about that. Going back to the history part. If I take a look at the summary part, it would tell me what has happened here. Test succeeded, build pipeline succeeded, manually queued, and this is what has happened. Now guys, can I just go ahead and put in certain other details? Can I make certain changes here? Let's try to understand what can be done. Now, again, I have this Git repository with me, right? So let's just go ahead and play with it a little and commit certain changes. To do that, first, go to the pipeline. This is the pipeline I'm concerned about. And probably I must be getting certain details that I'm looking for. They're not here. So let's go back a little. Projects, pipelines again. Here you have this option called as status badge. Now, what is the status badge? See, this is what the status badge looks like. It tells that, okay, whether the pipeline you built was built correctly or not. So if you are a developer, you would be wanting your code to be green, right? I mean, everything should be checked green. Everything should be nice and ready and successful. So this is what the badge does. So we are going to go ahead and use this piece of badge to add to our code so that now this is a sample stuff. I mean, it's not that important, but if we do go ahead and make or add this badge to our piece of code, it would show that a certain change was made in the code or in the file, and that would be reflected in the pipeline, something that is important when you talk about CI/CD. So let's do that with this simple example. So I come to the pipelines here, my pipeline, and then I scroll down. You would be having this README file where you can make changes. How do we do that? I say edit. And then I add in a piece of code here. Say, let's add a new piece of code somewhere here maybe. Okay, there you go. Again, guys, do not get into the details of the complicacy of this stuff. It is fairly easy, and do not judge me for that either. I mean, as I've already mentioned, my aim is to just go ahead and show you how the concept or the stuff works. So it is very basic, guys. I've just gone ahead and made some change to this piece of code. I've actually just gone ahead and added the badge here. So I'm just going to go ahead and say commit changes, update README file. Yes, please do that. Commit directly to the master branch, or should I commit it to the new branch that I did? Let's say master branch for now. So the change was committed here. So if I come here and if I just go to pipelines and select my pipeline, open it. Yeah, there you go. The change has been reflected. Update README. So this file was updated. So again, guys, this is what I'm talking about. Continuous integration and deployment. That is what it means. I mean, if I make change to this piece of code and if somebody else wants to access it, it or my software should give me the latest copy, right? So this is what this piece of code is doing. In my pipeline, if I just go ahead and pick a certain piece of code, I make change to it, that change gets reflected. And this is what DevOps does. And this is what Azure helps you do. It lets you bring in the whole GitHub concept into Azure, and it helps you go ahead and work with CI/CD in a much better way. Again, I talked about some other stuff as well. Repos, you have your boards, you have quite a few things that you can do. If you talk about overview in general, you have something called as dashboard. So if I click on this icon here, so I have this dashboard that is created by default. Oh, there is no dashboard here. Or if there is a dashboard, it does not have widgets. So I'm going to add a widget. Let's say I need a widget for build history. So I click on it and I say add. So I say done editing. So if I just refresh this thing, so if I just come here and select this particular pipeline and I say save, it will reflect the changes that has happened, what happened with or what is happening with this particular dashboard or with this particular project. So it would give me details like these. And as I've already mentioned, when you create dashboards, you can actually go ahead and integrate Power BI, which is a very popular business intelligence and BI tool basically. So you can actually go ahead and take in or consider all those features as well. Apart from that, you have all the other stuff that you can actually go ahead and play with. Again, to use analytics or to understand how analytics work with this thing, you actually would have to go ahead and do two things. One, you would have to go ahead and integrate your plugin for analytics. Once you do that, you can go ahead and implement quite a few things. To do that, you can actually come here and you can do quite a few things. You can take your GitHub connections. You can integrate your GitHub with your Azure. You can actually go ahead and integrate quite a few other things. See, you have options like service connections, agent pools, retention, parallel jobs, and stuff like that. So you can take care of all those things as well. Boards, again, you can go ahead and add items here. Items as in you can put in states where you want to put in details for certain things, like there are particular bugs that have particular priorities. Based on your project, you can add in those items saying that, okay, this is the criticality of those items and stuff like that. It is fairly easy. You can just click on create a new item, whether it's a bug, whether it's a feature, issue, whatever it is. You can go ahead and you can add that here. And you can keep track of all those things in the form of dashboards or boards here. Repos, you can actually go ahead and when you click on files, you can see the repos that you're using and stuff like that. You can go to the marketplace and you can take in the repos that Microsoft Azure supports. Pipelines, we've seen what it is. Test plans, you can go ahead and launch proper test plans as well. And you can create your own artifacts or your feeds as well by using Azure artifacts. So yeah, guys, this is pretty much what this session had to offer to you people. We did go ahead and create a pipeline. We saw how to commit changes and how those changes get reflected when you use an Azure pipeline. And we also saw what dashboards are and how do they work.
Now let's talk a little bit about DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with the cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our cloud platform of choice today, which is AWS. So what is AWS? Now back in the day, handling and storing data was way different than it is now. Companies preferred storing data using private servers, and that was obviously for security reasons. But however, with better usage of the internet, the trend has seen a paradigm shift for industries as they are moving their data to the cloud. Now, this enables companies to focus more on core competencies and stop worrying about storing and computation. For example, back in the day, if a streaming platform or a search engine platform, anything with a high volume database suffered a corruption, it would take days before their operations resumed. They would face problems scaling up
and only then would they realize the need for a highly reliable, horizontally scalable, and distributed system is what they need. But now, with cloud services and public cloud platforms, this wouldn't be a problem. Now, since every company has started to adopt cloud services, it can be claimed that the cloud is the talk of the town, and AWS in particular is the leading cloud service provider in the market. AWS, which stands for Amazon Web Services, is an Amazon.com subsidiary which offers cloud computing services at an extremely affordable rates. Therefore, its customer base is strong and it targets everyone from individuals to startups to tech giants running the IT landscape. If you might wonder what cloud computing is basically the use of remote servers on the internet to store, manage, and process data as opposed to an actual physical server or a personal computer to do the same. As we are talking about AWS, it is kind of an IaaS or infrastructure as a service, which basically gives you a server in the cloud that you have complete control over. In IaaS, you are responsible for managing everything starting from the OS completely up to the application you are running. So now that we have discussed about DevOps and AWS, let's move on to our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive lifecycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally code start. So first of all, we have AWS Code Commit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS Code Commit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS Code Commit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS Code Commit repository as you do with GitHub. Again, like Git, even Git pull can be used here to synchronize the files in AWS Code Commit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change.
and it is completely based on user-defined release process models. It also integrates with AWS services like AWS Code Commit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use Code Pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code Pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the Code Pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project, which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now that was all about Code Build. Now finally, let's talk about Code Deploy. Now, AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application, and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which, in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you can choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged, but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline, and I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about Code Pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they're completely unnecessary. On platform, let's pick PHP, and it automatically fills up the platform branch and version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here, it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in code pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now, this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says create pipeline. I'm going to give the pipeline a name. Let's just call it demo pipeline. So as a default, I'm just going to fill in a role name, AWS code pipeline, service role, US East, demo pipeline. Then click on next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS code pipeline repository. You can go ahead and look for it as well. It will be available in the AWS code pipeline's GitHub account. Yeah. And in the branch, let's select master branch and click on next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, success, congratulations, your pipeline has been created. Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has OK health, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now, if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID, So with that, your instance has been deployed and you realize that your demo pipeline has worked.
Let's compare AWS DevOps versus Azure DevOps. So let's talk about the services that it provides. The Amazon Web Services code pipeline is a continuous delivery service for fast and reliable application updates. Code pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. On the other hand, Azure DevOps services for teams to share code, track work, and ship software. Azure DevOps provides unlimited private Git hosting, cloud build for continuous integration, agile planning, and release management for continuous delivery to the cloud and on-premise. It also includes a broad integrated development environment support. In the next comparison, we will talk about what category of tech stack do they belong to. As you can see, Amazon Web Services code pipeline belongs to continuous deployment category of the tech stack, while Azure DevOps can be primarily classified under integrated development environment tools. Now let's talk about the features of Amazon Web Services and Azure. As you can see, Amazon Web Services provides workflow modeling, AWS integration, and it also has some pre-built plugins in it. Whereas Azure, on the other hand, provides agile tools like Kanban boards, backlogs, Scrum boards, and it also provides reporting tools like dashboards, widgets, Power BI, etc. And it also allows you to integrate with Git, which provides free private repositories and pull requests. Now, why do people like AWS is because it is extremely simple to set up, whereas Azure, on the other hand, is a complete package. It's full and it's very powerful. Now, let's move on and check out the uses of AWS and Azure. As I've already mentioned, AWS is extremely simple to set up. It also has several managed services. It can be easily integrated with GitHub, and it also has parallel execution. Deployment is completely automatic, and there are manual steps available, so you're never lost. Azure, on the other hand, supports open source. It also has several integrations. That is, it can be easily integrated with GitHub and Jenkins. It also has several project management features. And the most important plus point of Azure is that it is free for stakeholders. I hope the uses between AWS and Azure are extremely clear. Now let's move on and talk about AWS and Azure clients. So Amazon Web Services is used by companies like PlayHQ, Affirm, Curo Education, UP, Ready4, and Bitbank Incorporation. Whereas Azure has clients like Microsoft, Kingsman Software, Evodeck Digital, Muse, Energy to Market, and QR Point. Now, the next important difference is with what tools that these cloud services can be integrated with. Amazon Web Services, as you can see on the screen, can be easily integrated with GitHub, Jenkins, Amazon EC2, Amazon S3, AWS Elastic Beanstalk, RunScope, and CloudBees. Azure, on the other hand, can be easily integrated with Git and GitHub, Docker, Slack, Jenkins, Trello, and Visual Studio. Now let's move on and compare the salary of an AWS DevOps engineer and Azure DevOps engineer. As you can see on the screen already, the median salary for an AWS DevOps engineer is rupees 4,67,000 rupees, whereas the median salary for an Azure DevOps engineer is about rupees 6,04,000 rupees a year. Let's address DevOps interview questions and answers. There are different topics that we'll be covering in the session today. That is questions on general DevOps, programming, version control, continuous integration, continuous testing, configuration management, continuous monitoring, and finally, containerization and virtualization. So without much ado, let's talk about general DevOps interview questions and answers. The first question is, what are the fundamental differences between DevOps and Agile? So the first feature that we'll be addressing today is the agility. So in DevOps, the agility is seen in both development and operations, whereas the agility in Agile is only seen in the development side. The second difference is between the processes or practices. In DevOps, it involves different processes such as continuous integration, continuous development, continuous testing, etc. Whereas in Agile, It involves practices such as Agile Scrum, Agile Kanban, etc. The key focus area in DevOps is timeliness and quality, whereas in Agile, timeliness is the main priority. The next feature that we'll be talking about is release cycles or development sprints. In DevOps, smaller release cycles are implemented with immediate feedback, whereas in Agile, there is only smaller release cycles. The next feature that we'll be talking about is the source of feedback. In DevOps, feedback is from self-monitoring tools, whereas in Agile, it's from customers. And finally, the scope of work in DevOps is agility and the need for automation, whereas in Agile, it's only agility. I hope the fundamental differences between DevOps and Agile is clear based on the different features that are available. The next question is, what is the need for DevOps? According to me, this answer should start by explaining the general market trend. Instead of releasing big sets of features, companies are trying to see if small features can be transported to their customers through a series of release trains. This has many advantages like quick feedback from customers, better quality of software, etc., which in turn leads to high customer satisfaction. So to achieve this, companies are required to lower failure rate of new releases, increase deployment frequency, shorten lead time between fixes, faster mean time to recovery in the event of new release crashing. DevOps fulfills all of these requirements and helps in achieving seamless software delivery. You can give examples of companies like Etsy, Google, and Amazon, which have adopted DevOps to achieve levels of performance that were unthinkable even 5 years ago. They are doing tens, hundreds, or even thousands of code deployments per day while delivering world-class stability, reliability, and security. The next question is, how is DevOps different from Agile or software development lifecycle? Now, Agile is a set of values and principles about how to produce, that is, how to develop software. Example, if you have some ideas and you want to turn these ideas into working software, you can use the Agile values and principles as a way to do it. But that software might only be working on a developer's laptop or in a test environment. Now, if you want to quickly, easily, and repeatedly move that software into production infrastructure in a safe, simple, and yet efficient manner, DevOps is definitely the way. To do that, you need to understand DevOps tools and techniques. You can summarize by saying Agile software development methodology focuses on the development of software, but DevOps, on the other hand, is responsible for development as well as the deployment of the software in the safest and most reliable way possible. Now, moving on, which are the top DevOps tools? How do all of these work together? The most popular DevOps tools are Git for version control system, Jenkins for continuous integration, Selenium for continuous testing, Puppet, Chef, Ansible are the configuration management and deployment tools, Nagios is used for continuous monitoring, finally Docker is used for containerization. You can also mention any other tool if you want, but make sure you talk about all the tools that you can see on the screen right now. Now, the second part of the answer has two possibilities. Now, if you have experience with all of the tools that I just mentioned, then you can just say that I've worked on all of these tools for developing good quality software and deploying those softwares easily, frequently, and reliably. If you have experience only with some of the tools, then you can just mention those tools and say that I have specialization in these tools and have an overview about the rest of the tools. Now let's talk about a generic logical flow where everything gets automated for seamless delivery. However, this flow may vary from organization to organization as per the requirement. Firstly, developers develop the code and this source code is managed by version control system tools like Git. Developers send this code to Git repository and any changes made in the code is committed to this particular repository. Now, Jenkins pulls this code from the repository using the Git plugin and builds it using tools like Ant or Maven. Configuration management tools like Puppet deploys and provisions testing environment, and then Jenkins releases this code on the test environment on which testing is finally done using tools like Selenium. Once the code is tested, Jenkins sends it for deployment on the production server. Even the production server is provisioned and maintained by tools like Puppet. After deployment, it is continuously monitored by tools like Nagios. Docker containers provide a testing environment to test the build features. I hope how all of these work together is clear. Now let's move on to the next question. What is the difference between continuous delivery and continuous deployment?
Continuous delivery ensures code can be safely deployed onto production, whereas in continuous deployment, every change that passes the automated tests is deployed to production automatically. Continuous delivery also ensures business applications and servers function as expected. On the other hand, in continuous deployment, it makes software development and the release process faster and more robust. In continuous delivery, it delivers every change to a production-like environment through rigorous automated testing. But in continuous deployment, there is no explicit approval from a developer and requires a developed culture of monitoring. I hope the differences between continuous delivery and continuous deployment is clear. You can say so much to the interviewer. He's going to be more than happy. Now, what are the advantages of DevOps? Now, for this answer, you can use your past experience and explain how DevOps helped you in your previous job. Now, if you do not have any such experience, then you can simply mention the technical and business benefits of DevOps. The technical benefits of DevOps is it allows continuous software delivery. There are also less complex problems to fix, and also there is a faster resolution of problems. The business benefits, on the other hand, are it enables faster delivery of features, there is more stable operating environments, and most importantly, there's more time available to add value rather than to fix or maintain. What is the most important thing DevOps help us to achieve? The most important thing that DevOps helps us achieve is to get the changes into production as quickly as possible while minimizing risks in software quality assurance and compliance. This is the primary objective of DevOps. However, you can add many other positive effects of DevOps. For example, clearer communication and better working relationships between teams, that is, both the operations and development teams, collaborate together to deliver good quality software, which in turn leads to higher customer satisfaction. Moving on, explain with a use case where DevOps can be used in industry or real life. There are many industries that are using DevOps, so you can mention any of those use cases like Amazon, Google, Netflix, etc. Or you can simply talk about Etsy. Etsy is a peer-to-peer e-commerce website focused on handmade or vintage items and supplies, as well as unique factory manufactured items. Etsy initially struggled with slow, painful site updates that frequently caused the site to go down. It affected sales for millions of Etsy users who sold goods through online marketplace and risked driving them to the competitor. With the help of a new technical management team, Etsy transitioned from its waterfall model, which produced 4-hour full site deployments twice weekly, to a more agile approach. Today, it has a fully automated deployment pipeline, and its continuous delivery practices have reportedly resulted in more than 50 deployments a day with fewer disruptions. So basically, Etsy employed continuous integration pipeline into their daily deployment activities, and this eventually resulted in more deployments per day. The next question is, explain your understanding and expertise on both the software development side and the technical operations side of an organization you have worked in the past. Now, for this answer, share your past experience and try to explain how flexible you were in your previous job. You can refer this example. DevOps engineers almost always work in a 24/7 business critical online environment. I was adaptable to on-call duties and was available to take up real-time live system responsibility. I successfully automated processes to support continuous software deployments. I have experience with public or private clouds, tools like Chef or Puppet, scripting and automation with tools like Python and PHP, and also a background in Agile. So this is how you can explain your employer about how you have expertise and understanding on both the software development side and the technical operations side of your organization. Moving on, how will you approach a project that needs to implement DevOps? Now, the following standard approaches can be used to implement DevOps in a specific project. So in stage 1, you have to have an assessment of the existing process and implementation for about 2 to 3 weeks to identify areas of improvement so that the team can create a roadmap for the implementation. In stage 2, you create a proof of concept. Once it is accepted and approved, the team can start on the actual implementation and roll out of the project plan. Finally, in stage 3, the project is now ready for implementing DevOps by using tools like version control tools, integration tools, testing tools, deployment tools, delivery tools, and monitoring tools followed in each step.
Now, by following the proper steps for version control, integration, testing, deployment, delivery, and monitoring, the project is now ready for DevOps implementation. Now let's move on to the second part, that is programming. Here I'll be discussing some programs that are commonly asked in a DevOps interview. Without much ado, let's check them out. So the first program that is commonly asked is FizzBuzz implementation. It is a very simple programming task where you have to print the numbers from 1 to 100. And if the number is a multiple of 3, then you should print the message fizz. If it's a multiple of 5, then it should print the message buzz. If it's a multiple of both, then it should print the message FizzBuzz. This is the logic of the program. It's extremely simple and commonly asked too. So FizzBuzz is one program that you should be thorough with. As you can see in the output, the multiples of 3 print fizz, the multiples of 5 print buzz, and the multiples of both 5 and 3, that is 15, prints FizzBuzz. I hope this is clear. You can see that they just used simply an if condition, elif condition, and then simply print the message. So one important programming task that is often asked, that is questions based on trees. So the first one is to detect the mirror of a tree. So here you have to check for 2 trees to be mirror images. So the following conditions must be true. The first one is the root nodes key must be the same. The second condition is the left subtree of left tree and right subtree of right tree have to be mirror images. And the third condition is that the right subtree of left tree and left subtree of right tree have to be mirror images. So here you have a binary tree node, which is class node, and then given 2 trees, say root 1 and root 2, return true if they are mirror of each other. Now the base case here is if both are empty, then just return true. Now if both are non-empty, compare them recursively. Note that in recursive calls, we pass left of one tree and right of the other tree. And this function, this if condition will check that. Then finally, we create the tree and see if both of these are mirror images of each other. If it is true, then it's going to print 1. If it is not symmetric, then it's going to print 0. If neither of the above conditions, like 2 conditions that have been satisfied, if it is true, then root 1 and root 2 are not mirror images. So then you can return false. Now you're creating the tree here and then just checking if it is symmetric. If it is, then it's going to print 1, else it's going to print 0. Because it is symmetric, you can see here that the node has 1 and the left node and right node has 2, 2. Left of left has 3. And left of right has 4, and right of left has 4, and right of right has 3. So it is symmetric, it's going to print 1, and that's your output. The next common question is finding the maximum height of a tree. So here you recursively calculate height of left and right subtrees of a node and assign height to the node as maximum of the heights of 2 children plus 1. So this is what the algorithm says. And first thing you'll have to do is you'll have to firstly create a constructor to create a new node, and that's what you're going to initialize initially. After that, you compute the maximum depth or the height of a tree and the number of nodes along the longest part from the root node down to the farthest leaf node. Then you simply return the maximum height of the tree. Now we're just going to create a tree, and the height will be always +1, including the root. So this is the driver program to test the above function. And once you create your tree, you can simply print the height of the node. And this says 4, which is absolutely right. Moving on, we have to know another important program or logic of the serializing and unserializing a tree. So the question goes by, given the root to a binary tree, implement serialized root, which serializes the tree into a string, and deserialize, which deserializes the string back into the tree. So firstly, you'll have to create the binary tree using the node class. And once that is done, to serialize this tree into a string, you can see the serialize function here. And to serialize it into a string, you can consider the null nodes as hash. Starting from root, depth first search is used to traverse through the tree. Now, if a node exists, its value is appended to the string and the left subtree is traversed. This process really continues until there are no more children left. Then a hash is appended to the array and the recursive function is existed. Then the right subtree is traversed and the same process is followed all over again. The final resulting is string and that is returned. To deserialize a string to form a tree, the first word in the space separated string is considered as the root. When a hash is encountered, it is considered as an empty node and none is returned. In the remaining cases, a new node with a value as the word is formed and the remaining string is traversed. So this function is recursively called until the end of the string is reached. You can see that string after serializing the node is returned and the assert is true. Depth first search is really important. Given a binary tree, you have to traverse it using depth first search using recursion. Unlike linear data structures, which have only one logical way to traverse them, trees can be traversed in two different ways. That is usually depth first search or breadth first search. If you're into coding, I'm sure you must be very much aware of DFS and BFS. Depth first search is basically a technique used for traversing a particular tree or graph. Here, backtracing is used for traversal. That is, in this traversal, first the deepest node is first visited and then backtraces to its parents' nodes if no sibling of that particular node really exists. In graphs, usually there are cycles and disconnectivity. Unlike graph, tree does not contain cycle and are always connected. So a DFS of a tree is relatively very easy. So as you can see here, firstly, we can begin from a node, then traverse its adjacent or children without caring about cycles. And if we begin from a single node and traverse this way, it is guaranteed that we traverse the entire tree as there is no disconnectivity. So you can do this in three different orders: in order traversal, or pre-order traversal, or even post-order traversal. So the first case is to print in order. In case of a binary search trees, in order traversal gives nodes in a non-decreasing order. To get nodes of binary search trees in non-decreasing order, a variation of in order traversal where in order traversals reversed can be used. The next function is post-order traversal, which is useful to get the postfix expression of an expression tree. This is simple too. And finally, pre-order. Pre-order traversal is used to really create a copy of the tree. It is also used to get the prefix expression of an expression tree. I hope this is clear. You're just going to print each of the order in which the binary tree is. So it really traverses the tree in a particular order, and post-order traverses the left tree, then the right tree, and then visits the root. Whereas an in-order traverses the left tree, then it visits the root and then traverses the right subtree. Whereas in pre-order, it visits the root first, then traverses the left subtree, and then finally traverses the right subtree. And then it prints accordingly to that order. So you have a tree of 1, 2, 3, 4, 5, and then accordingly it just prints according to its traversal and how it moves. Recursively, it prints the order of the tree. So here you can see that in pre-order traversal, it first traverses the root, and then it traverses the left subtree, that's 2, and then 4, and then finally it will come back to the right subtree, that is, then it touches 5 and then comes back to 3. The same way in order and post-order traversals is printed too. On the other hand, a level order traversal of a tree is breadth first traversal for the tree. So we're going to use queue. With the help of queues, we are going to implement breadth first search. Here we're going to firstly create an empty queue for level order traversal, and then we will append the queue with the root. We will loop the queue until the length of the queue is greater than 0. We will loop this entire function and we will print the queue's data. Enqueue the node's children, first left then right children, dequeue a node from queue. And finally, we will print the level order traversal of the binary tree. The next important function or program is the topological sort. Topological sorting for directed acyclic graph is a linear ordering of vertices such that for every directed edge u, v, vertex u comes before v in the ordering. Topological sorting for a graph is not possible if the graph is not a directed acyclic graph. So in depth first search, we print a vertex and then recursively call DFS for its adjacent vertices. But in topological sorting, we need to print a vertex before its adjacent vertices. That's the difference between DFS and depth first search and topological sort. We can modify DFS to find topological sorting of a graph. In DFS, we start from a vertex, we first print it, and then recursively call DFS for its adjacent vertices. In topological sorting, we use a temporary stack. We do not print the vertex immediately. We first recursively call topological sorting for all its adjacent vertices, then push it onto a stack. Finally, print contents of the stack. It's important to know that a vertex is pushed to stack only when all of its adjacent vertices are already in the stack. So I hope topological sorting makes sense. So what they really do here is you're really having a function. You have to create a class to represent a graph. Then you are adding a function to add an edge to the graph. A recursive function is called to use the topological sort. So you have to mark the current node as visited and recursively visit all the vertices adjacent to that particular vertex. Finally, you push the current vertex to stack, which stores the final result. And then you have to write down the function to do the topological sort. That is, you repeatedly call the above function. And then you finally call the function to do this topological sort. You also should call the recursive function. Also, you should call the recursive helper function to store topological sorting starting from all vertices one by one. Then finally, you print the contents of the stack. Here we are printing the contents of the stack in a reverse order. So it's 5, 4, 3, 2, 1, 0. You'll have to create the graph and then finally call the function, which will eventually print the graph in a reverse order. I hope this is clear. Moving on to another important topic, that is sets. You'll have to know basic functions like removing duplicates. Here you're defining a function named remove duplicates. Firstly, you're going to convert the array into set and then eventually into a list. You're going to define the array and then print it. So if you know Python, I'm sure you must be very aware of this. Next is to detect duplicates. Here we're simply going to use set, which is going to be traversing through the entire list of elements that you've mentioned. And in this particular list that you've defined, if the count of the data within the set is repeating or has occurred more than once, then you're simply going to not include them in your output. So if the data or the elements within the list has occurred more than once, then it is simply going to keep a count of it and going to display that in its output. Strings are another important topic. So in strings, it's extremely easy. They're simple programs. With the help of slicing in Python, you can reverse a string by using -1, and it's just going to print the reverse of a particular string that you're going to incorporate. So the length of a string can be obtained by using the len method. You're simply going to use it with print, and then it will simply print the number of elements in your string. Another important program that you'll have to be thorough with is permutations. Different kinds of permutation and combination programs can be asked in your DevOps interview. A Python program to print all permutation using library functions. You can use the permutations, you can import the permutations library and then use it. The types of permutations that can occur with the three numbers, say 1 to 3, and this will print the different combinations that can occur with the three numbers, that's 1 to 3. So permutations is another important topic that you must be aware of. A Python program to print all permutation using library functions permutation can be used if you are very familiar with Python. So here, as you can see, I want the permutations of three numbers, 1 to 3. I'm going to define a variable and use the function permutations with three numbers, that is 1 to 3. And this will print out a list of all the possible permutations of these three numbers. You can see the output. So these are some of the programs. Even quick sort, merge sort, those are really important. You'll have to know the basic functions of programs that can be asked. I'm not saying that these programs are compulsorily asked in a DevOps interview, but these are the ones that have commonly been asked. So that's why I have made a list of all of the programs. So I hope this is clear.
And let's move on to the next topic without much ado. Now let's move on to the third part of this DevOps interview questions and answer session. So the first question that we'll be addressing in the version control is, what is version control and its benefits? Now, version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. Version control systems consist of a central shared repository where teammates can commit changes to a file or a set of files. Then you can mention the uses of version control. Version control allows you to revert files back to a previous state. It also allows you to revert the entire project back to a previous state. It can compare changes over time, see who last modified something that might be causing a problem. Also, it allows you to check who introduced an issue and at what time. Now let's move on and talk about some of the benefits of version control system. Now with the version control system, all the team members are allowed to work freely on any file at any time. It will later allow you to merge all the changes into a common version. Also, all the past versions and variants are neatly packed up inside the version control system. When you need it, you can request any version at any time and you'll have a snapshot of the complete project right at hand. Another benefit is that every time you save a new version of your project, your version control system requires you to provide a short description of what was changed. Additionally, you can see what exactly was changed in a file's content. This allows you to know who has made what changes in the project at what time. The last benefit is that a distributed version control system like Git allows all the team members to have complete history of the project. So if there is a breakdown in the central server, you can use any of your teammates' local Git repository. The next question is, describe the various branching strategies you have used. This question is asked to test your branching experience, so tell them about how you have used branching in your previous job and what purpose does it serve. You can refer to the points that I'll be addressing now. The first type of branching is feature branching. A feature branch model keeps all of the changes for a particular feature inside of a branch. When the feature is fully tested and validated by automated tests, the branch is then merged into master. The second type of branching is task branching. In this model, each task is implemented on its own branch with the task key included in the branch name. It is easy to see which code implements which task. Just look for the task key in the branch name. The third type of branching is release branching. Once the developed branch has acquired enough features for a release, you can clone that branch to form a release branch. Creating this branch starts the next release cycle, so no new features can be added after this point. Only bug fixes, documentation generation, and other release-oriented tasks should go in this branch. Once it is ready to ship, the release gets merged into master and tagged with a version number. In addition, it should be merged back into develop branch, which may have progressed since the release was initiated. In the end, just mention that branching strategies vary from one organization to another, so you know the basic branching operations like delete, merge, checking out a branch, etc. The next important question is, what is Git? Git is a distributed version control system. It can track changes to a file and allows you to revert back to any particular change. Its distributed architecture provides many advantages over other version control systems like SVN. One major advantage is that it does not rely on a central server to store all the versions of a project's files. Instead, every developer clones a copy of a repository with a local repository and has the full history of the project on his or her hard drive, so that when there is a server outage, all you need for recovery is one of your teammates' local Git repository. There is a central cloud repository as well where developers can commit changes and share it with other teammates. As you can see in the diagram, the distributed version control has a central repository, and each of the working copy or each of the developer have their own local repositories where they can make changes to regularly. And then if they want to push any of the changes to the central repository where their other teams can look upon it, they can easily do that using Git. Moving on to the next question in version control, how do you push a file from your local system to the GitHub repository using Git? Now, firstly, you have to connect the local repository to your remote repository by using the command git remote add origin and the web address. The example is given below, git remote add origin and the copied web address of my GitHub URL, that is
https github.com kavya github test.git. Secondly, you have to push your file into a remote repository by using the command git push origin master. That is, you're pushing your file into the master branch. The next question is, how is a bare repository different from the standard way of initializing a Git repository? You can either do this by using the standard method, that is by using the Git initialization command git init, and this will allow you to create a working directory. A .git subfolder is created with all the Git related revision history. The second way of doing this is by using the bare way, that is git init --bare. It does not contain any working or checked out a copy of source file. Bare repositories store Git revision history in the root folder of your repository instead of the .git subfolder. This is the difference between the standard method and the bare way. So in Git, how do you revert a commit that has already been pushed and made public? There can be two answers to this question, so make sure that you include both of these because they can be used depending on the situation. The first way is to remove or fix the bad file in a new commit and push it to a remote repository. This is the most natural way to fix an error. Once you've made the necessary changes to the file, commit it to the remote repository. For that, you can use git commit -n and commit message. Type in the commit message. The second way is to create a new commit that undoes all changes that were made in the bad commit. And to do this, you can use the command git revert name of the bad commit. I hope this is clear. Let's move on to the next question. What is git stash? Now, a Git developer working with the current branch wants to switch to another branch to work on something else, but the developer does not want to commit changes to your unfinished work. The solution to this particular issue is git stash. Git stash takes your modified tracked files and saves them on a stack of unfinished changes that you can reapply at any time. The next question is, what is git bisect? How can you use it to determine the source of a bug? I will suggest you to first give a small definition of git bisect. Git bisect is used to find the commit that introduced a bug by using binary search. The command for git bisect is git bisect, the subcommand and option commands. Now, since you've mentioned the command, explain what this command will do. This command uses a binary search algorithm to find which commit in your project's history introduced a bug. You use it by first telling it it's a bad commit that is known to contain the bug and a good commit that is known to be before the bug was introduced. Then git bisect picks a commit between these two endpoints and asks you whether the selected commit is good or bad. It continues narrowing down the range until it finds the exact commit that introduced the change. I hope git bisect and how it is used to determine a bug is easy and understandable. Moving on, what is git rebase and how can it be used to resolve conflicts in a feature branch before merge? According to me, you should start by saying git rebase is a command which will allow you to merge another branch into the branch where you are currently working on and move all of the local commits that are ahead of the rebase branch to the top of the history of that particular branch. Now that you've defined what git rebase is, give an example or explain with an example to show how it can be used to resolve conflicts in a feature branch before merge. Now, since you have defined git rebase, now explain it with an example. If a feature branch was created from master and since then the master branch has received new commits, git rebase can be used to move the feature branch to the tip of master. The command effectively will replay the changes made in the feature branch at the tip of master, allowing conflicts to be resolved in the process. When done with care, this will allow the feature branch to be merged into master with relative ease and sometimes as a simple fast-forward operation. How do you find a list of files that is changed in a particular commit? For this answer, instead of just telling the command, explain what exactly this command will do so you can say that to get a list files that has changed in a particular commit, use the command git diff -tree -r#. To get a list files that has changed in a particular commit, use command git diff tree -r and the particular hash. Given the commit hash, this will list all the files that were changed or added in that particular commit. The -r flag makes the command list individual files rather than collapsing them into root directory names only. You can also say that the output will also include some extra information which can be easily suppressed by including two flags, git diff tree -no commit ID -name only -r hash. Here -no commit ID will suppress the commit hashes from appearing in the output, and -name only will only print the file names instead of the paths. I hope this is clear. Moving on, how do you set up a script to run every time a repository receives new commits through push? There are 3 ways to configure a script to run every time a repository receives new commits through push. One needs to define either a pre-receive, update, or a post-receive hook depending on when exactly the script needs to be triggered. Pre-receive hook in the destination repository is invoked when commits are pushed to it. Any script bound to this hook will be executed before any references are updated. This is a very useful hook to run scripts that help enforce development policies. Update hook works in a very similar manner to pre-receive hook and is also triggered before any updates are actually made. However, the update hook is called once for every commit that has been pushed to the destination repository. Finally, a post-receive hook in the repository is invoked after the updates have been accepted into the destination repository. This is an ideal place to configure simple deployment scripts, invoke some continuous integration systems, dispatch notification emails to repository maintainers, etc. Hooks are local to every Git repositories and are not versioned. Scripts can either be created within the hooks directory inside the .git directory, or they can be created elsewhere and links to those scripts can be placed within the directory. Now let us look at continuous integration interview questions. The first one is, what is meant by continuous integration? Continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. I also suggest that you explain how you have implemented this in your previous job. You can refer to the diagram that is given here. Here, as you can see, developers first check out code into their private workspaces, and then when they're done with it, they commit the changes to the shared repository, that is the version control repository. Then the continuous integration server monitors the repository and checks out changes when they occur. The continuous integration server then pulls these changes and builds the system and also runs unit and integration tests. After this, the continuous integration server will now inform the team of the successful build. If the build or test fails, the continuous integration server will alert the team. The team will then try to fix the issue at the earliest opportunity. This process keeps on repeating, and this is the entire continuous integration pipeline in short. Moving on, why do you need a continuous integration of development and testing? For this answer, you should focus on the need of continuous integration. My suggestion would be to mention the most 2 important points. Firstly, continuous integration of development and testing improves the quality of software and reduces the time taken to deliver it by replacing the traditional practice of testing after completing all of the development. It also allows development team to easily detect and locate problems early because developers need to integrate code into a shared repository several times a day, that is more frequently. Each check-in is then automatically tested. Moving on to the third question, what are the success factors for continuous integration? Here you have to mention the requirements for continuous integration. You should include the following points, that is, continuous integration allows you to maintain a code repository. It automates the build, makes the build self-testing. In continuous integration, everyone commits to the baseline every single day. Every commit that is made to the baseline should be built. Keep the build fast. It is important to test in a clone of the production environment. It also makes it easy to get to the latest deliverables. Everyone can see the results of the latest builds. And finally, it automates deployment. The fourth question, explain how you can move or copy Jenkins from one server to another. Approach this task by copying the jobs directory from the old server to the new one. There are multiple ways to do that. You can firstly move a job from one installation of Jenkins to another by simply copying the corresponding job directory. You can also make a copy of an existing job by making a clone of a job directory by a different name. You can also rename an existing job by renaming a directory. It is also important to keep in mind that if you change a job name, you will need to change any other job that tries to call the rename job. In the fifth question, explain how can you create a backup and copy files in Jenkins. The answer to this question is really direct. To create a backup, all you need to do is to periodically back up your Jenkins home directory. This contains all of your build jobs configurations, your slave node configurations, and your build history. To create a backup of your Jenkins setup, just copy this directory. You can also copy a job directory to clone or replicate a job or rename the directory. I hope this is clear. Now let's move on to the sixth question of the session. Explain how you can set up Jenkins job. My approach to this answer will be first to mention how to create Jenkins job. Go to Jenkins top page, select new job, then choose build a freestyle software project. Then you can tell the elements of this freestyle job. Firstly, optional SCM such as CVS or subversion where your source code resides. Optional triggers to control when Jenkins will perform builds. Some sort of build script that performs the build where the real work really happens. Optional steps to collect information out of the build such as archiving the artifacts and or recording Java doc and test results. Optional steps to notify other people or systems with the build result such as sending emails, IMs, updating issue trackers, etc. Moving on, mention some of the useful plugins in Jenkins. Some of the useful important plugins are Maven 2 Project, Amazon EC2, HTML Publisher, Copy Artifact, Join, Greenballs. These plugins I feel are the most useful plugins. If you want to include any other plugins that is not mentioned, you can add them as well. But make sure you first mention the plugins that are on the screen right now. The next important question is, how will you secure Jenkins? If you have any other ways other than the one that I'm just going to talk about, please mention it. So the standard way to secure Jenkins is firstly to ensure that the global security is on. Ensure that Jenkins is integrated with your company's user directory with appropriate plugin. Also ensure that the matrix or project matrix is enabled to fine-tune access. Then automate the process of setting rights or privileges in Jenkins with custom version control skipped. Limit physical access to Jenkins data or folders. Periodically run security audits on same. Jenkins is one of the most popular tools that are used extensively in DevOps. There are many other ways to secure Jenkins. If you have any other way, you could just explain that, or you could just explain the standard method. Now let's move on to the continuous testing questions. First question is, what is continuous testing? Continuous testing is the process of executing automated tests as part of the software delivery pipeline to obtain immediate feedback on the business risks associated with in the latest build. In this way, each build is tested continuously, allowing development teams to get fast feedback so that they can prevent those problems from progressing to the next stage of software delivery lifecycle. This dramatically speeds up a developer's workflow as there's no need to manually rebuild the project and rerun all tests after making changes. Moving on to the next question, what is automation testing? What are the benefits of automation testing? Automation testing or test automation is a process of automating the manual process to test the application or system under test. Automation testing involves use of separate testing tools. It involves use of separate testing tools, which lets you create test scripts which can be executed repeatedly and does not require any manual intervention. Some of the benefits of automation testing are it supports execution of repeated test cases, it aids in testing a large test matrix, it also enables parallel execution, encourages unattended execution, improves accuracy, thereby reducing human-generated errors, and finally saves money and time. The next question is how to automate testing in DevOps lifecycle. In DevOps, developers are required to commit all the changes made in the source code to a shared repository. Continuous integration tools like Jenkins will pull the code from the shared repository every time a change is made in the code and eventually deploy it for continuous testing that is done by tools like Selenium. In this way, any change in the code is continuously tested, unlike the traditional approach. Let's move on and understand what are the key elements of continuous testing tools. The key elements of continuous testing tools are risk assessment, policy analysis, requirements traceability, advanced analysis, test optimization, and service virtualization. In risk assessment, it covers risk mitigation tasks, technical depth, quality assessment, and test coverage optimization to ensure the build is ready to progress towards next stage. Whereas in policy analysis, it ensures all processes aligned with the organization's evolving business and compliance demands are met. In requirements traceability, it ensures true requirements are met and rework is not required. An object assessment is used to identify which requirements are at risk, working as expected, or require further validation. Also, in advanced analysis, it uses automation in areas such as static code analysis, change impact analysis, and scope assessment or prioritization to prevent defects in the first place and accomplishing more within each iteration. In test optimization, it ensures tests yield accurate outcomes and provide actionable findings. Aspects include test data management, test optimization management, and test maintenance. Service virtualization ensures access to real-world testing environments. So it basically enables access to the virtual form of the required testing stages, cutting waste time to test environment setup and availability. Moving on to the next question, which testing tool are you comfortable with and what are the benefits of that tool? Here mention the testing tool that you have worked with and accordingly frame your answer. I will mention an example with Selenium. I have worked on Selenium to ensure high quality and more frequent releases. Some advantages of Selenium are that it is free and open source. It also has a large user base that helps communities. The major advantage is that it has cross-browser compatibility, that is Firefox, Chrome, Internet Explorer, Safari, etc. It also has great platform compatibility like in Windows, Mac, Linux, etc. It supports multiple programming languages like Java, C#, Ruby, Python, Perl, etc. It also has fresh and regular repository developments. And finally, the most important point, it supports distributed testing. Moving on to the next question, what are the testing types supported by Selenium? Selenium supports two types of testing. The first one being regression testing. It is the act of retesting a product around an area where a bug was fixed. The next one is functional testing. It refers to the testing of software features individually. The next question is, what is Selenium IDE? It is an integrated development environment for Selenium scripts. It is implemented as a Firefox extension and allows you to record, edit, and debug tests. Selenium IDE includes the entire Selenium core, allowing you to easily and quickly record and play back tests in the actual environment that they will run in. Now, include some advantages too in your answer. With autocomplete support and the ability to move commands around quickly, Selenium IDE is the ideal environment for creating Selenium tests, no matter what style of tests you prefer. Moving on to the next question, what is the difference between assert and verify commands in Selenium? First, we will talk about assert command. Assert command checks whether the given condition is true or false. Let's say we assert whether the given element is present on the web page or not. If the condition is true, then the program control will execute the next test step. But if the condition is false, the execution would stop and no further tests would be executed. The verify command also checks whether the given condition is true or false. Irrespective of the condition being true or false, the program execution does not halt. That is, any failure during verification would not stop the execution and all the test steps would be executed. Assert command is best used when the check value has to pass the test to be able to continue to run, whereas verify command is used to check non-critical things. How to launch browser using WebDriver? The following syntax can be used to launch browser. You can use the command WebDriver driver is equal to new Firefox driver function, or WebDriver driver is equal to new Chrome driver function, or you can also use WebDriver driver is equal to new Internet Explorer driver function. Moving on to the last question of continuous testing. When should one use Selenium Grid? For this answer, my suggestion would be to give a small definition of Selenium Grid. It can be used to execute same or different test scripts on multiple platforms and browsers concurrently to achieve distributed test execution. So this eventually allows testing under different environments and saving execution time remarkably. Now let's move on and check out how much you know about configuration management. What are the goals of configuration management process? The purpose of configuration management is to ensure the integrity of a product or system throughout its life cycle by making the development or deployment process controllable and repeatable, therefore creating a higher quality product or system. The configuration management process allows orderly management of system information and system changes for purposes such as to revise capability, improve performance, reliability or maintainability, extend life, reduce cost, reduce risk, and liability or correct defects. Let's move on to the next question, that is, what is the difference between asset management and configuration management? Asset management is concerned with finances, whereas configuration management is concerned with operations. Scope is everything you own in asset management, but scope is everything you deploy in configuration management. In asset management, it is interfaces to purchasing and leasing, whereas in configuration management, it is interfaces to ITIL processes. In asset management, you can maintain data for taxes, but in configuration management, you maintain data for troubleshooting. Lifecycle is from purchase to disposal in asset management, whereas in configuration management, lifecycle is from deployment to retirement. In asset management, relationships are only incidental, whereas in configuration management, relationships are all operational. Moving on to the third question, what do you understand by infrastructure as code? Infrastructure as code is a type of IT infrastructure that operations teams can use to automatically manage and provision through code rather than using a manual process. Companies for faster deployments treat infrastructure like software, as code that can be managed with the DevOps tools and processes. These tools basically let you make infrastructure changes more easily, rapidly, safely, and reliably. Moving on to the most important question, which among Puppet, Chef, SaltStack, and Ansible is the best configuration management tool and why? This depends on the organization's need, so mention few points on all of these tools. Puppet is the oldest and most mature configuration management tool. Puppet is a Ruby-based configuration management tool, but while it has some free features, much of what makes Puppet great is only available in the paid version. Organizations that don't need a lot of extras will find Puppet useful, but those needing more customization will probably need to upgrade to the paid version. On the other hand, Chef is written in Ruby, so it can be customized by those who know the language. It also includes free features, plus it can be upgraded from open source to enterprise level if necessary. On top of that, it is a very flexible product. Ansible is a very secure option since it uses secure shell. It is a simple tool to use, but it does offer a number of other services in addition to configuration management. It is very easy to learn, so it is perfect for those who do not have a dedicated IT staff but still need a configuration management tool. SaltStack is Python-based open source configuration management tool made for larger businesses, but its learning curve is fairly low. Based on all of these tools and which you're comfortable with, you can just mention which is the best tool and why would you want to use it. The next question is, what is Puppet? Puppet is a configuration management tool which is used to automate administration tasks. Now you should describe its architecture and how Puppet manages its agents. Puppet has a master-slave architecture in which the slave has to first send a certificate signing request to master, and master has to sign that certificate in order to establish a secure connection between Puppet master and Puppet slave, as you can see in the diagram. Puppet slave sends request to Puppet master, and Puppet master then pushes configuration on slave. In the sixth question, before a client can authenticate with the Puppet master, its certificates need to be signed and accepted. How will you automate this task? The easiest way to do this is to enable auto signing in puppet.config. It is definitely a security risk, but if you still want to do this, you can firewall your Puppet master, that is restrict port TCP 8140 to only networks that you trust. Create Puppet masters for each trust zone and only include the trusted nodes in that Puppet master's manifest. Never use a full wildcard such as asterisk. Moving on to the seventh question, which open source or community tools do you use to make Puppet more powerful? Over here, you need to mention the tools and how you have used these tools to make Puppet more powerful. For example, changes and requests are ticketed through Jira and we manage requests through an internal process. Then we use Git and Puppet's code manager application to manage Puppet code in accordance with the best practices. Additionally, we run all of our Puppet changes through our continuous integration pipeline in Jenkins using the Beaker testing framework. The next important question is, what are Puppet manifests? It is a very important question, so make sure all of this is set in the correct flow. According to me, you should first define manifests. Every node or Puppet agent has got its configuration details in Puppet master written in the native Puppet language. These details are written in the language which Puppet can understand and are termed as manifests. They are composed of Puppet code and the file names use the pp extension. Now, with an example, you can write a manifest in Puppet master that creates a file and installs Apache on all Puppet agents or slaves connected to the Puppet master. Moving on, what is Puppet module and how it is different from Puppet manifest? A Puppet module is a collection of manifests and data such as facts, files, and templates, and they have a specific directory structure. Modules are useful for organizing your Puppet code because they allow you to split your code into multiple manifests. It is considered best practice to use modules to organize almost all of your Puppet manifests. Puppet programs are called manifests, which are composed of Puppet code, and their file names use the pp extension. Moving on to the 10th question, what is factor in Puppet? Factor gathers basic information, that is facts about Puppet agent, such as hardware details, network settings, operating system type and version, IP addresses, MAC addresses, SSH keys, and many more. These facts are then made available in Puppet master's manifests as variables. What is Chef? Chef is a very powerful automation platform that transforms infrastructure into code. Chef is a tool for which you write scripts that are used to automate processes. What processes? Pretty much anything that is related to IT. Now you can explain the architecture of Chef. It consists of Chef server, Chef node, and Chef workstation. The Chef server is the central store of your infrastructure's configuration data. The Chef server stores the data necessary to configure your nodes and provides Search, a powerful tool that allows you to dynamically drive a node configuration based on data. A node, on the other hand, is any host that is configured using Chef client. Chef client runs on your nodes, contacting the Chef server for the information necessary to configure the node. Since a node is a machine that runs the Chef client software, nodes are sometimes referred to as clients. Finally, a Chef workstation is the host you use to modify your cookbooks and other configuration data. In the 12th question, we're going to discuss what is a resource in Chef. A resource represents a piece of infrastructure and its desired state, such as a package that should be installed, a service that should be running, or a file that should be generated. The functions of resource are: it describes the desired state for a configuration item. It also declares the steps needed to bring that item to the desired state. It specifies a resource type such as package, template, or service. It also lists additional details also, which are known as resource properties whenever it's necessary. They are also grouped into recipes which describe working configurations. What do you mean by recipe in Chef? A recipe is a collection of resources that describes a particular configuration or policy. So a recipe describes everything that is required to configure part of a system. Some of the functions of recipes are: it helps in installing and configuring software components, it manages files, it deploys applications, and it also executes other recipes. How does a cookbook differ from a recipe in Chef? A recipe is a collection of resources and primarily configures a software package or some piece of infrastructure. On the other hand, a cookbook groups together recipes and other information in a way that is way more manageable than having just recipes alone. What happens when you do not specify a resource action in Chef? Here, Chef really just applies the default action. You can explain this with an example. The first snippet is the same as the below resource because create is the file resource default action. What is Ansible module? Modules are considered to be the units of work in Ansible. Each module is mostly standalone and can be written in a standard scripting language such as Python, Perl, Ruby, Bash, etc. One of the guiding properties of modules is idempotency, which means that even if an operation is repeated multiple times, example, upon recovery from an outage, it will always place the system into the same state. Now, what are playbooks in Ansible? Playbooks are Ansible's configuration, deployment, and orchestration language. They can describe a policy you want your remote systems to enforce or a set of steps in a general IT process. Playbooks are designed to be human readable and are developed in a basic text language. At a basic level, playbooks can be used to manage configurations of and deployments to remote machines. In the picture on the screen, you can see an example of playbooks in Ansible. How do I see a list of all the Ansible variables? Ansible by default gathers facts about the machines under management, and these facts can be accessed in playbooks and in templates. To see a list of all the facts that are available about a machine, you can run the setup module as an ad hoc action. That is Ansible-m setup host name. This will print out a dictionary of all the facts that are available for that particular host. How do I turn the auto deployment feature off? The auto deployment feature checks the applications folder every 3 seconds to determine whether there are any new applications or changes to the existing applications and then dynamically deploys these changes. The auto deployment feature is enabled for servers that run in development mode. To disable auto deployment feature, use one of the following methods to place servers in production mode. That is, in the administration control, click the name of the domain in the left pane, then click the production mode checkbox in the right pane. At the command line, include the following argument when starting the domain's administration server. That is -D weblogic.production mode enabled is equal to true. Also, the production mode is set for all WebLogic server instances in a given domain. The last question in configuration management is, when should I use the external stage option? Set external stage using weblogic.deployer if you want to stage the application yourself and prefer to copy it to its target by your own means. Now let's test your knowledge on continuous monitoring. The first question is, why is continuous monitoring necessary? Continuous monitoring allows timely identification of problems or weaknesses and quick corrective action that helps reduce expenses of an organization. Continuous monitoring provides a solution that addresses 3 operational disciplines known as continuous audit, continuous controls monitoring, and continuous transaction inspection. The next really important question is, what is Nagios? Nagios is one of the monitoring control tools. It is used for continuous monitoring of systems, applications, services, and business processes, etc. It is used for continuous monitoring of systems, applications, services, and business processes in a DevOps culture. In the event of a failure, Nagios can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you do not have to explain why an unseen infrastructure outage affects your organization's bottom line. Now, once you've defined what is Nagios, you can mention the various things that you can achieve using this tool. You can plan for infrastructure upgrades before outdated systems cause failures. They can also respond to issues at the first sign of a problem. You can also automatically fix problems when they are detected, coordinate technical team responses, and also ensure your organization's SLAs are being met. How does Nagios work? Nagios runs on a server, usually as a daemon or service. Nagios periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of the scripts and will run other scripts if these results change. Now expect a few questions on Nagios components like plugins, NRPE, etc. What are plugins in Nagios? They are scripts like Perl scripts, shell scripts, etc. that can run from a command line to check the status of a host or service. Nagios uses the results from plugins to determine the current statuses of hosts and services on your network. Once you have defined plugins, explain why you need it. Nagios will execute a plugin whenever there is a need to check the status of a host or service. Plugin will perform the check and then simply returns the result to Nagios. Nagios will process the results that it receives from the plugin and take necessary actions. The next important question is, what is NRPE in Nagios? That is Nagios Remote Plugin Executor. The NRPE add-on is designed to allow you to execute Nagios plugins on remote Linux or Unix machines. The main reason for doing this is to allow Nagios to monitor local resources like CPU, load, memory usage, etc. on remote machines. Since these public resources are not usually exposed to external machines, an agent like NRPE must be installed on the remote Linux or Unix machines. I advise you to explain the NRPE architecture based on the diagram that is given here. The NRPE add-on consists of two pieces: the check NRPE plugin, which resides on the local monitoring machine, and the NRPE daemon, which runs on the remote Linux or Unix machine. There is also a SSL connection, that is a secure socket layer between monitoring host and remote host as seen in the diagram. What do you mean by passive check in Nagios? Passive checks are usually initiated and performed by external applications or processes. Also, the results are submitted to Nagios for processing. They are useful for monitoring services that are asynchronous in nature and cannot be monitored effectively by polling their status on a regularly scheduled basis. They can also be used for monitoring services that are located behind a firewall and cannot be checked actively from the monitoring host. The next question is, when does Nagios check for external commands? Nagios checks for external commands under the following conditions: at regular intervals specified by the command check interval option in the main configuration file, or immediately after event handlers are executed. This is in addition to the regular cycle of external command checks and is done to provide immediate action if any event handler submits commands to Nagios. Moving on, what is the difference between active and passive check in Nagios? For this answer, first point out the basic difference between active and passive checks. The major difference between active and passive checks is that active checks are initiated and performed by Nagios, while the passive checks are performed by external applications. If your interviewer is looking unconvinced with the above explanation, then you can also mention some key features of both active and passive checks. Passive checks are useful for monitoring services that are asynchronous in nature and cannot be monitored effectively by polling their status on a regularly scheduled basis. They're usually located behind a firewall and cannot be checked actively from the monitoring host. The main features of active checks are that they're initiated by the Nagios process. Active checks are run on a regularly scheduled basis. I hope the differences between active and passive checks is clear, and as you can see on the screen, these are the two different pictures of how active and passive checks really work. The ninth question is, how does Nagios help with distributed monitoring? The interviewer will be expecting an answer related to the distributed architecture of Nagios, so I suggest that you answer it by explaining that first. With Nagios, you can monitor your whole enterprise by using a distributed monitoring scheme in which local slave instances of Nagios perform monitoring tasks and report the results back to a single master. You manage all configuration, notification, and reporting from the master while the slaves do all the work. This design takes advantage of Nagios' ability to utilize passive checks, that is, external applications or processes that send results back to Nagios. In a distributed configuration, these external applications are other instances of Nagios. Moving on, explain main configuration file of Nagios and its location. The main configuration file contains a number of directives that affect how the Nagios daemon operates. This config file is read by both the Nagios daemon and the CGIs. It basically specifies the location of your main configuration file. Now you can tell where it is present and how it is created. A sample main configuration file is created in the base directory of the Nagios distribution when you run the configure script. The default name of the main configuration file is nagios.cfg. It is usually placed in the etc/subdirectory of your Nagios installation. Explain how flap detection works in Nagios. Flapping occurs when a service or host changes state too frequently. This causes a lot of problem and recovery notifications. Once you have defined flapping, explain how Nagios detects flapping. Whenever Nagios checks the status of a host or service, it will check to see if it has started or stopped flapping. Nagios follows a procedure to do that. Firstly, it stores the results of the last 21 checks of the host or service, analyzing the historical check results, and determines where state changes or transitions occur, using the state transitions to determine a % state change value for the host or service. Finally, it will compare the % state change value against low and high flapping thresholds. A host or service is determined to have started flapping when its % state change first exceeds a high flapping threshold. A host or service is determined to have stopped flapping when its % state goes below a low flapping threshold. Now, what are the three main variables that affect recursion and inheritance in Nagios? Name, user, and register. Name is a placeholder that is used by other objects. Use defines the parent object whose properties should be used. Register can have a value of 0, indicating it's only a template, and 1, which is an actual object. It's important to know that the register value is never inherited. I hope the three main variables that affect inheritance and recursion in Nagios is clear. Moving on. Let us understand what is meant by saying Nagios is object-oriented. One of the features of Nagios is object configuration format, in that you can create object definitions that inherit properties from other object definitions and hence the name. This basically simplifies and clarifies relationships between various components. Now, the last question in continuous monitoring is, what is state stalking in Nagios? State stalking is used for logging purposes. When stalking is enabled for a particular host or service, Nagios will watch that host or service very carefully and log any changes it sees in the output of checked results. It can be very helpful in later analysis of the log files. Under normal circumstances, the result of a host or service check is only logged if the host or service has changed state since it was last checked. Now we're moving on to the last topic of today's session, and let's see how much you know about containers and virtual machines. So what are containers? Containers are used to provide consistent computing environment from a developer's laptop to a test environment, from a staging environment into production. A container consists of an entire runtime environment, an application, plus all its dependencies, libraries, and other binaries and configuration files needed to run it, bundled into one package. Containerizing the application platform and its dependencies removes the differences in operating system distributions and underlying infrastructure. Now let's move on to the second question and discuss what are the advantages that containerization provides over virtualization. Containers provide real-time provisioning and scalability, but virtual machines provide slow provisioning. Containers are also lightweight when compared to virtual machines. Virtual machines have limited performance when compared to containers. Containers have better resource utilization compared to virtual machines. These are some of the advantages that containerization provides over virtualization. Moving on, how exactly are containers, that is Docker in our case, different from hypervisor virtualization? What are the benefits? Hypervisor virtualization in default security support are to a great degree, but containers have a slightly less degree over here. In a hypervisor virtualization, the complete operating system plus applications are in memory on disk, whereas in containers, only the application requirements are on disk. Time taken to start up is substantially longer in hypervisor virtualization